Hello, everyone, and welcome to the Azure Developers .NET Day 2024. My name is Hailey Huber, and I am so excited for this opportunity for .NET developers to explore the latest Azure features tailored for their applications, enhancing productivity and cloud building capabilities. It's a day filled with expert insights on advanced cloud development, covering AI, app development, data services, and so much more, all aimed at elevating developer experience and efficiency. Let's take a look at the agenda today as a brief intro on what we're going to be seeing. We're going to start the day off with an hour of AI, which is always exciting, followed by cloud native and data services sessions. After that, we'll be going to developer productivity and app development. These are really great ways to end the day with a lot of information on how to make the most of all of your services. Now, we're going through this quickly so that we can make sure that we get to the sessions getting started, but if you'd like to reference the agenda later on today, the link is right here at aka.ms/AzureDevelopers/.NET Day. We also have a lot of great other links for you to check out, including the Azure Developer Hub, which has a lot of great resources for developers looking to use Azure, from beginner to more advanced, with lots of code samples that you can use to get started right now. Today's agenda can be found there, as well as session links can be found at AzureDev/.NET Day/learn more. So we'll have a lot of great links from the sessions on how to start using the code that they share. All those will be included in those session links. Now, of course, we can't forget about the Cloud Skills Challenge, which is a very exciting way for you to take the skills that you learned today and start winning awards. And Cloud Skills Challenges are just one of my favorite things to do. Now, before we get started, I just want to say thank you to all of our wonderful speakers and producers who are helping make this a wonderful day. Throughout the day, you'll have the opportunity to engage directly with these speakers, ask them questions, and connect with fellow developers. Don't forget to subscribe to the Azure Developers channel. These experts come on weekly to talk about the products, any new updates that are going on with their services, and you can directly ask them questions because they're live. So today, grab your virtual seat, buckle up, and let's take your cloud development skills to the next level.
Hello, everyone. My name is Bruno Capuano. I'm part of the .NET Cloud Advocates teams, and I am here today to share some practical and I hope fun AI coding tips with you. And hey, I hope you really get the idea of this because it all started when my friend Gisela, she may or may not be a superhero. She asked me if she can use AI to help her in her day-to-day. And by the way, this is not in the superhero side. This is on her personal side. She's a programmer. So I was super happy because I said, yes, you know what? We can do a lot to help. So we started to talk about, hey, this is Azure AI Studio. Here you can deploy and use in chat or completion modes models like GPT-4 or GPT 3.5 or more. You can chat with this. She asked me, okay, how about if I want to write an out of office? Like with this prompt, with a story that needs to be in English, using emojis and more. And hey, this all works. So she was very happy, say, okay, I like the AI part, but how do we use this? How do we integrate this with our day-to-day coding? And also, if I want to use an external API, like in example, this superhero API, how we can use it. So the whole idea is you can use this using semantic kernel. And this is a notebook, a polyglot notebook, that is going to show the basic steps to use this, to create your own prompt, to use your own functions, to use external functions and more. And you are going to find later a repository with all of the steps here that you need. But the whole idea is that what we have here is, first of all, we need to install semantic kernel. I am going to start to install the package, the NuGet package of the version 171. And then this is a kernel. This is a semantic kernel. So what we are going to do, we are going to create a kernel. And we are going to add one service. In this scenario, we are going to add an Azure OpenAI chat scenario. And this is important. We can add Azure OpenAI, we can add OpenAI APIs, or even local models to work with this. And then we start to work with plugins. And remember, my friend Gisela, she said, you know what? I want to have the chance to write my own prompt. Like we say before, like we have here, write an out-of-office message. where we have a hero, where we have an input. And the whole idea is that all of these prompts lives in folder. So if we go here and we see semantic function, we have here a writer plugin with a couple of folders here and subfolders, a fun plugin with a joke inside. And each one of these plugins has first a prompt, and then we also have a configuration. And the configuration is basically what we can also do in Azure AI Studio. When we run here our chat, we have some parameters. If you take a look here at the parameters panel, we can basically modify the temperature, which is how creative the model should be, also top priorities and more. If we want to do this, but programming, what we can do is, hey, we create a plugin that is going to have a prompt. In this case is write a joke in English, and then we are going to have the configuration here with the tokens that we want to use, temperature, and more. So going back to the code, the whole idea is that, hey, we can create variables to pass to the prompt. In this case, tell me an April Fool's joke. We are in April for Batman. And when we run this, we are going to have the kernel where we register Azure OpenAI chat completion calling this prompt, and it's going to generate a joke. By the way, the jokes are not very good. Sorry about that. And we can make this a little more complex. We can start to write very big prompts, like an example, tell a story, a spring story for Superman. And I have here a very long story. Once upon a time in the bustling city of Metropolis, this is going to work and get here. Or like an example, I want to create an out-of-office message for Christmas for the superhero Hulk. Let's run this one. And in this one, we are going to write also a function called write long story that is going to pick up the whole story and it's going to split. And take a look at this. This prompt is a good one because this is Hulk getting away for Christmas. And it's going to also say that, hey, when I am not here, if you need assistance, in the meantime, you can reach my good friend Thor. Why is that? Because in the prompt, when we define what we need to do to write this out of office, we are also going to say, hey, you must offer help for another superhero in your absence. So we can define how far we can go here. So right now, we have a lot of plugins that we can define using prompts. But also remember that Gisela asked me, hey, if I want to integrate my own information, I have my own system, and I want to call this. So we have this superhero API. It's a public API. So we also have a function here, a C# class function that is going to call this API in HTTP request, and is going to ask for information for a superhero. Part of this information, let's take a look at Batman. It says the power stats, the biography, the alter ego, the real person behind the superhero, and we have more. So we have here, Batman is Bruce Wayne. And the whole idea is that we can also call this function in semantic kernel. So we can invoke the hero info as part of our kernel. Remember, the kernel is the part where we are adding all of this functionality. And then we are going to ask, hey, you know what? Give me the alter ego from Wonder Woman, which is Diana Prince. Or let's try another one. Let's go for Iron Man. And Iron Man is going to be Tony Stark. So we have all of our pieces together. And this is the moment that Gisela asked me, okay, but when I have all of this, how can I put it all together? How can I ask, you have this intelligence to create stories, messages, jokes, get alter ego. How can I ask something more complex to put it all together? We have the planner. And the planner is an amazing piece that we have in semantic kernel that is going to allow us to put it all together. So let's install first the NuGet package, and then let's create a planner. There are different types of planner. Right now, we are going to use the handlebars. And then, this is the important part. I have a request here, and this is kind of a long request. I would like you to tell me a joke about Batman, and with the joke, create an out-of-office message. You see here, we are going to use different plugins that we have. So let's ask semantic kernel to create a plan. When semantic kernel put all of the pieces together, analyze the request, and create the plan, we have here a simple plan that is going to say, first of all, it's going to create a joke, and then it's going to use the joke in the out-of-office message. So let's take a look at the full execution here. Once we have this, we have, hey, hello, I'm out of the office fighting the crime with Batman. Here is a joke for you. Why did Batman and Robin? It put it all together. And remember, we can also ask to use a native function like the one that we had to have the real identity of a superhero. So we can ask something like, hey, I would like you to find out Iron Man's alter ego and then create an out-of-office message for Iron Man, sending with his alter ego. So now we are going to mix native functions and plugins. When we run this, it's going to generate the steps. We can see here we have more steps. So the first one is get the superhero, which is Iron Man, then the alter ego, then create the message, and then put the message. We have all of the steps together. And if we run all of these all together, we are going to have a very small story, which is, I am out of the office for urgent matters. Please contact Pepper Potts, Tony, which is nice because Pepper is Tony's assistant and Tony Stark is Iron Man. But everything is all together here in semantic kernel to do this, to work like this. And as I said, everything that we just seen is available and it's using semantic kernel because semantic kernel makes it really, really easy everything that we see. Calling APIs, internal APIs that you have, invoking and using OpenAI services, Azure OpenAI services, any type of language model is amazing. If you want to know more, if you want to follow the steps of everything that we do in a longer way with a lot of descriptions and more, we also have this repo available, which is aka.ms/EVSK heroes repo. So you can get there. And I strongly advise you to also go to the semantic kernel blog to get the latest information here. So, hey, I hope you really like this. This was a fun one. I really love to enjoy this to help my probably hero or not superhero. We don't know, I can't tell. But this is my contact info, and I hope that you enjoy the rest of the event. Thanks.
Thank you so much, Bruno. I feel like I need to step up my out of office message game now, although I'm not a superhero, but I love learning about practical ways that we can use AI in our day-to-day experiences. So that was a wonderful session on just practical and fun. I did think that was very fun with the superheroes from Bruno. We're going to move into our next AI session, which is on GitHub Copilot. And I love being able to integrate it into database development because data is our currency. It's what we use. And so I'm really excited to learn about how we can actually use AI and our data together. So I would love to welcome Subhojit to the stage. Hello, how are you?
Hi, I'm great.
All right, well, I'm super excited to hear what you got to share. Can you hear us?
Yes, I can hear you.
Okay, perfect. All right, yeah, I'm super excited to learn from you. So take it away.
Cool. Everyone, welcome to .NET Days. The topic for our presentation today is GitHub Copilot for SQL. I would just run you through what kind of AI, how you can integrate AI into your regular database development. I am just... Yes, navigating through the slides. Hi, I'm Subhojit. I am in Microsoft for the past 2 years. I'm product manager working on SQL Server data tools, SSAS and SSRS in Visual Studio. These are my coordinates. I would be glad if you give me feedback on my products as well. This is what I would be talking about in the session. So just in case you feel that this is not something you are looking forward to, then it's perfectly fine. You can drop off from the session. Okay, so with this, I would want to start with a short question. Like, I know there are people who are SQL Server veterans, like people who have been using SQL Server from a time when I was learning coding. So anyone, if you want to share, what was the first version of SQL Server you used? You can use the chat. I am checking. Anyone? Six 6.5, 7. Okay, that was long back. So the way SQL Server or coding in SQL Server used to happen in those times are very different from the way we code now. So I'll take you back to the first coding class that you had in your college or anywhere where you learned coding from, and the instructor might have told you that, before you write a piece of code, you're expected to write a comment. That comment is for people who would look at the code at a later point of time, or even you, if you want to look at the code at a later point of time and understand what you meant. um, Fast forward to 2023, with the revolution of artificial intelligence, you are in an era where you're only expected to write that comment, and we would write the code for you. So I'll just run you through a very short demo. What I'm intending to show in the demo is we'll create two tables. One is customer, one is order. We'll fill in data. We'll show you that data, and we'll delete these tables, and we'll not write a single piece of code. We'll do everything with the help of GitHub Copilot. So starting with the demo, we write a comment. We write a comment where we want the table that we want to create, along with the columns that we want to create. Like if any column if we want to create any column as a primary key, we mention that. And similarly, a table is created. When we write a piece of comment and we press enter, the entire prompt is shown. When we press a tab, then that prompt becomes a code. As you see, then when we execute this code, we are able to get the code being executed successfully. Now, we would go ahead and fill in a few rows in these tables that we just created. We write that prompt for the same, and we see that um, Copilot is able to generate codes, and we have the values. Automatically, the next prompt which you're expected to write, Copilot is saving you from writing that as well. You can just press a tab and the prompt fills in, and the same prompt gives you the answer of the code that you're trying to find. We'll execute this code. We see that it is perfect on the syntax and it is able to generate what you're looking for. Now we have created the table. We have filled in the data. We want to see the data. But you see, Copilot is again trying to guess what you might want to do. It asks you whether you want to do a stored procedure, but no, you don't. You want to see the customer table. So it gives the select statement, which shows you the customer table. Similarly, I have given the prompt for the orders table as well. And we see that exactly the data that we have just filled, we are able to see the data here. Similarly, we'll again go ahead and delete these tables. We write the prompt. We had an extra 2-3 characters before. We would remove this. It becomes a perfect comment. Once we enter, we get the code for deletion. And here we go, we have deleted it. So you see that we actually did not write even a single line of code while we executed this entire program. This might sound super simple, but this is just to give you the flavor of what we are trying to achieve. I'll go into some more complex things after explaining what GitHub Copilot is. So although GitHub Copilot has multiple use cases, one of them is to provide an autocomplete style suggestion from an AI pair programmer to generate snippets of code based on the comment that you've written within your developer IDE. Basically, you write the code in natural language, English, and we generate a snippet of code in the language that you're expecting the answer in. So we currently support all the major IDEs. Whatever IDE you're using, we have support of that. And the IDEs that you don't find the support of, we are working towards bringing support on that. A few prerequisite that you would require after the presentation, if you're really happy and you want to try this out, all you need is a GitHub account, a subscription to a free trial of GitHub Copilot, or just in case you want to go ahead with a paid subscription, the extension of GitHub Copilot added to the IDE of your choice, and like very importantly, a curiosity to experiment with AI. Remember, this is Copilot. You are still the pilot. You cannot let the Copilot run the flight, right? So you have to understand it. You have to empathize. You have to understand what kind of replies you are wanting versus the replies Copilot is giving, uh, and then take the decision whether you would take that snippet of code or not. This is a very short demo where I show how a GitHub account can be created and how you can go ahead and try Copilot. I've used my college email ID. So anybody from hi to them. So we create an account on GitHub and there are a few questions which you got to answer. You press continue and we see that yes, we have been able to create a GitHub account successfully. Now you go ahead in the GitHub account, you see and you search for Copilot. You have the Copilot documentation here. In that you would go ahead and try Copilot. Now when I show you the trial of GitHub Copilot.
Seems like we lost our presenter, but he will be rejoining here in a second. But while we're waiting for him to reconnect, I would just like to share again the schedule session here. And so we have a bunch of great sessions coming up. If you want to look at the session while we're presenting, here are all the agenda sessions and schedules for today. Here's just the big link so that you can access it. This is actually the agenda link. The other link is the link to all of the links that everyone is sharing in their presentations. And so Bruno shared a few how to access things and how to try things out. So definitely go check that out, because our goal here today is to show you the cool capabilities of Azure for .NET developers and let you go try it out in real time and start figuring this out. Oh, you are back. Welcome back. I think we lost you there for a second.
Yes, I'm back. I know I'm trying to share my screen. I'm on the office internet and I have absolutely no idea why it went off.
No worries. I
Let me
think
know
if
you're
there's
able
at
to
least
see
not
my
one technical
screen.
issue, it doesn't count as a dev conference.
Yes, there was a time when the lights
right.
went dim while I was presenting. So I again had to move around and get the lights on.
All right,
So
you are back
yes,
and good to
if
go.
I am back. Perfect. So I just talked about if you're able to get GitHub Copilot, then install the GitHub Copilot extension in your favorite IDE. I see some questions regarding SSMS. Erin Stiletto would be the right person to ask questions regarding when it will come in SSMS. But trust me, we're working on it. Um, yes, I'm able to navigate. So GitHub Copilot currently has 3 SKUs. One is Copilot for individual, which is mostly designed for individual developers. It integrates within your editor, and it is a single person SKU that we have. Then we have Copilot for business, where we have some additional functionalities like an admin seat management, policy controls, an integrated billing and usage report, and a telemetry policy where you can see what kind of usage you're having. Then we have Copilot for Enterprise, where we have an enterprise level admin experience, an org level admin experience, and an end user experience. We also have a way in which you can block public codes. And what I essentially mean is GitHub basically finds codes from all around the web and then tries to provide a suggestion. In an enterprise, you might want to keep your coding practices of the organization intact, and you can set it up for your enterprise. Navigating through the model in a very short span of time, when a user writes a prompt in natural language, it takes some code before and some code after that cursor, and this is transferred to the proxy service, which is basically Copilot, um, where we check for any personally identifiable information, any kind of hate speech, any toxicity, and it classifies the code based on what language you're trying to find. Then it sends this information along with the natural language prompt to the model. The model is basically the GPT model that we are considering. The model sends back a code which is checked for code quality. There can be different vulnerabilities in a code which might lead to SQL injection or you know, any security vulnerabilities. That is again sent back. Model gives another code. We do a basic pruning. We see if there's any duplicate, and then we show a suggestion in the code editor. So you can understand that there are a lot of steps which go in between before a suggestion is shown to you. And that happens in a flick of a second. So you can understand how fast AI is moving. I'll go ahead and show you a few more demos where I'll show you some complex examples, what you can perform. Anybody who's new to it, who's new to SQL, this can be of real help. Anybody who's a .NET developer or in C Sharp, they can find some, you don't need to go into the syntax of SQL if you want to, use it for a specific purpose. So in the first demo, we would be using the Wide World Importers database, which is an open source database. And we are trying to run a query which requires a join between two tables there, purchase orders and purchase order lines table. And the output that we are wanting to see is basically for a specific supplier ID that we want to see the output for. We write the entire prompt in natural language, and we see, once we press enter, we see a snippet of code. We press tab, we press enter, again we press tab, we press enter. So we basically, when you're pressing a tab, you basically accept the code suggestion which is given to you. When you press enter, you want to see the next suggestion. As you see that we are able to see the exact details that we wanted. So these are the few columns that we wanted to see: the stock item ID, description, expected delivery date, and order date were the columns that we wanted to see for supplier ID 4. And we can see that we are able to generate that code. Now, while it is, you might think that whenever you're trying to run a code like this and you just write the natural language prompt, it would understand whatever objects you have in your database and it would generate the query. Well, AI is not that intelligent yet, and we need to help it a bit. So here in this example, I'll show you that first I'll use a specific query to run a piece of code and show this in Azure Data Studio, and then take you to a different editor where the same natural language prompt would generate a different result. And then I'll show you how you can mitigate that and how you can get the same results in that other editor as well. So this is the natural language input that we are giving. This is the comment. Since it's a long comment, so I had to put it in 3 lines. We are using the purchase order lines table, and we are using purchase orders table to have the join. So the join expects a between clause and an and clause to join two tables. So we see that Copilot is switched on, and we go ahead and run this prompt. We see that the select statement comes with two different tables, and with the joint condition, which is specifically mentioned, with the where clause, between, and and clause. Once we run it, we see that it is running as expected. So description, expected unit, and the other columns were there. Now we go to Visual Studio, which is SQL Server Data Tools, and we run the same prompt. We see that it is the structure of the answer that it generates is same. It has a select statement, from, on, where, between, and, but the objects that should be there are missing, or it is identifying different objects. Because as you might remember, I said that before, the prompt, it checks the code before and after. So we need to give some brain into this AI. We need to paste the data definition language, which you can go, a script is create, and you can find it here. you paste the data definition language of that table, of both the tables which are used in that join. So I'm using the purchase order tables and the purchase order lines table. I paste both of these tables before that prompt wherever I'm giving. You see the purchase orders and the purchase order lines table. There was one dash which was missing. Yes, I removed the previous piece of code which it had generated, and I try it again, and we see that it is able to generate the code that we are expecting. We'll still don't trust it. We'll try and run it. We see that we get the same output that we are expecting in Azure Data Studio. So you can understand that if we're able to push in the data definition language or push in some brains, put in the context into Copilot, Copilot should be able to generate the exact same result. So while you are experimenting it out, while we are experimenting different types of prompts, this is something which might really help you in identifying how you can tweak with it and how we can understand, because Copilot in general do not have the context of the database. We are not going through your data because a database might have n number of objects and tables. So if you really want to do a join or some complex operations, this can be really helpful if you're not getting the right answer that you're expecting. With some of the use cases, I know that making a code better is one of the biggest challenges that we face, and Copilot can really help you there as well. So Copilot can help you with performance optimization, and I would give you um, basics of how it is done. A few terms that we would be using is SQL Server parse and compile time and SQL Server execution time. So if you look at the first message which is there, the parse and compile time, this is something which we would actually look. So the parse time is the time to prepare the query by syntax check, creating a set of normalized tasks, and compile time is the time to run the query through the algebraizer. Um, so this is the metric that we would check while we try to identify how fast a query has run. So I'll go ahead with our first demo. This is something really simple. Here we are trying to generate a code using the year and month operator. And we see that this has a specific uh, SQL Server, like specific parse and compile time. And when we optimize it using Copilot, uh, Copilot generates a different piece of code, which when we run, we see a better output and the same output with a better time complexity. So we'll go ahead and run this. We see that we are getting the select statement with the year and month operator. The elapsed time is 165 milliseconds for this query. When we optimize the query, which is written above, we see that it uses a different format, and we have brought it down to 47 milliseconds. Very similarly, Copilot can be used to add indexes to data to enhance query performance. Um, in like if the database is reasonably large, these minor optimizations can make a huge difference in the speed of the application or the code. Uh, we all know that while developing on .NET, you come across codes which are difficult to interpret, and you just know that it will impact your performance. Without even delving deep into the code, you can consider optimizing it and reducing the complexity. Once you use the Copilot chat with this, which is also available, you can even understand what a piece of code is running. This is an example of a more complex performance optimization where Copilot interestingly identifies a cursor. A cursor is a database objects that allow us to retrieve and manipulate each row at a time. So as a developer who's working on a different language, you do not need to know it. If you think that it can be performance optimized, you just go ahead and use optimization here, see that the output is same or not, and then you see if you are able to get the same output in a different a shorter period of time or not. Here again, we see that we are able to generate this at a shorter period of time. So it changes the cursor into a join, which significantly saves time because it has a different way in which the code is read. So I go ahead and write optimize the performance, the previous query. Forgot to make it a comment. And we need to set the statistics input output on so that we can see the messages. So it automatically gives that. We see that a select statement is given. And once we go ahead and execute that, we see that the prompt is being generated. This is a complex join, which uses multiple operators, a where and a group by, to generate the same piece of output that the cursor had generated in the previous part of the query. So I guess you're understanding the point we're trying to achieve, that even if the code is really complex while you're doing something, this can really help you in making life simple for you. You don't need to understand it. If you think it can be optimized, check and go ahead with the new query. So with this, okay, a few things that you should care about or watch for while you're using this product is like, we are providing you a copilot. This is your personal assistant. Don't let your personal assistant take the decisions for you. Um, Writing prompts and writing these comments in natural language has its own learning curve. The same word might have a different connotation or a meaning. The same prompt can generate different answers. Different prompt can generate same answers. Based on the session that you're working on. Till the session is on, Copilot is trying to make itself better. The moment you close the editor, Copilot forgets everything. Um, Sometimes Copilot, in the attempt to optimize your query, might end up changing the context or generating a different output. So please be wary of that. Please check the output first and then check what kind of optimization it has led to. So with that, I'll come to the point where I hear some questions. If there are some questions on the chat, I would. Do I have time? Any question? Okay. So Tanya asks, so it can optimize stored procedure and be able to explain it. Yes, it would be able to optimize stored procedure. For the explanation part, you can use the Copilot chat, where if you are highlighting a piece of code, uh, it would be able to give you what that code signifies. For those not using Copilot yet, is it worth it? It's going to replace anyone anytime soon. And this is by JAJUNK. No, nobody's replacing. So as I said, this will just help you in making things, making your life simple. This will just enhance your productivity. Um, not This is not here to take your job. This will help you in writing codes faster. Um, so there are two types of developers we are looking for. One, somebody who's new into the SQL ecosystem. Here, since I'm explaining from a SQL point of view, somebody who's new SQL developer, he does not need to reference, the complex syntax. He can just go ahead. He can write what he wants to see, and eventually there's a learning curve of how these contexts, how these prompts are generated, what kind of codes are generated based on that. So there can be a learning curve in that, but this can be really helpful for somebody who's new to it. And somebody who's a veteran, it would help them in doing things faster, like IntelliSense, like code snippets that you have in the editor. This is just something which really helps you uh, to upload. your screen slides. I guess that would be taken care by the organizer. I'll see, can one use natural language to refer to table names, or would you require additional prompting? So it is expected that the table name that you're using would be of the exact word, the exact table. Like I used purchase orders and purchase order lines table. So the P was in capital, the O was in capital. So we ensured that we use the same text and with the same. It's basically like a proper noun that you got to use. That's the best practice. Sometimes AI does understand what you're trying to mean. Some more questions. Now I'm going to the questions which were asked previously. There are some hate speeches. Curious for what type of toxicity GitHub Copilot would be looking for. So we believe in responsible AI practices. So if you're putting a comment which has some words which are unparliamentary, or something which is not right, this is an extra piece of a check that we are ensuring that it does not return back an answer. It is same as like if you ask something uh, wrong to ChatGPT, it would not answer. So this also follows the same practices. So I guess can it be used in the design phase too? I'm not sure I understood that question, but if you can elaborate it, I would be very happy to answer it offline. I guess we are towards the end of it. With that, I'll just summarize what we talked about. GitHub Copilot is your personal coding assistant. Consider it as an extra pair of hands on the keyboard, which does some things for you. Don't forget that you're the pilot, so you got to check whatever you're doing and see and take the final call. Um, for contextualization, Copilot needs to get the context of your database. By default, it does not have context of the objects which are present in your database. So it is important that you provide the context by means of data definition language before the code, before the prompt. In multiple scenarios, GitHub Copilot can help you optimize SQL queries and incorporating the best practices of SQL development into query building. Your data is safe. We do not store your data. We do not take your data. The moment your session is closed, all data that we had are removed out of our system. Thank you so much for attending. There are 2 links. You can dive deeper into .NET and Azure with our curated learning collections. And also you can take the Cloud Skills Challenge. Thank you so much.
Thank you so much. It's so wonderful to hear all of the great things that you had to share. And I do want to say, I want to call out, in addition to GitHub Copilot, Microsoft has a lot of other great Copilots as well, including Microsoft Copilot for Azure. And so what I'm showing here is actually the Azure Developer Hub. And so that's developer.microsoft.com/Azure. And so you can learn a lot more about the Azure Copilot here, as well as just a lot of the other products and features that we have and featured solutions to see ways to be able to take this into the real world and start coding on it. But thank you so much, Subhojit. Thank you so much. It was such a pleasure to hear all of the things we could do with GitHub Copilot.
Thank you, Hailey.
All right, next, I'm very excited to introduce Catherine and Stanley. Ooh, that's the wrong sessions. So Catherine and Stanley are going to talk about Azure Cache for Redis, which actually does have a community stand-up. And so you can join Catherine every 4th Tuesday of the month to learn about all the cool new features that they have. And honestly, just really interesting things to be able to ask about and have live Q&A. So I'd like to invite Stanley as well as Catherine up onto the stage. Welcome, welcome. We are so excited to have y'all here today. How are you?
Good, thank you. So welcome everyone. This is the Redis cache and intelligent apps for .NET session. My name is Catherine. I'm a product manager in the team.
Yeah, and I'm Stanley. I'm a software engineer on the Azure Cache for Redis team.
Okay, so today we'll look at how to use Azure Redis Enterprise with vector similarity search and a few associated application scenarios for it. We prepared a couple of demos on the RAG AI semantic caching and a few more, depends on how much time we have. And we'll mention security is important and it's very secure to run your application in Azure. So let's get started. Azure Cache for Redis Enterprise is a first-party offering in Azure. We have a partnership with the Redis Inc. So even though the Redis Enterprise software is not owned by Microsoft, the service in Azure has the entire first-party support, scalability, resiliency. It's unparalleled up to 5.9 SLA. Why Redis Enterprise? Because it has a search module that enables the popular vector similarity search scenarios in intelligent apps. Redis itself can be a decent vector database because it has built-in search capabilities, and we have great developer experience support. Like in the agent SDKs, we have a connector through semantic kernel, and we have popular open source .NET libraries like Stack Exchange.Redis and Redis OM and Redis Stack. Those are for using the modules and the search capabilities built on top of the Stack Exchange. So rich client libraries and tooling support, good search capabilities, and Redis itself has data structures like JSON and hash to store the vector embeddings, so we can use it with our application. So we talk about vector similarity search a lot, but what can it do for your intelligent apps? In the retrieval augmented generative AI scenario, a vector database can be used as an external knowledge store. So suppose if you have any documents that's internal to your enterprise, you won't want to train the GPT model to know everything about it, both for security, privacy, and also it's costly, expensive to train a new model. In that case, you want to put your additional knowledge in an external vector database, such as Redis. And you can then retrieve the information from it, augment your prompt, and then send to GPT for generating the chat completion. So that's one popular scenario for vector similarity search using a vector DB like Redis. Other scenarios include summarization, grouping, trend prediction that just by comparing the similarities or differences among the vector embeddings, it can deliver by itself. And you can incorporate it in your application. For example, you can recommend a similar item a user has purchased in an e-commerce shopping web app. And there are current scenarios for caching, like the user session, state data, distributed caching, output caching, and so on, which can all be incorporated into your intelligent application, making Redis a multi-purpose data store for intelligent apps. So let's get into the demo.
Yeah, thanks, Catherine. So another popular scenario for using Redis is as an external knowledge store for embeddings and other documents. So let's show a quick demo with an intelligent app using Redis. So you can find the code for this application here. So it's very simple to get started. All you have to do is go to the repository, press dot or period on your keyboard, and that'll open a code space. And once you do that, you can open a terminal and provision your environment. And so this is a service provided by or paid for by Azure Samples, so you don't have to worry about costs for this. So to set up your application, all you have to do is run azd auth and then set the environment to use Redis and enter an environment name. And then you enter the embedding type. This is specific to Redis. And then you just run azd up. And then this will provision resources in the subscription and region that you choose. So you
Stanley, the azd command, is it the Azure Developers CLI? And is there any backup backing this whole process?
Yeah, so the Azure Developer CLI is a very simple, easy to use tool. It makes things repeatable, and this is fairly simple to use, I would say. So
I see all the PDF files being uploaded. It's pretty fast.
yeah, there's a lot of PDF files in our application. So this is we take the documents, we send them to Azure OpenAI instance, which sends it to a function, which then sends the bit embedding to Redis with relevant metadata. So you can see it's processing all of the PDF documents, and then we'll be able to use them in our application.
So Redis is pretty scalable in this case.
Yeah, I would say so. Yeah, we can use it. Azure Open offers a variety of sizes for Redis, so it's definitely built for scale. So this is our chat application. We just click on the link after we provision it, and we can enter a question where we'll generate a response with supporting content. So you can see we have our answer to the question along with the documents that are relevant. You can see all of the documents that we uploaded and processed here, and those all have embeddings associated with them in Redis. So here's an example of using Redis as a semantic cache. So we entered the question, what happens to performance review? And we got our answer. And if we enter a very similar question, what is a performance review? You can see it returns the same response. Now this is a tool to view our Redis data called Redis Insight. This is a free and widely available tool from Redis. So we just enter our host name and password, and we can view our data. So you can see we have our semantic cache data with our prompt, question, and embedding information. And then we also have our document embeddings with the embedding and the associated metadata and content. So we could also run the profiler tool and see the commands executed in real time. So if we execute a query in our application, we can see that query reflected in Redis Insight as well.
That's one advantage for using Redis as the vector database through the tooling support.
Yeah, absolutely. That's right. So we can view that, verify that the semantic cache is working, and it did cache our question. So that's great. So that was the demo. You can find the code here. The demo Azure Search OpenAI demo C# on the Redis branch. So now I'll just briefly go through some of the code and show how simple it is to add this to your application. So I added two main functions to the application. One is the embedding service, and then the other is the search service. So to create the embeddings, first you have to create an index. So this is the method to create the index. It just executes the ft create command and then the parameters. You can specify a schema to use the metadata associated with your vectors. You specify the vector type, the vector dimension, and then the distance metric that you want to use.
That's all the built-in Redis search capabilities, and the index is all stored in Redis itself.
Yeah, absolutely. Yeah, it's and then this is creating the command directly and directly executing on a Redis, but there are also libraries such as Redis Stack, which offer additional functionality for C# as well. So you can see once we have our document, we compute our embedding with Azure OpenAI, we can just provide this information to Redis, and it'll store that in the database, and we'll be able to query it. So moving on to the search service. So we were able to query the documents. This is the primary query that we're executing. So you can specify the index, and then how many documents you want to retrieve, and then you supply the query vector, and it'll, based on the search function you use, it'll find the most similar documents to the query vector, and it'll return those results. And this is all done using the ft search command. And then finally, there is, we added functionality to use Redis as a semantic cache. So you can see we imported these two libraries, redis.om and redisom.vectorizers. And this allows you to create a semantic cache using your API key, resource name, deployment ID, and dimensions. And then further on, you can check if a similar question has been asked before in the semantic cache. If it has, you can return the response. And if it's not, you just create the answer and cache the response. And so that's.
So that means when semantic cache is used, your application don't have to call into the GPT model again to generate the answer, right? Because everything is just cached.
Yeah, that's right, Catherine. So it can definitely reduce the burden on your application and those resources. And it's definitely something that you can tune as well. There's a variety of parameters that you can tune to set the sensitivity of the semantic cache as well.
Awesome. So
yeah.
Basically, this is using Redis as the external memory store for RAG AI, and using it as a semantic cache for reducing cost and improving performance.
Yeah, absolutely. And keep in mind that Redis can also be used for a variety of other more traditional web functions, such as session state caching, output caching, and storing the chat history as well. And this is all stored in memory, as Redis is an in-memory database, so it's all very, very fast. So we can switch back to the presentation, and I can go over the architecture, which we briefly showed. So that you can see the presentation. This is the architecture. So we send the documents to a function, and we store those in Redis, and then we query those also using Redis. And it's it's definitely an exciting use of Redis in general.
It's very cool seeing just using one instance of Redis Enterprise, we could enable so many scenarios and features for intelligent app.
Yeah, absolutely.
Okay, so Stanley, you earlier mentioned there is an alternative for doing all the search command using Redis stack. So this is the Redis stack library that Stanley was talking about. I mean, as a developer, you have a choice if you want to write the Lua script and the commands yourself. Stanley showed you the way to do it. This is an alternative way. It kind of wraps the command a little bit and orchestrate all the function calls. So this library is maintained by Redis Inc., but available to everyone. It basically enables all the Redis module commands like search, JSON, time series, and so on. So you can check it out. I have another like demo application just showing if you use Redis stack, this is going to be how creating an index would look like and how search would look like. So not wrapping the raw command, but we have some functions here to make things a little bit neater. Yeah, and I think Stanley also mentioned about the semantic kernel. This is a Microsoft-owned but open source agent SDK. It has built-in memory support using Redis as the backend store. And we also have a blog post talking about how semantic kernel and Redis can work together to enable chat applications. So we talked about semantic caching a lot, and we know this concept is relatively new to people. What does it mean? If you have an application used by multiple users, then like in a chat application, for example, there might be questions that are similar in meaning but asked in different ways. For example, where is the capital of France and where is the French capital city? In this case, there's really no need to go to GPT again and call the large language model generate a new answer because it's expensive, it could be time consuming. What we want to do is to store responses to this type of questions. And how we find or retrieve the value is through making the key of the cache entry to be vector embeddings. And we search through to find the entry with a similar key in meaning as we translate everything into vector embeddings. In OpenAI, Ada text embedding can do that for you. It's relatively lower cost comparing with like calling the GPT model for generating a chat completion. So for example, in this case, if a question got asked, where is the French capital city? We go through the embedding transformation, making this question query to be vector embeddings, and we compare through the list like how to see which one is the most similar, and we retrieve something we found and then give the answer back. So in this case, it reduces the cost and improves your performance. And I want to show another application to emphasize on semantic caching a little bit more. This is an OpenAI art gallery. It calls into the DALL-E model to generate pictures on demand. So if I hit the semantic cache endpoint, and let's just do something new, a purple robot walking in the sky, because we are done it, we like the purple robot. Okay, I think it's blue. I may have set the similarity threshold for like too low. Let me just clean the response and do it again. This is a nice tool, Redis Insight. Like I can just go into it to manage my data. I see there are some like previous entries. Let me just delete all these entries. Yeah, it's pretty simple to use this tool. So let's go back to the application again and try semantic cache a purple robot walking in the sky. Try again. .NET plus Azure. Hope it works this time. So we see it's taking the time calling into the DAO-E model for generating the picture. Ooh, I like this one. So it's a lot closer to what I was asking for. Now, if another user comes in and maybe enter a prompt with similar meanings but different ways, like a robot that is purple in the sky. I'll say like walking in the sky. You see the response got reused. Picture returned instantly. There's no like waiting progress for calling into DAO-E again. So this is like another application for using semantic caching, and it's beyond the question and answer. Can be anything generated. Now, when I was displaying all the pictures, like my server had to render the HTML, and if a user keeps on refreshing this page, there could be like overly utilized CPU resources. So we wanted to reuse some of the previously rendered HTMLs. That's why we introduced the Redis output caching in .NET 8. What this means is, for example, if I go to the cached endpoint, I see a French garden. The first time is calling into the backend DAO-E model again to generate this picture, but notice if I refresh it, because it's the same command, the HTML response will be cached, and it's going to reuse what was generated earlier. In this case, it will save the CPU resource utilization and also improving the performance. If we go to the Redis Insights tool, do a refresh, we see the previous entries here. And this one is from the output cache, basically HTML or generated already to be reused. And for both scenarios, the coding effort is pretty minimal. To enable output cache in .NET 8, you just have to firstly add the services. This one, add output cache, make sure output cache is enabled, and then stack exchange.redis, making sure Redis is used as the backend store. And you just say like .cache output in your program application. If you want to add any additional configuration, you can do it either through the attribute or go back to the service initialization code to do it. Yeah, so this is like a little bit about the new Redis output cache we shipped in .NET 8. And regarding to the semantic cache part, it's very similar to what Stanley showed earlier. We use the Redis OM, and it's cache.get similar and cache.store async for saving the command prompt with what's generated by DAO-E. Yeah, and if you want to learn more about the vector similarity search, vector embeddings with Azure Cache for Redis Enterprise, this is our documentation, and the links plus the blog post, demos, everything will be in the slide deck. Yeah, and we want to mention it's very secure to develop your application using our Azure Cache for Redis. We support application level, transport layer, and infrastructure level security. So when you code your application, you can make the entire experience quite free, leveraging the Entra ID. And there are well-established bicep files for configuring the VNet, bicep, ARM, Terraform, the choice you like. and we supported the latest TLS 1.3. Okay, and yeah, that's all we have.
So, Catherine, there's some questions in the comments. One of the questions asks, can we tweak how similar the results are in the semantic cache? And so that's definitely something you can update and tweak as necessary. You can, yeah, there's different parameters you can use to modify that.
Yeah, sorry, I cheated through my demo, but like Stanley said, there are parameters you can use to define the similarity level.
Yeah. Another question we have, do the documents have to be written in a certain format, or can we send any documentation to be queried? The documents don't have to be in a certain format. You can use pretty much any document with text. You can use PDFs. You can, I'm sure you could change it to use something like a Word document or something like that. But anything that you can extract text from would work. You can also use it with images as well, and that's definitely a use case for that. Another question asks, can we use the caching for controllers? And it's definitely a supported use case. We definitely support the model view controller framework. Yeah, you can use output caching and semantic caching with that as well. Yeah, so I think that addresses most of the questions.
Awesome.
Well, thank you so much. And yeah, just another reminder, every, let's see, that's the 4th Tuesday of the month. And I think your next community stand-up is actually on May 8th. Isn't that right? I think we had to reschedule one of them. So if you'd like to hear more about how to use Azure Cache for Redis and from our wonderful presenters and speakers today, they will be joining every month on this YouTube channel. So just subscribe to the channel and you'll get lots of great content, lots of opportunities to ask more questions and to learn about more features that we offer. Thank you all so much for joining today.
Thank you.
Thanks, everyone.
I also do want to plug our Cloud Skills Challenge, and I'll put the link up right here. So one great way that you can take what you learned today and actually turn it into real world scenarios is to participate in our Cloud Skills Challenge. And so selecting join the challenge right here, it opens today. And so it's now available for everyone to join if you'd like to. It's a series of learned documentation and collections where you'll be able to try out what you've learned today. And so we've concluded the AI portion of the day, but if you want to play around with Azure OpenAI and learn how to use it, see what the use cases are and how it can benefit you, check out the Cloud Skills Challenge. The link is below. It is free. You can get a lot of great information and knowledge just from being able to play around with the tools. So highly, highly recommend. I'll also do another plug for all of the links from the sessions today. So I know Catherine and Stanley shared a whole bunch. Down here at the .NET Day site, we have a ton more links of all the sessions. And so everything you're seeing today will be linked there. The recordings of this will also be included in this YouTube channel. So if you love the sessions that you saw and you want to reference them again, just subscribe and you'll be able to access this at any time. I would love to bring up our next speaker, Davide, from the Data API Builder team. Hello, how are you? You are muted.
Oh, I'm muted. I'm muted? Oh, I should
Now you're good. Now you're good.
Okay. Yeah, so I'm in Chicago at the VS Live conference doing another conference online. So it's going to be fun.
Well, thank you so much for joining us. Thanks for fitting us in.
Okay. So I can start to share my screen,
away.
I guess. Perfect. So let me present and share my screen. And the entire screen. Here we go. And okay. You should be able to see my screen. So let me just start the session today. Event-driven architectures with Azure SQL, .NET, and Azure Functions. So 30 minutes of fun. because we'll be discussing about how to implement the event-driven architectures with something we just released recently that will help you to build that around Azure SQL. So for those who are new, event-driven architectures is just basically an architectural pattern that allows you to create a microservices solution that exchange events between each other. So the idea is that every microservice or every service is decoupled and autonomous and independent, can scale independently, can do its own thing, but when it needs another service to do something, it will send an event, and the other service will react to that event. So this is very common and popular architecture. So one thing that is very key to understand how all the events moves around and why they are needed is basically the entire idea of events, which is basically something that represents a change in a state or some update to a state. And the event producer are those services who generates the event and publish the event. And of course, typically in a complex scenarios, you have an event router that routes the event to the right consumer, which can be more than one. And then of course the consumer is those who get the event and decide what to do with it. For example, it could be in a very simple example could be a signaler function that update a website, for example. And this way, the services remain decoupled. They, as I said before, they are completely independent. And in general, it's easier to just make sure that a solution that grows as your needs or your requirements grows. So one of the most, well, I wouldn't say maybe one of the most common, definitely one of the feature in the service I like more is Azure Functions. Azure Functions is an event-driven serverless compute platform. Serverless means that you don't have to worry about infrastructure. So you just write your code and deploy it, and then everything else is taken care for you. It supports any language. Of course, we'll be focusing on .NET. And another thing I really like is that it has full support for on-premises development. So today we will be building something completely on-premises, and then I'll show you how easy it can be deployed to Azure. And one way to have this function executed, because again, you just deploy your code, but the code isn't executed until something happens. That something is called a trigger, and a trigger is basically a way that you can use to cause a function to run. There are many triggers in Azure Function supported. Probably one of the most common one is a HTTP trigger that allows you to answer to HTTP request, basically creating a REST endpoint with Azure Functions. But there are many more. For example, you can monitor for data changed in a Azure blob or some event coming into Event App if you're already using event-driven programming. So there's a bunch of them that you want to use. Now, it would be fantastic if an Azure function could be executed when some data is changed in the target database, because that would enable the database itself to become itself an event producer, which means you don't have to poll for data in the database, but basically just react to change, which is exactly the whole idea behind event-driven programming. So you can react as fast as possible to change, and then make something happen, like make an order, ship an order, or enable some feature in a website, something like that. So that would be our dream, right? And now the main issue with that is how we can detect changes efficiently in database, because maybe you have 1 million or 1 billion of rows, right? So how you can detect changes efficiently in the database. And in general, even after you have detected the changes, how you can notify that function so that it can actually be executed. So that is exactly why we have built in Azure SQL already from 2016. So it's available in Azure SQL, but all SQL Server Edition from 2016, something called change tracking. Change tracking is a native lightweight solution that allows you to easily monitor a table to understand if some rows has changed. And if some rows has changed, you can get the information on what are the primary keys of the rows that has changed, so you can go back to the table and then get the latest data for that specific row. Now, change tracking just needs to be enabled. It's part of the engine, so it doesn't come with additional cost. It doesn't have any additional requirements. It's just within the Azure SQL engine. And on top of change tracking, we lately released something called Azure Function SQL Trigger, which, despite the name, is not a trigger in the database sense. So it doesn't really use database trigger. It's a trigger in the Azure function sense of things, because it is able to execute a function when some change is detected on the target table. So Azure Function SQL Trigger is actually an Azure Function feature that queues behind the scene for you, so you don't have to actually worry about that. This ability that Azure SQL and SQL Server has to detect changes using the change tracking engine capability. So when a change is detected, an Azure function is executed, and there are, of course, some details that you need to know. For example, what happens if you have multiple changes? So let's say, and I will show this in a demo very soon, but basically, if you have a sequence of changes that are happen together, for example, someone inserted a row and then immediately updated that row, and maybe did several updates to the same row, what you will be receiving in the Azure function is what we call the net change. So it's the sum of the insert plus all the subsequent update, which means basically you will access the latest version of the row. You will not be able to access the intermediate changes. This is, of course, done for performance reason, but also because on average, unless you are doing some ATL or some other more advanced scenarios with events, you probably need only the latest version of the data that is in your database, not all the intermediate one. Changes are sent in batches, so if there are 100 rows changes, they are sent all together. So you will receive one payload with 100 rows. So your function will be executed once, but it will be able to act on 100 rows. And let's say if you have many changes happen, let's say you have 1 million rows changed, of course, maybe an Azure function alone cannot handle all the workload. So optionally, you can, because of course that will come with some additional cost if you use more than one function at the same time, but you can actually enable automatic scale out, so that if you have a lot of changes that need to be processed, you don't only have to use one function, but you can use as many as needed in order to keep up with the amount of changes that is coming in. So you basically have a scale out solution already done for you that is based on how much data is actually sent to the function. So with that, other couple of things that I guess makes you happy, because one of the most common question I have when I present this kind of session is what happens if the connection to the database is lost? Well, inside the code of the Azure SQL Trigger, the Azure Function SQL Trigger, there is already all the logic to retry in case of connection error or even exceptions. Of course, at some point we will give up if an exception it's continuously happening. But in general, if it's just a matter of temporary disconnection, we will the Azure Function SQL Trigger will take care of that for you. Of course, if you want to change the batch size or the number of changes per worker, or even the polling interval, because how it works behind the scene is that the Azure Function SQL Trigger will check for changes using the change tracking feature every X second. By default, that X is equal to 1, but you can actually change that value in order to make it more suitable to your need. Everything is configurable, as you can obviously imagine. So let's go to the demo, and let me bring up the code. So the code is very easy. I created a function. Let me close this. I created a function using the usual function init process, and here I have my Azure Trigger binding. So as you can see, it's just a regular function, and it's marked with the attribute function. I'm using the isolated environment, and this is the magic keyword that makes everything happen, SQL Trigger. It's an attribute that you have to specify in your function, where basically you define what table you want to monitor and what is the name of the option in the settings that contains the connection string. We support, of course, all type of authentication, SQL authentication, but also, and that's what I'm going to use, manage the identities and entry-ID authentication. And then you have another option that you have to specify in your function that is basically the payload, the changes that you will be getting. It's an I-read-only list of SQL change on the object that you have created in order to get the information about the changes row. So sample table, in my case, is a POCO object that contains exactly the attribute with the same name of the column of the table I am monitoring. So you will see that my sample table has exactly these columns. Why some columns needs to be nullable, even if you will see in the table are not nullable, because if I delete the column, if I delete the row, what it will happen is that I will only get the information about the primary key, which is in my case is the ID that that has been deleted, and of course I will get null values for all the values that are related to a row that has been deleted, because that's exactly what happened. The row has been deleted, so these values are gone. So that's why you need to make sure that everything is nullable here, except for the primary key. And the read-only list has this interesting option, the SQL changes, more specifically, object have this interesting operation property that tells you if the operation was an insert, update, or a delete. And then the item itself is basically the POC object you have created that contains the rows that has the payload of the row that has been changed. So it's very, very easy. It's just a few lines of code. And of course, here I'm not doing anything interesting. I'm just logging. But you can imagine that once you get the information about a row that has changed, you can actually do anything. You can send this data to an event tab. You can call a Signal endpoint to update a website. You can do whatever it's needed to do in order to, for example, process an orders, validate a user, or whatever. So in this case, I'm just logging, but let me show you how it is to set up. So first of all, we need to set up a database. So let's make sure that the database has change tracking enabled. That's how I do it, very easy. And I'm connecting to my local database. So yes, of course, my change tracking is already enabled. That's fine. I'm now creating a table here. Again, the primary key is my ID, and then some value, another value are exactly the name of the column that I will also be using in the POCO object. And then I enable my table for change tracking. That is something that you have to do in order to have the SQL trigger function working correctly. Once it's enabled, you can even, of course, check in some specific system table if change tracking is enabled or not. Has been enabled for me, so all is good. I can just now go here, and since already the code has been written, I can just do func start and see what happens. Now the table is completely empty, so no changes so far. So I don't expect anything to happen here. So I don't expect anything to be logged. Of course, I would just expect to see my function ready. And actually, I have a couple of functions. The one that we are focusing on right now is this one, the SQL trigger. The other one, the HTTP trigger, will be used later in another day. So let me go back here and now try to do something on my data, but not before having shown you that, let me make some space here, that I'm using this database, and you will see that now, aside of the table I have created, let me zoom in a bit. Inside of the table I've created, you have two other couple of tables that has been created for you when the SQL trigger was started. Basically, the SQL trigger needs to keep track of what rows you have already been notified of changes. So that's how it does it, using some additional table that has automatically created when it was started. So don't fear if you see this additional stuff. It's needed for the SQL trigger to function properly. Now that I said that, let's just take a look at our table, which is empty. Fantastic. And let me move this on the right side of the screen. And let me move this on the left side of the screen, make some space, and take a look at the log. So let's add a couple of rows in one single transaction. And you will see here that oh, sorry, I did it in the Azure database, not the local one. So let me connect and connect to the correct one, actually. So let me go here. Let's do from here, new query. Let me connect to this database and do this one here. Nice. Okay, so this is the empty table on my local database. Yes, now I'm in the local database. Nice. So let's go back here, insert a couple of rows, and you will see that immediately the rows are now have been sent to the function. Again, everything is working locally, and the function processes the changes. So as you can see, one change, even if affecting more rows, sent both of the rows affected to the one execution that happened behind the scenes. So one execution for a batch of rows. Now, what happens if I just do one transaction with just one option that is actually affecting 2 rows? Again, you will get a couple of execution. That is nice. And of course, if I delete everything, again, you will get both rows sent to your execution. And you see that the operation changes because 2 is for deletion, 1 is for the update, and 0 is for insert. Now let me insert again the row. Let's do something interesting here. I'm adding the rows, and basically without letting any time pass between the addition and the update, I'm also updating the rows. So I'm changing the second value here, the some other column, to Davide instead of the original value. So let's see what happened. What you have received here is an insert notification, because 0 is the insert, but look at the some other value. It's equal to the latest value detected, right? That's because between when we did the insert and the update, the function didn't have a chance to be executed because we did it very quickly. And so that's exactly what happened. The function and the change tracking allows us to get access to the rows changed and to the latest version of the data, not the intermediate one. So here we are notified that a new row has been added, but with the latest data, which is exactly what you need, because in this kind of scenario, you probably don't need to have the intermediate changes. You only need to understand if data is changed and then get the latest version of the change in order to act upon that change. There are other ways to monitor the full history of changes, and then we can discuss it later. But for this one, you will always get access to the latest changes. Okay. Now, what happens if I want to deploy everything in Azure? That is very easy. Let me stop this. Of course, you can do using AZD, as you have seen in a previous session, or Bicep, or even from Visual Studio. I just installed the Azure function extension. I can deploy to a function app. Very, very easy. And what will happen is that I get this function here that shows me that I have the trigger SQL and the HTTP trigger available. Now, if I go and take a look at the application insights, and let me clean everything here, you will see that every time, since this is now working on Azure SQL and on Azure, you will see now that I have to change to my Azure database. So let me make sure I connect it to the Azure database. Okay, this is my Azure database. And here I did exactly the same as I did on premises, with one big difference. And this is something I really want to show you. I am connecting using, of course, a connection string that I can easily share with you, because there is nothing secret in here, right? Because I'm using the Active Directory authentication. So in order to do that, what I had to do is, of course, make sure that my function has an identity enabled. So in this case, I'm using a system assigned identity, and the system assigned identity created as the same name of the function app. So I took this value here, and you will see that in the sample I provide to you, you also have something that you need for Azure when you deploy on Azure. You need to create a user that represents the function. So again, I'm using exactly the same name of the function, because when I created my identity, it was given the same name of the function. And then since my my code needs to read from, in this case, any table, to write to my table, and to create the additional table I shown before, I'm giving the right permission, and I'm also granting the ability to view the change tracking on the table I have I want to enable for change tracking. That's it. So just make sure that you use, that's my recommendation. Of course, you can still use SQL a lot, but we are really kind of telling you that the best way to do that, to do security, is without using password. So just use the identity, and then that's very easy. I can go to the environment variables where I have my connection string stored, and again, I can go here and show it to you, because again, there is nothing secret in it, right? So that's that make my life as a developer super easy. I don't have to think about password and logins anymore. And once that is done, everything is working nicely. So my trigger is available here, as I already shown. So let's go here and see what happens. Let me show you what happens if I'm connected to Azure, yes. So let me delete everything from my table and insert. Now my table is empty. Let me insert again a couple of rows here. If I go back here, you will see that the function has been executed once when I deleted my row, and another one time when I have inserted a new row. And this is just like magic, because again, let me do one other, couple of other, and you see that the function is just being executed anytime I insert a row or delete a row or do any operation that changes the data on my table. So this really enables you to create event-driven architectures using Azure SQL or SQL Server as a producer in this case, which is amazing, because again, completely changes the way you think about your database if you start to think in this kind of approach. Now, one last thing I want to show you before going to take any question is that this approach is great, but what happens if you don't have a table that you want to monitor? Because maybe you want to execute the function based on something that happened in a storage procedure or some more deterministic way, but that is not related to data being changed in a table. For example, you would love to be able to call a function as a part of a storage procedure execution, maybe to process some data before making the changes, or to notify or call other services, or even to send some log to a remote information to a remote service to track that the function has been, that the storage procedure has been executed. So to do that, you can use a new storage procedure called, well, relatively new, in the sense that it's been around for a year now, SP invoke external REST endpoint that allows you to call any REST endpoint that you have in Azure or even outside Azure using API management or some tunneling technique. It's available in Azure SQL already in GA and has been just recently released in preview in SQL MI, if you are using that version of Azure SQL, so that you can call any function, any REST endpoint, any event tab. You can send a message to event tab. You can interact with Azure Storage. You can use OpenAI to get embeddings, for example, from a text. So it really allows you to call any REST endpoint published by Azure and even by other services. It's very easy to be called, as you can see, exec SP invoke external REST endpoint, and then it supports JSON, XML, plain text payload, anything. It typically comes in and out from a REST endpoint. Of course, it supports also managed entities, but if you have a function that requires a specific header with some secrets, you can actually even provide that, and you don't even need to store it in clear text in the function call, but you can use scope database credential to make sure that everything is securely stored and only those people with the right permission can actually access it. It has been built. We really put a lot of effort in making sure that all the access to REST endpoint is absolutely secure. So, for example, we only support HTTPS protocol. We don't follow redirects, and we also have some throttling already embedded in the logic of the calls, just to make sure that noisy neighbor problems cannot happen. With that, let me show that in action is actually very, very easy. It's just one line of code. So let me copy and paste this from here, and I just need to make sure that I be on Azure. So here I'm actually calling the HTTP I have deployed as part of my example. So here I have an HTTP trigger, and the HTTP trigger is just, take first name, last name, and say hello world to the first name. So what I have to do is call the REST endpoint, specify what method I want to use, specify the content type, then the payload is actually my, in this case, JSON object, and the response would be giving me as an output parameter. So let me run this in millisecond. I got the full response. So the full response contains all the metadata, even the headers that I've received from the server, and of course, the payload. The code this payload is super easy thanks to the JSON function you now have in Azure SQL, so I can just do JSON value and then extract the message, and here it is. So if I need to call a function in a way that is not related to some data changed in a table, but again, part of a stored procedure, part of a script, SPVOC external REST endpoint is the way to do it today. With that, let me go to my last slide and one practical example of putting all of these things together. So the event monitoring on the table using the function, the calling to OpenAI REST point to get embeddings in the specific case. It's built end-to-end using also Data API Builder, another service I love that allows you to take your database and turn it into a GraphQL REST endpoint. So basically doing the opposite of what I've been explained so far, and creating an end-to-end full stack Jamstack application that allows you to chat with your own data. Well, that's the example you want to go and follow. Azure SQL DB Session Recommender v2 that basically wraps everything I just described into an end-to-end solution, adding the AI spice on it, which is today all the rage. So make sure to check this out. It's very, very interesting. And for example, this website is what I'm using even today at VS Live, where I am right now, to explain AI in end-to-end solution with Azure SQL function and GraphQL. This is a broader solution that you can create with Azure SQL and, for example, function integration, Data API Builder, everything. This is a very modern architecture based on events. And of course, this is a little bit more complicated than the one what I shown before, as is showing everything, including the analytical part, telemetry and logging and everything, but this is something you can easily build using SQL as event receiver or even an event producer today. Couple of resources here. Make sure to check out azuresql.dev. I have wrote a book years ago, and also Bob Ward, that is here with me today, also wrote a nice book called Azure SQL Revealed. Make sure also to check out the AI resources. Again, today AI is the hot topic to understand how you can integrate everything I've shown with your AI ideas. And last but not least, and then I have a couple of minutes for question, is make sure that you go to this list, to this URL, and or use this QR code to fill out this survey, because this allows you to tell us what you want in Azure SQL. 3 years ago, we did the same survey, and we got a huge amount of feedback on need to support Azure function, need to be able to call REST endpoint, need to be able to expose a table as a GraphQL endpoint, and we built all of that in the last 3 years. So now that we have built, I would say, 90% of what we have been asked, it's now ready for you to ask for more. So what you want to have in Azure SQL next, where do you think we should work on? So make sure to fill this out. It's very important for us because it allows us to correctly prioritize the development of the product to make sure that this is matching your need as a developer. And with that, I am done on time, I think. So let me go and see if there are any questions for me. Let me just go back here and stop sharing my screen. And here we go. Okay. So, Davide, you mentioned timeout connection issue handling. What happens if there is a larger issue and the process timeouts? There is a way to re-trigger things. So if the row is being determined to be completely lost, because again, maybe there are exceptions in the last 30 minutes, something like that. No, in that case, you have to retry it manually. So one technique I use is that I add a column to my table that basically forces the row to be reprocessed. That's an option that you have. And actually, this exact technique is also shown in the end-to-end sample I mentioned before. Yes. So does the trigger work in a .NET isolated process? Absolutely, yes. That's exactly what I used in my sample that I will soon publish also on GitHub. So absolutely, yes, it's working perfectly, actually. That's the way you should start using Azure Function right now, using isolated process. And is the change tracking available on Prem SQL Server? Absolutely, yes. You can implement Azure Function Trigger without moving database to the cloud. Absolutely, yes. So Azure, the change tracking is available everywhere. There is, just for you to know, there is even a more powerful version of change tracking called Change Data Capture that is also available on SQL Server and on Azure SQL, that allows you to even track and keep kind of breadcrumb of all the changes that happen between when your function executed once and when your function executed next. So you don't just have the net changes, but you have all the historical changes happened on the row if that's what you need. And that is also available on SQL Server and in Azure SQL. Okay, so it seems that I am perfectly at time. Thanks a lot for the question. Thanks a lot of Hailey for having me.
Thank you so much for joining. Yeah, we'll let you get back to your conference.
Thank you.
Usually we can see you on the Data API Builder live
That's
streams.
That's right. That's right.
Tomorrow.
Yeah, I will skip that, but Jerry will. Yeah, Jerry will be
Yep.
there. I know that Jerry also has a session on Data API Builder with Frank at this conference. So make sure that you tune in for that because it's going to be amazing.
Oh yeah. So stay tuned later today. Thank you so much,
That's
Davide.
right.
Have a great day.
Bye-bye.
All right, we're going to kick off the next two sessions here, finishing up the cloud native portion and then moving into the data services. So I would love to bring on, and after that, we'll have a short break just for everyone to grab a coffee and just rest for a minute before we launch into the second half of the day. So with that, I would love to close out our close.
Hello everyone, my name is Abhiman Tiwari. I'm a product manager on Azure SQL team, primarily focused on developer experience with Azure SQL DB. Today we'll talk about T-SQL for cloud native developers. So in today's talk, we'll look at JSON capability in Azure SQL database. We'll learn about JSON functions and operators, and we'll also explore about the newly added regular expressions, commonly referred as regex, feature in Azure SQL DB. Let's understand why JSON. If you are building a cloud native application using a microservice architecture, the communication between services is typically done over REST API, or could be GraphQL, or could be other protocol like gRPC or SOAP or anything else. But the most popular and common data exchange format is JSON. So if two services or applications talking to each other, it's very likely that they would exchange data in JSON format. And here is a simple application architecture, what you see on the screen. If you are a developer building mobile application or web or SPA or could be Jamstack application, in any of the technologies including C#, Python, Java, JavaScript, you name it. It could be the JavaScript frameworks like React, Angular, Next.js, Vue, and so on. You can choose Azure SQL database as your backend. At the same time, take advantage of Azure SQL database security, performance, high availability, and other great capabilities. And JSON support is available in SQL Server 2016 onwards, also on Azure SQL database, Azure SQL Managed Instance, and in all the offerings. Before we introduce the native JSON data type, the JSON document could be stored in character columns like varchar and nvarchar. But now they are natively supported. So we have a native JSON type. And you can interact with the JSON using the functions and the operators, what we have. Using those functions and operators, you can transform JSON to relational data and vice versa. JSON documents is stored in binary format with the introduction of new JSON native data type, which is optimized for querying and searching JSON document. Once it is passed, you don't need to pass it again. You can modify any particular tag or value. That way, you do not need to update the whole document at any point of time. And you can look at the limitations compared to other services or the competitions. So with that, let's look at the quick demo. Here, in this demo, we have a JSON document. We will use the isJSON function and the JSON path exist function to validate if it's a valid document, and also to check if it's a valid array. And at the same point, as you can see in the second query, we'll see if a particular object or value present in the JSON document. So here I'm looking for the order number. And in the second column, I'm looking for the order date, which actually doesn't exist in the JSON document. So this should return as a false. We have a date, but we don't have order date. So let's go ahead and run this. And as expected, it's a valid JSON document. It's a valid JSON array. Yeah, and we have order number in the document, but we don't have order date. And you can just verify that in the JSON document, which we are using here. Now let's look at the native JSON type. So here, I'll be using the JSON type to create an orders table. The column order info will be of JSON type. And I'm inserting JSON documents into this column. So let's go ahead and run this. And as you can see in the result, these two JSON data inserted into the table, like any other JSON document. And you can validate the account numbers here with the data which we inserted. Here in the third scenario, I'm using query property of JSON document to generate a relational result sets. So we have data stored in the JSON format. Now I'm using JSON value function to fetch those values from the JSON document and casting it to certain type and then performing arithmetic operations. Like any other data in the relational table, you can play around with the JSON data as well with the help of the functions. Okay, now we'll look at the JSON value and the aggregate constructors. So here in this example, I'm creating an account table and inserting a couple of regular relational records here. So as expected, these records are inserted in the table. In the second scenario, which is scenario 4, I'm creating another order table. And in this example, I have a JSON document which is stored in a JSON variable. And with the help of OpenJSON function, I'm reading the JSON document and inserting those data into a normal relational data format. So in the previous example you saw, I could, as it is, store the JSON document. And in this example, we are able to break those JSON document into relational format and we can insert in the table. And here, with the help of JSON object and JSON array, we can create any JSON document of any arbitrary shape and format, and also we can aggregate with the help of JSON array aggregate and JSON object aggregate. So here, if you take a look, I'm using JSON object and JSON array to generate the JSON document and the JSON array. And if you see, the 4 numbers are here generated in form of array in this JSON document. Similarly, in the next example, I'm using JSON object aggregate, and all those JSON documents will be aggregated into a single document, and then it can produce a single document for the number of records you want to generate for. Similarly, in the next one, I'm using JSON array aggregate with a JSON array constructor to aggregate the data. Yeah. So as you can see, we can play around with the JSON document. We can store in a relational format. We can break them into relational format, from relational format to JSON, JSON to relational format. With that, if you want to learn more about the especially preview features of JSON, native type and couple of JSON aggregates like JSON object aggregate and array aggregate, you can just go to this link aka.ms/JSON preview. You can sign up here. Also on this blog, there are further details you can go through and learn more about it. With that, let's move on to the next topic, that is regular expressions support in Azure SQL DB. We are happy to introduce the regular expression support in Azure SQL database. Regex is a powerful tool for pattern matching and data extraction. It can be used in databases to perform complex searches, validate data, ensuring that it meets the specific formatting or content requirements, and manipulate text. Some advantages of using regex in databases includes flexibility. It allows for complex pattern matching, making it possible to search for and extract data that meets a specific criteria. It is efficient. We can use regex to perform complex searches and data manipulation operations in a single step, reducing the need for multiple queries or a script. It improves the data validation and cleaner code. And again, you can use regex to transform and standardize your data. Conventionally, SQL aligns with the ANSI standard, but our regex implementation follows POSIX standard because POSIX is more widely supported, widely used, and it's the standard across in terms of front end and back end. You name it, any library, majority of them follow the POSIX standard. So we wanted to align with that. And our implementation support case sensitivity, character classes, quantifiers, anchors, and the subgroups. So the native support for regex in Azure SQL DB will enable customers to write more complex search pattern and perform string manipulations efficiently. This feature is available across all the tiers of Azure SQL DB in private preview. And these are the functions we have introduced as part of our regex announcement. You can use regexp like to filter the rows based on regex condition, and also to apply check constraint to ensure the data fulfills the specified criteria before they get inserted into the table. And again, you can use regexp count to count the occurrences of pattern within the string. If you want to find the position of the match in the string based on your regex pattern, you can use regexp instr. Again, to replace something based on the regex pattern, you can use regexp replace for that. And to find a portion of a string from the larger string based on your regex pattern, you can use regexp subst. So with that, let's look at the quick demo. So here in this example, I'm creating an employee table and inserting a couple of records. And as you can take a look at the data, I'm inserting a couple of invalid email addresses. And also, if you take a closer look at the phone number, they're not in the consistent format. So let's go ahead and create the table. It's created. And as we can see, the 5 records are inserted. Now we will use the regex functions to filter out the invalid records, and we'll fetch the valid record based on our needs. So here I'm using regexp like to filter the valid email addresses which are ending with the .com. So let's go ahead and run this. This will return the email addresses which are valid and also ends with the .com. So there are 2 email addresses which are valid, ends with the .com. There is another one, but that's not a valid email address. As you can see, the second one ends with the .com, but that's not .com, that's @com. It's not valid. Okay, now I want to count the number of valid emails in my table or database. I can again do that with the help of regexp count. It will return all the valid email addresses count. So far we have 3 valid email addresses in our table. So it's returning 3 here. Now again, if I have a similar requirement that I want to count the number of valid email addresses based on their domain, that again we can do that with the help of regexp substring here. So this will return me the count. We have one email addresses with the contoso.co.in and two with the contoso.com. Now, in the next example, let's say I don't want such records to be inserted in the database in the first place. So I can again use the same regexp-like function to put the check constraint on the couple of columns on the email and the phone number to make sure that the data getting inserted should meet this this pattern. So let's go ahead and recreate the employee table with the check constraint. So as you can see, the data is in right format now. So to validate if the check constraint is working, we'll go ahead and try to insert incorrect data here, and it should complain. Yeah, as expected, it's complaining about the check constraint and the email address because email address is not in the right format. We'll go ahead and fix it. And now, ideally, this should complain about the phone number because that's not in right format. It should be hyphen. We are using underscore there. Yep, it's complaining about the phone number here. Let's go ahead and fix this as well. And this should go in. Yep. So as expected, this record is also inserted. Let's go ahead and look at the table. And yes, we could see successfully we have inserted the demo data in the table. Now, if we want to find the position of the match in the in our query, we can use the regexp instr. And here in this example, I'm trying to find the position of @ in the employee email addresses. And you can look at the result set here. We could successfully find the position of the match. You can again validate that. And in the next example, I'm trying to replace the format of the phone number. Previously, it is in the 3-digit hyphen, 3-digit hyphen, 4 digits. Now I'm asking it to put the initial 3-digit in the bracket and leave the remaining 3-digit hyphen 4-digit as it is. And in the second column, I'm trying to mask the last 4 digit of the phone number. So let's go ahead and run this. And as you can see, the first column has the original format. In the second column, I could change the first 3 digit in a bracket. And in the third column, I could mask the last 4 digits. And again, with the help of regexp substring, we can find the substring from a larger string. So we will find here in this example the domain of each email addresses. And as you can see, we could successfully fetch the domains of each and every email addresses. Yeah. So if you want to experience the latest feature before anyone else does, and see how regex is integrated in the Azure SQL DB and provide your feedback to save the future development, just head over to aka.ms/regex-preview-signup, or alternatively, you can scan the QR code. You can submit your sign up request. Our team will validate and onboard you. And these are the reference links for the JSON and for the regex, and also for the entire SQL dev blogs. The last one, you can go through those blogs to learn more about it. You can start your learning journey today. To dive deeper into .NET and Azure with our curated learning collections, you can just head over to the link. Again, to take the Cloud Skill Challenge, you can go through the second link here. And to download .NET 8, to get the latest version of .NET and explore its new feature and improved performance, you can just head over to get.net/8 and you can download it. Again, for the migration tools, you can go to aka.ms/get-app-cat and you can enhance your Azure migration with a new tool. With that, we have reached the end of the session. Thank you. Thank you for joining today.
Thank you so much. That was a wonderful session. We are close on time, so I'm going to move us through quickly to our last session in the first half of the day on data services. When we come back from after a 10-minute break after this next session, we'll have the remaining half of the day, which is going to be super exciting, looking at developer productivity and application development, which is a great way to take this into the real world, learn what you're doing, and make sure that you are being as efficient and streamlined as possible. So without further ado, I will introduce our next session.
Hello, everyone. My name is Attinder Singh. I'm the product manager with Azure SQL Database team. So today in this session, we would be discussing about Azure SQL Database Hyperscale and how you could unlock the scalability aspect with named replicas. So we will first quickly introduce about the concept of hyperscale, read scale out, and then we will go deeper into the session, into the named replicas. All right, moving on. So as we are familiar with the SQL Server architecture since many decades, where we used to have all the SQL Server components like CPU, disk, memory, everything running in a single machine. So same architecture that you see that is inherited in the cloud world as well. But there were multiple challenges actually with this architecture, like limited scalability of storage. It used to be a very, very common customer challenge. And then the compute scalability aspect was complex, even in on-premises world and even in the cloud world. The scaling of the compute used to take very, very long time, even in the cloud world. And then scale up and down of the other resources, like because of the resource level limitation in the cloud world, a very common customer challenge. And then even another challenge was the transaction log size getting filled, transaction log getting filled, right? So all these challenges actually let us, or to overcome these challenges, a cloud-born architecture known as Hyperscale came into existence, right? So in this Hyperscale architecture, it is just another Azure SQL database tier. The only difference is that we have separated or distributed the components of SQL to like separated the compute layer, the storage layer, and the log service. So with this architecture, by changing or by distributing several components, we could actually mitigate all the challenges that I just discussed. And also the compute scaling got very, very fast, because now it is not a size of data operation anymore. It is just a compute that is getting scaled up in the background. And then the issue of transaction log getting filled got mitigated. Storage limitation that used to be there in the cloud world was around 4 terabytes earlier. Now that also got mitigated. And then now, let's say a startup actually starts with 10 gigs of their database size, and then they don't have any worry to that, okay, I need to add storage manually or increment the storage manually. It is taken care automatically. So from 10 gigs to 100 terabytes, it can grow seamlessly. And that limit is like 100 terabyte is there as of today, which is April 2024. This limit can be increased further. Like your database size can grow even bigger once we have the bigger size available, right? So with this architecture, we could also cater an important customer request to build a capability to scale out the read workload in a relational database world, right? So now like we can add multiple compute nodes in our database architecture, as you see in this architecture diagram, a high-level diagram that you just to scale out your read workloads, and then since each compute node that we have added can have its own name or endpoint, these are called named replicas, right? So now you can imagine a named replica as a simple reader database that utilizes same storage layer as your primary hyperscale database, right? It leverages the same storage, hence there is no additional storage cost. Customer can just provision a additional compute for a specific application, and then just this application can connect to its own private database, which is just a read-only database. Now, if you see that whenever any inserts, update, or any DML operation happens, that insert will go to a compute, or the DML will, or a log record will be created, and it will be in this compute's log buffer. And then from the log buffer, it will be pushed to a log service. So log service is in turn responsible to push those log records to a specific read replica, or we call it as named replica. And at the same time, log service is responsible to push the log records to the storage layer, or we call it as hardening of the logs in the storage layer as well, right? So this is the high level summary of the hyperscale architecture and the introduction to the read scale out scenario. Now let's dig deeper into a scenario, like what was the customer's challenge, and we will take an example of a customer, and then how that customer could leverage this architecture to mitigate the challenges in the existing system. So this is a scenario of a Contoso Mart customer, which is an e-com company, and they were using SQLDB premium DTU model earlier. That is also one of the tier of Azure SQL database. Eventually, this application, because this was a startup, they started up with the premium DTU model, and then, but then as and when this application started growing, there used to be the multiple applications got plugged in. Like for example, in the Contoso Mart, they had the another reader application of sales and marketing. That is a read application. So that sales and marketing started leveraging the same database for their operations, for their decision making and all. And again, as and when this application grew, an API, another API workload came in who was reading the data from the same database. Again, an additional API came into existence, which was actually capturing the pricing information, the inventory information. So this API used to fetch the data from the database and used to provide it to the application, right? So basically the workload started growing, and then the business reporting came into existence. Like they needed the business reporting for each day, and then they were leveraging the same database. And then came the monitoring dashboard. So basically, you can imagine this architecture as a simplified version of a modern database architecture, wherein all the different components are actually pulling the data from a single source of truth. Now, that actually created a problem. The problem was that it actually made this as a contention point where customers started facing the performance issues, they started facing the scalability issues. Since the storage was limited to 4 terabytes, they could not grow beyond that. The compute scalability was limited, and even the read scale out was limited to just one high availability replica. So now, because of these challenges, they actually switched or migrated to hyperscale tier, wherein they pointed the read-write application to a primary hyperscale database, and then the small application that I talked about, sales and marketing application, they spin up or added a small compute named replica because that application just had a smaller workload. So this named replica could cater it, and then thereby, like this sales and marketing application could actually manage their database on their own. Like they could scale up or down on their own, or they could manage the permissions or of their specific users on their own, right? So that actually gave them the flexibility, and even the cost part could be segregated, and then that cost of that compute could be paid by the sales and marketing team, right? And then came the API. So API also connected to a separate named replica or a compute layer. And then as and when this API workload like increased, or customer told like their critical workload was actually running through these APIs, which is to get the inventory data in a real time and then serve it to the application layer. So as and when that multiple APIs came into existence, what they did is they added multiple HA replicas or high availability secondary replicas to their named replica. So basically earlier it was only one named replica or a compute node that was serving the read traffic. Now they could offload another API workload to multiple HA secondary replicas. And then you can imagine this as a group of or a pool of read replicas. As of today, we can have like a pool of 5 read replicas in a named replica. Like specifically for one named replica, you can add up to 4 HA replicas, right? So that way they could handle their read workload gracefully. And at the same time, since I mentioned it used to be their critical read workload, they needed to ensure high availability of this compute layer so that the pricing information should be available all the time. Let's say even anything goes wrong with the primary compute of named replica, then the automatic failover will happen to one of the HA secondary replicas, and your workload will never be impacted, right? And then came their business reporting and the dashboard. They actually put up that business reporting and dashboard to a separate named replica with a smaller compute size. But then they wanted to save the cost as well, because the business reporting used to happen just once a day, and this dashboard also was pulling the data like once or twice a day. So what they did is they actually created or opted for the compute model as serverless compute. With that, they can optimize their price performance, because now they don't need to worry about scaling up or down of their named replica. It can be taken care automatically as and when the workload demands. It can be scaled up or scaled down automatically, right? So this is the and then another thing, as I mentioned, like this used to be a startup, and then as and when the startup started growing, their storage requirement also grew, and then the storage scalability was there. Like as I mentioned, automatic scale up of the storage was there, so their storage grow automatically, and they can grow to 100 terabytes, right? And then as and when their named replicas got stabilized, or they could understand, okay, how much compute is necessary for the named replica, they could actually reduce the compute size of their primary read-write replica to save or to optimize the cost, because now their read workload is actually pushed to the read replicas, which I'll show you how many read replicas that you can scale up to in a next demo, and you would see what is the latency numbers between those replicas. Let's have a quick look at the demo. And also, if you have any questions, please feel free to put those questions in the chat. I would be happy to answer those questions. All right, so this is a quick demo of an application wherein the application is we are ingesting data around 9.13 MB per second worth of data with a write refresh of 300 milliseconds. And you see that I have provisioned 30 named replicas as from 0 to 30. Like this is number 4, 15 and all. So if you see, this is getting refreshed, like we are continuously pushing the data, and the latency numbers that you see here are like around just 53 milliseconds, 52 milliseconds. So basically around 50 to 60 milliseconds worth of latency between the primary and a named replica because they're sharing the same storage. So latency numbers, you can see it here, and how you can leverage these replicas to scale out your workload. And then, as I mentioned, you can scale up to 30 read replicas or named replicas. Now, I also mentioned that each named replica can you can ensure high availability of that named replica as well, right? So now this Contosomat, for their critical workload, they required that we need a zone level resiliency. So what they did is they actually enabled zone resiliency for their named replica. And to enable zone resiliency for your named replica, basically what does that mean is that you now have the capability to create a named replica in zone 1 and then add an HA replica that will be put in a different zone altogether, so that in case any zone level problem happens, then the high availability replica can pick it up and it can start serving the traffic. So that way, and this feature actually got recently introduced in March this year itself. So now you can have zone resiliency for named replicas. And again, one more advantage of this is, for example, how Contosomat got advantages that for their business reporting, right? Let's say their primary compute is down because of any reason. Their business reporting will still continue because the named replica is actually reading the data from the page servers or the storage layer, and it has the data. Let's say it is not a current data if the compute is down, but it can still have the existing data, and it can still serve the traffic of your read request. So basically, you can imagine it as a resiliency at any step, any given point, right? And then provisioning it is very simple. It is just a few clicks of a button, and then your named replica with zone resiliency is provisioned. So I'll show you a quick demo of how easy it is to provision a named replica from the portal. However, you can provision it using the PowerShell, CLI as well. But let me show you a quick demo about how to create a zone resiliency in named replicas. All right, this is just a Contoso Enterprise database you see here, and it's a read-write database. I'll just show you the compute plus storage part of this read-write replica. Basically, the requirement is that zone redundancy should be enabled on a primary read-write replica. If you see here, it is enabled. And then now it's time to provision a named replica. For your existing Hyperscale database, click on Create Replica button, and then choose a replica type as named replica, and then choose the appropriate name of your named replica. Once you have chosen this name, you can actually go to Compute plus Storage and configure your database. In this configuration, you see you can choose the high availability replica to 1, or just click on Yes to zone redundancy. One HA replica is added, and the cost is also added for one HA secondary replica. That's it. Your named replica is provisioned. You just need to click on Apply, Create, and your named replica is ready. So this is named replica with zone redundancy is available and is ready to be used. So provisioning is very, very quick. It hardly takes about 60 seconds to provision a named replica. All right, so now that we have understanding of how named replica can be provisioned, let's quickly look at the additional capabilities that you have with named replicas. The biggest advantage, I would say, it's license and cost, storage cost is not applicable to named replicas. That means that you just pay for the compute only, and that compute you can utilize for your variety of read workloads. And I'll give you one example where one of the customer who is using named replicas, they are even using it for the testing purposes. Let's say they are building up any new query, read query, instead of testing it on the production environment, because let's say they have tested on the test environment, but then they actually wanted to have a look and feel of or experience how it will work on the production. Now they don't need to run it on the primary or a production read-write replica. They can just perform or test its query on a named replica, and then that's it. Their workload is tested, or the new development is tested, right? So, and then you can further optimize your cost by leveraging the serverless compute. If your workload is unpredictable, and right, so if your workload, let's say, is like as I mentioned in Contoso Mart example for Power BI and the Grafana dashboard, if your workload, let's say, is getting refreshed once in a day or so, you go ahead with serverless option, right? So it will automatically take care of your scale up and down. And then monitoring is very easy and available in named replicas from DMVs that you're familiar with. I'll show you a quick demo on this. And I was very excited to show you a demo of Database Watcher as well. That is something that we have recently announced this month itself. So I'll show you a quick demo of that as well. And auditing feature, it actually inherits all the auditing capabilities from the primary database to your named replica. And for a SaaS applications, like Elastic Pool is something is very much adopted for all your most of the SaaS customers. So now, let's say they have added the databases in Elastic Pool, and currently named replicas in Elastic Pool is not supported. However, if your SaaS database requires a capability to read scale out or scale out any read workload, they can simply add a named replica for a database in Elastic Pool as well. That is available. And then you can configure isolated access. For example, marketing team could actually, in the Contoso Mart app example, they could configure isolated access for certain set of users, which required access to only 2 to 3 tables. They could do that with the isolated access specifically for a named replica. And then you can mix and match your hardware. Like primary can be your provisioned compute, serverless can be named replica can be serverless. You can have zone resiliency on primary, and you may or may not want zone resiliency at a named replica level. So that is possible. You can do mix and match. Now let's look at a quick demo for a monitoring solution that we have, or monitoring of named replicas, or troubleshooting steps for named replicas quickly. All right. So this is just a portal experience. I mean, in the portal, if you open the named replicas, you can actually see the compute utilization, or like you see the primary read-write replica, and you can go to the matrix. You can choose whichever matrix you would like to, you're interested in to look at. So I chose CPU, and then I can look at CPU min max and all. That is possible. You can for named replica, you can monitor your performance from the portal, as well as you can monitor it from the SQL Server Management Studio, the same way that you were monitoring your existing read-write databases. So now the new function got added in the for the named replicas. That is the database property EX function. In that a parameter replica ID. You can get the replica ID of a connected named replica, and then you can utilize it for your monitoring purposes. Like this example of DM database replica states to understand the synchronization lag between your primary and secondary. Similarly, you can see any blocking. Similar way for primary, you can run those DMVs for named replica as well. And then named replica, like all the DMVs, like DM exec request sessions, all DMVs work for the named replica as well. Like in this case, you see what are the number of logical reads and all. You can have a look from your DMVs, right? So similar way, the query text you can extract from the sys.dm exec SQL text as well, from this SQL handle and all for all the queries. So I'll just quickly show you that as well. Execute. All right. So this is the query text I am running in the background. So basically, the intent is to inform you that there are same troubleshooting steps that you need to follow that you're already aware of, right? So DMOS wait stats, you can look at that as well. And again, I wanted to, continuing the monitoring part, a quick demo on database watcher as well. So this is the database watcher on the portal. Where I have created the 30 read replicas that I showed in the previous demo. I can monitor those 30 replicas. All of them are green. I can look at their CPU percentage. I can dig deeper into each named replica or a database in my database watcher, instance level CPU, data IO, basically environment in this monitoring tool that is the database watcher. Now let me go deeper into one of the named replica to see how it is performing. So I can have a look at that as well. So that is how simple experience you get, or the capabilities that you get with the Azure SQL database world, with all the latest and greatest features and hardware that you're getting, right? Now, let me show you one more example of a customer or a customer story. So basically, it is DHL, a very well-known or a world-leading multinational logistics company. So they were actually having a problem during their on-premises world. That is, they were bearing huge amount of cost for the provisioning that they had. So with Hyperscale, they could actually mitigate that problem because, as you are aware, that we have recently announced in December 15th of December last year that there is no license cost for Hyperscale database now. It is as good as, or it is, the cost can be compared with your open source databases now. So if it is a startup, Hyperscale is the choice for the customers now. So the cost factor got mitigated, and then they didn't have the flexibility to innovate in the on-premises world. So with Hyperscale, they got that flexibility to cater their increased demand during holiday season, especially like Christmas and Easter, right? They could add, or they have actually offloaded their complete shipment tracking workload to the named replicas. So as and when the increased demand demand increases, they can increase the compute as well. It's just a few clicks of a button. So yeah, so that is how DHL got success with Hyperscale, and there are many customer examples. You can go to customers.microsoft.com where you can see the customer stories of a lot of Hyperscale customers who got the success with Hyperscale. All right, so that is it. What I had for this session. Now, for this Azure developers, you can actually start your learning journey by going through this link, that is aka.ms/Azure Developers.net. They learn more, and you can also go for a Cloud Skills Challenge as well by going through this link. All right, and then you can download .NET 8 now by going through this link. And also, if you would like to optimize your on-premises .NET application for Azure, our migration Azure Migrate application, actually, if you go to this link, and code assessment tool for .NET provides a detailed analysis of your application. So go ahead and try this as well. Thank you.
That was a wonderful session, and that closes out the first half of the day. So I want to give everyone just a quick 10-minute break before we jump into the second half, which is super exciting and so much fun. We have a ton of great sessions and experts coming to you for the other half of the day. I do want to plug the rest of the links really quick one more time. The Azure Developer Hub is a great place to find resources, samples, any new information that we have of new products coming out or updates. Today's agenda can be found at this link as well. to learn about all these great sessions that are coming up this afternoon, so you can stay tuned. All the session links are also included in there we go, this link over here. So anything that you've seen in the sessions that you're really interested in trying, in downloading and learning more, all of the session speakers have provided us the links and the calls to action, and they will be included at these session links there. Finally, as most of our speakers have been mentioning, we do have the Cloud Skills Challenge, and I highly encourage everyone to go check it out. I am joining, I am doing it on the side. I have really enjoyed it, and just making sure that I can get more use out of all the things that I'm learning today. So with that, I'm going to take a 10-minute break here. And so everyone go grab a coffee, get ready, and we'll see you back here in 10 minutes. That will be 10:50 Pacific time. So it's 10 minutes from now, I guess 11 minutes from now with the next session. See you all very soon. Welcome back, everyone, to the second half of the day. We are not quite halfway through with all the content, but we took a nice little break just to get some coffee and to refresh ourselves for the next group of sessions that are on developer productivity. So I'm going to invite Luce up to the stage here to talk about our first session in developer productivity, and that's on MongoDB. Hello, how are you?
Hey, I'm good. Very excited to be here.
We're excited to have you. We really appreciate you joining in.
I always love an invite.
Well, I will let you take it away.
No worries. So I'll just wait for my slides to show up. There we go. Perfect. Cool. So hi, everyone. So I'm here to talk to you about what's new in MongoDB for Azure developers / .NET developers. So I'm Luce Carter, a developer advocate at MongoDB and also a very proud Microsoft MVP. Now, for those of you wondering what developer advocate is, these days people know, but just in case, basically my job kind of entails being part developer, part product, part teacher. Basically, I get to go and learn new and cool things happening in the MongoDB space, teach it to you through videos, tutorials, and like today, giving talks. So I'm really, really excited to be here. So what are we going to talk about today? Well, we're going to start off with what is MongoDB. Then we'll answer the question, well, why MongoDB? More importantly for Azure developers, why MongoDB over Cosmos DB? Then we'll start to look at some code things around semantic kernel and Azure OpenAI. Then we'll have a look at kernel memory and what that is. Then we'll end off with MongoDB provider for EF Core, what that is, why it's exciting. Then I'll give you some useful resources that hopefully you can go away and take a look at and get some value out of. So what is MongoDB? If you're watching this talk, you may already know, but I actually learned a long time ago to never make an assumption of audience knowledge. So for that reason, I just want to take a couple of minutes to just do some basic explanations of what MongoDB is. So at its core, the main part of MongoDB is a document database. It's similar to a key value database, but it supports more data types like embedded documents, so essentially objects, dates, different types of numbers, and many more. It also stores information in collections of documents rather than tables with rows and columns. So a document is kind of a row, and then a column would be a field in that document. As you'll see today, and if you've ever seen anything on MongoDB, it's general purpose. So it can be used for lots of different things, whether it's an operational database, vector database, time series database. And if you saw our customer list, you'd see that we really do cover a wide array of things. So very much general purpose. We also have a flexible schema. So you can have your documents in your collections be a different shape and size if you want to. If the thought of that frightens the life out of you, don't worry. We also have the ability to set schemas and data validation. So if you want your documents to all look the same, you can do that. But there are times when you're proof of concepting things that maybe you just want a bit of flexibility in what your documents look like. Plus, we support horizontal scaling. And historically, that wasn't always as easy. So it's just, one part of document databases that's considered a good feature. But MongoDB is actually more than just a document database. It's a full developer data platform. So we have the database itself. We have Atlas Device SDKs, which is basically a suite of development tools for working with things like on-device databases. So you might historically have heard of Realm, which we purchased a few years ago, which kind of acts as your local database. But you can take advantage of that local database to enable offline functionality while using device sync to handle keeping that data in sync as the network availability changes. Charts allows you to create various types of charts and graphs, so you can visualize your data stored in MongoDB, and you can even carry out pre-processing of the data before it even is shown. So that's cool, adds even more power. And personally, I think Charts is one of my favorite products because I don't need to write any extra code with a third-party charting library just to show patterns or interesting things about my data. Analytics is also useful because you can run analysis of your data, and it even supports Microsoft products like Power BI. Lastly, we have search, and this is a key feature of what you'll see demoed in this talk today. So we have two types of search. We have full text search, which is built upon Luce's full text search engine. And this allows you to just search your data based on text without needing to code in integrations from third-party search tools. And then there's also vector search, which allows you to search beyond just text. And we will discuss that in later slides. So that's what MongoDB is. But why use it over something like SQL? Well, MongoDB and document databases just make life easier. There's high availability. So I won't get too technical, but MongoDB clusters are made up of 3 nodes that are kept in sync. So if the primary node goes down, one of the secondaries will be promoted to primary, so your database will just keep running. As we mentioned, it's also highly flexible. So documents can have different shape and size, and that supports that flexibility. It's scalable vertically. So like with relational, everything's relational. Like with SQL databases, if the server needs more hardware to perform, it can. And it can also scale horizontally, as I mentioned. So historically, horizontal scaling was less common in tabular databases. So horizontal scaling was a big benefit of NoSQL databases like MongoDB. And MongoDB does this using something called sharding. So it breaks your data into groups, aka shards, based on an attribute you decide, and then spreads that data over multiple servers. And this is great when you have maybe millions of documents and you need improved read performance, for example, because a query can then use that shard key to know exactly which server to use to resolve that query, just saving time searching through all those millions of documents. And then lastly, there's readability. Documents just look like JSON documents. And those of us used to C family languages like good old C# are used to JSON documents. So it's automatically readable. But you can summarize all this really as build better apps faster. In the past, the most expensive part of databases was the hardware, especially storage. But these days, with reduction in cost of storage and processors, actually the most expensive and valuable part of data storage and application development is the developers themselves. So you. So why not make it simpler and easier for you to create awesome things? Okay, Atlas. So we talked about MongoDB as a developer data platform, and a key part of that is Atlas. Atlas basically is MongoDB's fully managed multi-cloud database service. These days, it expands to be that whole developer data platform, including more than just databases, including the Atlas search and Atlas charts that we discussed earlier. But why would that matter to Azure developers, right? Well, this is a cluster deployment on MongoDB Atlas. As you can see, this is deployed on Azure in the North Europe region in Ireland. Even better, it's an M0 tier cluster, which is our free forever tier that doesn't even require you to share credit card details. So it's great for just trying and creating proof of concept applications without any kind of financial commitment. And if you're like me, you'll start 1,000 side projects a year that you never finish, and it's super cool that you can do it without paying for it. So this clip here shows how easy it is as well to actually configure Atlas to create a cluster and deploy it to Azure. So we can just go ahead and click create. It will bring up a wizard. You can then fill it out. So you can pick M0 and you can have one per project. There is a sample dataset box, but you can load more later on that we'll see. You can pick Azure. Then you can pick which region you want to deploy to, and then just go ahead and click create deployment. Sometimes it will give you a nice capture box. Who doesn't love that? And then it will just go ahead, start deploying it, and bring up this guide if you want to. So you can generate your first user, you can add your IP address, and then it will talk you through other stages if you want to. And what's cool about MongoDB as well is if you just want to play around, we have a whole set of sample data. So we saw that little tick box, but there's actually more than just that little sample you get from that tick box. And this sample data comes in all shapes and sizes, and you can load it into any cluster. And it represents all sorts of interesting data, such as Airbnb listings, restaurants, movie, even shipwrecks. And loading the sample data is as easy as clicking load sample data on this overview page of your new cluster. After a couple of minutes, you'll then have an array of data to play around with without needing to make your own. But that's Atlas, and you're an Azure developer. So you might be wondering, well, why MongoDB Atlas over Cosmos DB? Well, as you may know, Microsoft offers this product called Cosmos DB with MongoDB API. And this is a NoSQL product offering that I think's been around since about 2017. But the issue is it's more of an emulation of MongoDB, so it imitates the features and doesn't necessarily always have full compatibility. In fact, one of the things we see a lot is that people often raise issues with the Cosmos DB with MongoDB deployment with us, thinking we're behind it, and then you end up wasting more time trying to get help from the right place. And those differences might be okay for you in your application, and which you choose is up to you, because both have full pros and cons. We are happy partners with Microsoft, which is exactly why I got the honor of being invited here today. So, it's not a competition. It's just about which one works best for you. But I do recommend that for the full experience, MongoDB and specifically Atlas is the way to go. But some of you might be thinking, well, why would I pay for Atlas when I have an agreement with Microsoft that provides Azure credits? Well, guess what? That doesn't need to hold you back, because we have an official product in the Azure Marketplace allowing you to use your Azure credits to pay for an Atlas subscription, so you can get the benefits of Atlas without paying any extra. Woo, winning. Okay, so that's the kind of scene setting stuff and just giving you an idea about MongoDB and Atlas and some background info. Let's start actually looking at ways that you can work with Atlas and Azure products in your applications and some of the latest advancements in our, what I like to call, long-standing partnership. And it's true. So first up is Microsoft Semantic Kernel and Azure OpenAI. Well, what are they? So Microsoft Semantic Kernel is an SDK available in multiple languages that integrates LLMs such as OpenAI and Hugging Face with programming languages such as Python, C# and Java. And it allows you to integrate out of the box community and custom plugins that can be chained together to achieve great things as a combo. You can use OpenAI or even Azure's own managed OpenAI product. Plus, it supports connectors for other storage engines for memory storage, such as, MongoDB Atlas, Chroma, DuckDB, Redis, and others. Okay, let's look at a demo movie recommendation bot that I wrote that uses Semantic Kernel, Azure OpenAI, and Atlas. So this is a very professional looking console application that I ran. So it asked you, tell me what sort of film you want to watch. So we can ask it something like, I want to watch something about music. It will then go away and pull in the information. So it will do a search for you. It will then give you the title, the plot, the year, and a relevance score. And we can even keep asking it questions like, maybe we want something about sharks. And again, you get those results back really, really, really quickly, which is one of the things I love about the connector with Atlas and Semantic Kernel. That's a simple bot, though, that queries our data. So that's cool. And it was really fast. But how does it work? Well, as I mentioned before, it uses Semantic Kernel. So it uses a MongoDB Atlas cluster for storage and Azure OpenAI for generating the vector embeddings using the chosen model. But this, again, we try not to assume any knowledge. So what even are vector embeddings? Like I say, the mantra I shared at the start is I never assume any audience knowledge. It's good to understand at least a little bit of what vectors are and how that links to products like Semantic Kernel. So vectors are a set of numbers in an array that represent the data. Each number represents a specific characteristic of that data point called a dimension, and that's what's learned by a model in machine learning. How many dimensions or numbers in the array can be specified when the vector is produced. So basically, the more dimensions, the more contextual information it has to use to find, related data points. And producing these vectors is known as embedding. So something like the string here, quick brown fox, might end up looking something a bit like this, just with more numbers than the one you see. And obviously these numbers are just a bit random, but yeah, essentially, if you generate the embeddings, you'll get something that looks a bit like that. But how does embedding work? Well, the data is sent through an embedding model, such as a popular one for text data called text embedding A002, which if you've had any kind of, touched on or dipped into any kind of AI stuff before, you might have heard of this model. And then the vectors are produced as the output. But the vectors that are produced need to be stored somewhere. And this is where a database like MongoDB comes in. You can store your vectors, often referred to as embeddings, in place in your database alongside the data. And it's just stored as a new field. And it makes sense to keep the fields containing the vector data within the same document as the data it represents, because it just helps improve performance. And this is what's cool about MongoDB. It can be both your operational and your vector database in one. And then the encoder in the middle, this is just a machine learning algorithm that can be run locally, hosted privately, or just called via an endpoint or API. And in Azure, this will be where Azure OpenAI comes in. So it's a managed API for generating embeddings based on the popular OpenAI models. And OpenAI is currently, Azure OpenAI is currently in preview, and you can request access as a business by filling out a simple form. I say as a business because a few weeks ago, I think around Easter, when I requested access, it did make it clear on the form that if you had a personal account like Gmail or Outlook, it wouldn't be accepted. But once you've been approved, which I found happened quite quickly, you then have access to the ability to deploy an endpoint linked to a specific model that you can take advantage of in your applications. And creating them is really simple. So we've got these two deployments here already, but if you want to make your own, all you need to do is click Create New Deployment, select which model you want. So at the moment, we have GPT-3.5 Turbo, text embedding ADA002, or Whisper. As you can imagine, we're going to pick the text one. Then for model version deployment type, there's only one option, so that's nice and easy. Give it a name. I don't know, Azure Dev Day Demo Talk, or Text Demo, Text Model, I can't remember what I called it. There we go. And then just click Create. And just like that, almost instantly, you have your own deployment. And that deployment name, make a note of it. Obviously, you did just name it yourself, but just make a note of it because as you'll see, it will come in useful later. Okay, so how do we combine these to perform a search of our data that we have stored? Well, first we generate embeddings for the data you want to search. So in our case, we can use the Azure OpenAI deployment we just created. We can store those vectors as a field of embeddings in our database. But we also need to create a vector search index just to let the database know where to find the embeddings and what similarity function to use. Which similarity function is essentially the search's way of how it will find what it wants. There's different ways of doing comparison. Then we need to create the embeddings for that search term, so both available as vectors for comparison using that similarity function. And actually, thanks to Semantic Kernel, steps 1 and 4 are done for us automatically. And step 2 is just achieved with a plugin called Semantic Memory that we'll see in code in a minute. Ooh, hang on, there we go. So how do we do it in Atlas? Well, you can do it in a few ways via the Atlas Search API, the Atlas API, might be Atlas CLI, anyway, programmatically in code, or via the Atlas UI in the browser, which I'll show here because in the browser is just much easier to see as a demo. So we've got our cluster here that we've deployed and it has the sample data loaded. We can just go into it and say, create a search index. We want to go under Atlas Vector Search at this point rather than full text search. You can see we've only got JSON editor as an option, but we can go in. We can then specify which document, database and collection to find the field that we want. And then we can give it a name if we want. And then we just have to fill in a couple of things. So first is the path. So that's the name of the field to find the embeddings. In this case, I happen to know that the field is called plot embeddings. We pick those number of dimensions, which is 1536. Then we pick that similarity function. So you've got 3 choices, but we're going to pick cosine as our function, which uses the angles between the vectors to find the similarity, just because that's what Semantic Kernel supports. And just like that, you have your index. Within a couple of minutes, once it's indexed all your documents on that field, you will get an email to let you know that your search index is ready and you can start using it. Okay, so we have everything in place to carry out those steps. Let's see the actual code used to make that movie recommendation bot you saw earlier. Well, because we want to store information, search it, retrieve it, and remember it between sessions, we want to use that memory plugin, which is accessed via a memory builder. So we set up the text embedding generation service. In this case, we're saying with Azure OpenAI, and we pass it in the details. So we have that deployment name that I mentioned earlier is worth remembering. Once you deploy it, you'll also get a endpoint, and then you've got your API key, your model name, and anything else that you might need. In this case, that's all you need. We then create a MongoDB memory store using that connector, which is available as a NuGet package, and we pass it to our connection string. We just pass it the connection string, the database name, and the name of the search index we want to use. In this case, it would be that vector underscore index default value from creating the index earlier. Note, semantic kernel, though, can only work when the field containing the vectors is called embedding singular. So this is a feature, and we'll discuss a solution to that later. But for now, we can't use the embedded movies collection that we just created an index on in the sample data set because that field is called plot underscore embeddings, not embedding. And so for that reason, we just have a method that we can call that only needs calling one time, called fetch and save movie documents, which solve that problem. So there's a few things that happen in this method. Let's just talk through it. First, using the MongoDB C# driver, we've already got a client and a database and collection defined. And in this case, we call it movie collection. So we fetch the number of requested documents from the movie collection. Then we loop through each one. And some documents have no plot field value just because we wanted to show what flexible data might look like. So some of them don't have a plot. So we just do some error handling by just replacing it with the word unknown. Then we just add each document into our memory store, assigning values to the fields in the way that's most useful. And by calling save reference async, it's not only saving it to a new collection in our Atlas cluster, but it also generates those text embeddings for us with Azure OpenAI at the same time. And it leaves us with a field called embedding. So this is an example document taken from the cluster that shows the metadata object containing the things we care about, such as the title, plot, and year of release. You could also use that additional metadata field just to store any custom schemas that you want to be able to generate or search against, should you wish. So this code looks a bit more complex just because I'm using the wonderful Spectre console library to make it look prettier. So you might have seen the green text color and the table with the headers and everything. But the main search code itself is actually really simple. We call search async on our memory, just passing it in the collection to search the search term, and then how many results to return and the minimum relevance score we want. So if it falls below that threshold, we just don't consider it accurate enough for what we want to see, so we just discard it. This then returns something called an async enumerable of type memory query result. So we're using a wait for each, so we can loop through each result or memory and just populate the rows in the table before printing it out. And as you saw, it was super, super responsive. But you may have noticed a few things already with semantic memory and semantic kernel, which limit us or cause problems. Firstly, it only supports text as a data format, which isn't great if you want to take advantage of things like image search. Secondly, you can only use the cosine similarity function, which is best for less dense data such as text. So this makes sense when you consider 0.1, but it's still not great. Thirdly, it only supports C#, Python, and Java, and those connectors and community plugins vary in their availability between language. So Microsoft, being the great company that they are, took these experiences, lessons learned, and feedback and generated the next evolution, kernel memory. Kernel memory is a multimodal AI service specialized in the efficient indexing of documents and information through custom continuous data pipelines, with support for retrieval augmented generation, synthetic memory, prompt engineering, and custom semantic memory processing. So I took this from Microsoft memory, kernel memory GitHub page, but that sounds a bit businessy. So what does that even mean? Well, it just means it can support more data formats, including images, PDFs, JSON, Word documents, of course still text, but just a lot more than that. It can also support hybrid search using and/or filters and just move away from cosine as the only available similarity function for comparison. It can also support more languages than just those three, so you can have chatbots, maybe CLI tools, browser extensions, and others, even low or no code solutions. Plus, it supports a broader range of storage engines. And there's some other benefits that are a few of my favorite. It can support RAG with sources lookup, so you can create much more powerful experiences, including chat, without actually needing to code in your own support for the history and shared context. It supports custom storage schemas, which means that we can move away from that funny looking document shape we saw earlier with the metadata bit fields containing the main things that we care about. And you can start using something that's in the shape that you want. It can support vector databases with internal embeddings, which means we won't have to generate embeddings for data that already has them, so we can get away from needing that field called embedding. As I mentioned, we found, there's a way around that. That would be kernel memory. So where you've got the ability to use tools like OpenAI or Azure OpenAI and even Hugging Face and others to generate embeddings, you now can store them in MongoDB Atlas, and kernel memory will be able to use those without needing to go through the hoopla of pumping a bunch of documents in. And we can use even more LLMs, including Llama Sharp, and as, which means that we can have what I am naming here and now TM Calm Stack, C#, Azure OpenAI, Llama Sharp, and MongoDB. We may even end up with Mac as well, so MongoDB, Azure OpenAI, C# and kernel memory. Now, you might notice I use MongoDB in both those stacks, which leads us on to the question, if semantic kernel has a MongoDB connector, well, what about kernel memory? Well, of course, thanks actually to an awesome member of the community. So it hasn't been fully tested by Microsoft in their full suite of tests. So although the PR has been merged, it's not available in the NuGet package for kernel memory just yet, but fingers crossed, it will be available really soon. At the moment, I have this Blazor application. It's available on GitHub that I wrote using my, as you can see, amateur design skills to display movies available in the sample data set. But there's a search box at the top, as you can see, and depending on which GitHub branch you use, this is either doing full text search to find movies that match the title entered, or it uses vector search. And this is just a quick vector search in action. So we can just go in and we can type something. So maybe we want 3 men and swords. We can just click search. It'll go away and use vector search under the hood to find it. And hey, look, we find things like 3 Musketeers and other ones like Sword and the Sorcerer, Crouching Tiger, Hidden Dragon, Dragon Tiger Gate, anything that it deems from that search that is similar to 3 men and swords. Now, this example currently uses the MongoDB C# driver, which brings in vector search as part of our advanced querying product called Aggregation Pipelines, which is available in nearly all our drivers. But what I would love to do is actually migrate this to use kernel memory and add a chat feature that allows you to have a full-on conversation with the bot. So you can search on not just title or maybe poster image, but actually get recommendations via a full conversation. So you can ask more than just one thing, like something about music. Whew. Cool. So that's cool stuff with AI using Atlas and Azure. But what else? Well, I just want to briefly talk about something else. Entity Framework, and more specifically, the MongoDB provider for EF Core. Many websites hosted on Azure App Service use Entity Framework. Plus, statistics and surveys by third parties show that MongoDB is the most popular NoSQL database for C# developers. So it's no surprise that one of the most requested features of Entity Framework was a provider for MongoDB. So for a while now, Microsoft and MongoDB, as the great friends that we are, have been collaborating on a new provider for Entity Framework. And the exciting news is that on Thursday, this very coming Thursday, at our .local NYC, so New York event, you will hear that the provider is going GA. Woo. I wish I was on my Mac now because I could play confetti. But anyway, for those of you interested, here's just a quick snippet of some interesting things about the provider that you might want to know. So this is from another demo available on GitHub, which is using a tutorial I wrote and recorded on YouTube as well on how to get started with the provider. And it's just a demo of a car booking system, nothing exciting. So we have the car booking DB context. And just like with any Entity Framework code you already have, it just inherits from DB context and has DB sets for our models we want to store. We can also override the onModel creating method if we want to provide further information on our entities. But is there anything special about these car and booking classes? If it's a new provider and it's not using SQL under the hood, is there anything different? Well, let's look at car. The first thing to note is the use of this attribute here. So it's just a standard C# object, this class, but we add the attribute from the provider just to tell it what collection to map to in MongoDB. The rest is just properties, apart from that special object ID, which is just a data type of the primary key in a MongoDB document. And actually, when the provider goes GA on Thursday, you'll find there's an easy way to not use object ID anymore, but actually use the string and get back all the string methods that you're used to and it will automatically handle mapping that between object ID and string for you, just like in the C# driver, which really the provider is just built on top of. But the rest is just standard C# code, and these other attributes you see here, if you've not seen them before, they're just standard web attributes, I believe related to MVC for a form. And then inside programs CS, you just set up entity framework in the same way as before, but adding a DB context. Then you just, instead of using something like .use SQL Server, you just have .use MongoDB, and you pass your connection string and database name. Then you can just use entity framework in the same way you're used to. So, that was a whistle-stop tour. Well, the main things to take away from this are that MongoDB and Azure are great friends. No matter, you can share your credits if you want to, so you can enjoy Atlas while using your Azure credits. Semantic kernel with MongoDB connector is the first step towards AI with an awesome storage solution. You can combine that with Azure OpenAI and Atlas Vector Search to perform text-based queries. And then kernel memory is that next evolution that allows you to do more than just text search. Excitingly, as well, MongoDB's provider for EF Core is about to go GA. And the main thing to remember, things are only going to get better. So there'll be a link and a QR code to access this gist on the next slide that I'll leave up, but this is just a list of useful resources I think you'll get value from. They just include things like content and tutorials I've already mentioned, our developer center where you can find lots of C# and Azure content to get started. And as I say, just keep an eye out on Thursday for our .local New York, which will also be some of the sessions, like the keynote will be live streamed on YouTube. Then you can watch out for sessions later where you can learn more. Thank you.
I'm going to unmute myself. Thank you so much, Luce. I'm going to pull your quote, the things are only getting better. I'm going to keep saying that. Our products can only keep getting better, and especially when we get feedback from the community. So yeah, join the live streams, comment on these videos. Let us know what you think, what you use, what works well, what questions you have. That's how we make these products continually improve and get better for your experiences.
Yeah, absolutely. And, I'll be in YouTube chat for a while after this. If you've got any questions, fire away.
Yeah, I saw a whole bunch come in already, so I think
amazing. I'll be sure to go and answer them all while we enjoy the next amazing session.
Yes, thank you so much. Enjoy the rest of your day.
Thank you for having me.
All right, we are going to move on to API Center. So if you're anything like me, I have a bunch of APIs and I want to learn how to manage them well. So I'm going to bring up Justin to teach us a little bit more about the Azure API Center.
Right. Hello, everyone. Welcome to the Azure Developers .NET Day 2024. I'm Justin from Microsoft as Principal Cloud Advocate. Today, I'm going to talk about Azure API Center that empowers .NET developers' application development velocity. As developers, we are both consumers and producers of APIs. Almost every day, we use APIs. At the same time, we develop APIs. But from the maintenance and governance point of view, are you really sure that your and your organization's APIs are okay? A report says that more than 90% of organizations will invest more on APIs for the next 12 months. It was 3% increased from the previous year. The same report also says that almost half of organizations, they spent more of their development effort for working with APIs. So what do those numbers really mean to us? Our application ecosystem consists of the vast number of APIs, and we rely on those APIs. But it has caused a lot of trouble to us, especially within organizations. It's called API sprawl. In other words, in our organization, there are too many APIs scattered out and out of our maintenance. with poor maintenance effort. As a result, not all APIs are feasible or managed. API discoverability and usage rate are lower than expected. There are unused APIs called shadow APIs or zombie APIs, and they have become the targets from the malicious attackers. And those APIs have been away from our compliance, organizational standard compliance. So these kind of things we have been experienced a lot because of the API sprawl. Therefore, there have been many requests for the central inventory of organizational API portfolio. It doesn't matter where the APIs are hosted. They need to be managed in a central repository. It doesn't matter what type of APIs are. They need to be managed in a central repository. So that we all know the APIs we've got in our organization are properly governed, like where they are, what their current statuses are, how compliant they are, and so on. Based on those requests, we now have introduced Azure API Center to be acting as the central repository of your organization's API portfolio. So, with our Azure API Center, you can register all sorts of APIs, including OpenAPI, WSDL, GraphQL, gRPC, and more. You can also manage the lifecycle of those APIs from design and development to deprecated and retiring. You can also manage metadata of individual APIs, like who the owner is, whether it's compliant or not, whether the code where the code repository is, and so on. And you can also handle events raised from the APIs about API status changes. And you can, with this event, you can take further actions. Now, so what kind of Azure API Center offer for us? First of all, API Center offers you with this API inventory feature. So like this one, you can register new APIs through GitHub, Visual Studio, and Visual Studio Code. There are a bunch of existing APIs already in your organization. So how can we handle these kind of existing APIs then? You can register them into Azure API Center with simply running the command like Azure CLI or import from Azure API Management. You can also register shadow APIs that you don't directly manage, but you want to keep in feasibility. What about the governance of your APIs? Building and maintaining APIs are important, but at the same time, governing those APIs is as important as building and maintaining them. So Azure API Center offers many governance capabilities, including API metadata tracking and API process automation, API design linting, and so on. Another great feature of Azure API Center is discoverability and ability to consume. What that really means is, here are a few examples. We are offering an open source based Azure API Center portal, so you can deploy and customize it based on your organization's needs. There are extensions for Visual Studio Code and GitHub, so that you can easily integrate your APIs with your preferred developer tools. And of course, with GitHub Copilot, you can analyze your APIs within Visual Studio Code to get more shift-left experiences before actually deploying it into the cloud. Right. Now, I'm going to show you a few demos how API Center is used to accelerate your development experience. I'm going to quickly build an ASP.NET Core Web API and get the OpenAPI document from here. Then with this OpenAPI document, I'm going to run the client-side linting using Visual Studio Code extension. And once the linting is over, I'm going to register those APIs to Azure API Center with various ways. Then I will show you how the server-side linting works. Then import existing APIs from Azure API Management and handle some custom metadata things. And finally, I'm going to test your registered APIs from your local machine using Visual Studio Code extension and generate client SDKs. I mean, .NET Client SDKs to integrate with your existing application. Okay, let's go into the demo. Now, I have Visual Studio. So I have Visual Studio. Then I'm going to run the .NET application. So I have the API application. So I have API application and a front-end application. So I'm going to run this API application. So see how it's going. Now, once it's done, then it will automatically show up the Swagger UI screen. So let's wait a few more seconds, then it will show up. Once the application is built, then the Swagger UI will be showing up. So let's wait a few more seconds. Now it's being built. Okay, so we have now we have the API application, right? Now, so when I click the Swagger UI button here, and this is the actual OpenAPI document. So I will copy this over, and put into here. So weatherforecast.json file. Then it says, okay, so that's the normal application. And as you can see, there is a yellow line and there is a red line. And with this red line, it says something is wrong, right? And what this happens because I used the API Center extension, right? And if I install the API Center extension, and then I can do setting the API style guide like this. So there are a few menus, including Microsoft Style Guide and OWASP Style Guide as a default. So I will, if I change to use the Microsoft Style Guide, then that linting result will be slightly different, right? So it used to be some sort of red lines here, but now it all changes to yellow line. And if I change it to the OWASP style, then it changes a little bit there, right? So yellow line and red line here. What that means is that each style guide has a different rule set. That means your organization can customize your that rule set for your business requirement. So I'm going to change it to some sort of the custom rule set. So there is a rule set called resources rule set here, and open this. Then it will change the linting result. And there is the yellow line, and there is another, the red line here, and it is based on this rule set. So that rule set comes from this one. So it is based on the OpenAPI spec. Then my organization wants to put some additional value on there about the versioning stuff. This is the versioning stuff, right? So, but in here, there's a bunch of yellow lines and red lines. I have no idea what that really means. So let's go into the GitHub Copilot chat so that we can analyze what that really means, right? So I'm going to ask GitHub Copilot about this. So workspace, explain weatherforecast.json file. Then it says, okay, so I need to choose which line I need to get explained. So I choose that red line here. Then it says, okay, it's about the versioning stuff, okay? But it doesn't say anything what is wrong here. So I choose this the rule set as well. Then again, it asks the GitHub Copilot again. What I need to change here. So based on the oas.yaml file, what should I do? Then it says, okay, it used to be version 1.0, but based on this rule set, it should be changed to like v1.0, something like that. So that means my organization has the standard of versioning standard, right? I mean the versioning formatting standard. So, right. So how can I change these kind of things now? So now I'm going to update our API application to make this happen. So there is a program, the CS file. Then, so I will comment out, and I will comment in, uncomment it, and I will also comment out, and I will also uncomment this. So by doing so, when I go into here, it has more like the metadata information is there. Okay, and with here, so I have versioning thing as well. So let's take a look. Then I will build this application again, and what will happen? So I will run this application again. Okay, I will run this application again. Then it will show us some sort of different results. Now, so once application is built, and it will show up a different Swagger UI screen. So let's take a look. Now, so we have different Swagger UI. Now, so as you can see, this is the previous one, and this is the new one. So can you see the differences? So I put all those things and make it more descriptive. So if I click this one, then it changes the version as well. So I will copy this file and put into the Visual Studio Code again. There is no yellow lines or red lines, but let's change a little bit here. You don't see the real changes. So I'm replacing the existing OpenAPI document with this one. Now, it used to have a lot of yellow lines and red lines. Now it's all gone. That means our OpenAPI document is compliant with our organizational policies. I didn't say the previous, the weather forecast JSON file is not compliant with, it's not following the OpenAPI spec. It follows the OpenAPI spec, but now it's compliant with our organizational policy by running the API linting on Visual Studio Code. Now, our application, our API document is ready. Now I will upload this the OpenAPI document into the Azure API Center. So there is the API Center, the already provisioned in our Azure portal. Then the first one is using Azure portal. So click the register API, and let's say, oops, weather forecast API, and API type is REST, and version title is version 1.1.1. Now it's all done. So let's create. So while I was doing that, oops, on the version lifecycle, another one here. So let's say it's a design phase. Then I will create the APIs, and it creates API and version, and create it here. I created version as well, but I didn't put any OpenAPI document yet. So once go into here, then I can add definitions, right? Then once it is the opening up, so definition screen and here up here. Now I'm going to add OpenAPI document here click the add definition button. Now let's say weather forecast API. Now the space name is OpenAPI document, and I'm going to choose my OpenAPI document that I just showed you. So if I click the weather forecast review.json file and then create the one, So it will upload our definition page. And once I click that, then they will show you about the API definitions. So I click the show definition, and it shows us with the API document that I just uploaded. Now, API definition is coming up. So that's the API document that I just uploaded. Now, there is another button here, analysis here. So that's actually the server-side linting. So I showed you with the client-side linting with Visual Studio Code. The same thing is happening within the API center. So there is an error, there is a warning sign. Because I put the latest reviewed version of API, so there is no error or warning, right? So this is how the server-side linting works. Then, now I'm going to add another APIs to the API center through Visual Studio Code. So there is the Visual Studio Code. Now I'm going to go here, API center, and if I refresh this one, then there is a weather forecast API that just registered. Now, if I click the register API here, and there are two ways. One is the manual way, and the other one is the the GitHub Actions way. So I'm going to choose the step-by-step, and then API title should be Pet Store API. And it is REST API, and the version is 1.0.11. And we can say development, and definition title is Pet Store API. And it is Open API, and I'm going to choose that the Pet Store API here. Now, the API is being registered through the Visual Studio Code, then it will be registered like this. So I have Pet Store API registered in the API center with this, like this, right? So that's all good. Now let's go back to the Azure portal there, and so there is APIs. So I just register Pet Store API. But this time, let's go into the API analysis as well. So how's the difference? So there is weather forecast API that I just registered through Azure portal, which doesn't have any errors. But Pet Store API has errors and warnings like this. But it doesn't mean that Pet Store API there is an error. It's not compliant with our organizational policy. So we might need to slightly accommodate the Pet Store APIs to be compliant with our organizational policy. The Pet Store API itself is working, but it's not compliant with our organizational policy. That's the main thing, right? Now, this is how the server-side linting works. Now, once we go into the Pet Store API, let's go into the Pet Store API here. And there will be that API is built by a third party, but we haven't completed compliance reviewed, right? These are the custom metadata thing, right? So this is the custom metadata that we can add for the organizational policy. So, for example, if there is an API where this API code is hosted, something like repository URL. And if the API is registered, what sort of compliance review process has done or not. So this kind of the flag is here, right? So these kind of things we can do the thing. Now, there is interesting thing is that API Center has the event grid integration. So there are a bunch of event handler like this, and these event handlers are coming from the logic apps here. So if I register the APIs and it has something like, it shows that event captured by, event captured by like this. So with this logic app, we can do event handling. But in here for now, we only capture the event in the raised, right? when we put the additional logic in the logic workflow, then we can handle those kind of custom metadata things. But for now, I'm going to use the Azure CLI for to handle those events. So let's get back to the Visual Studio Code here. That now I'm going to run the custom metadata things. So I have resource group, and I have the API center, and I just registered Pesto API, right? So this needs to be reviewed. So this needs to be compliance reviewed. So I get the custom metadata. Now I got the custom properties, which means these custom properties, compliance review, need to have value, like need for review. So with this Azure CLI, the command, so we can update custom properties like this. So if I run this application, run this command, then it will show us the custom metadata properties updated like this. So let's get back to the portal. Now, I have APIs, and before I was showing you, before that, Pesto API doesn't have compliance reviewed value. Now we have the compliance reviewed, the properties have some sort of this need for review value, because I did the update that value through Azure CLI. That can be done through the Azure Logic at some stage, right? So this is how we can handle the custom metadata things. And now we have registered all the new APIs from Azure Portal, through Azure Portal or Visual Studio Code. But in your organization, there are a bunch of existing APIs within API management. So for example, here we have API management, and there is an API like this. So we have API like USPTO API registered in our the API management. So how can we import these already registered APIs from API management to API Center portal? So there are a few ways, but now I'm going to use Azure CLI to achieve this. So yeah, and I'm going to run this command again. So I get the resource group. I get the API Center. Now I have, so once the API Center is done, then I get the API management with all this API management instance. Now, so I'm going to run this command. This command says import from API management, and this API management, all APIs registered in the API management can be imported to API Center. So let's run this command, and it will take a few seconds. So what it does is that we can, so there is another ways. We can like export our API document directly from the API management and store it into your local machine, then upload, register that API document to the API Center. That's one way. But now what I've done is that I'm using the API Azure CLI command directly import API management to the API Center portal. So once it's done, it will show up in this screen. So let's wait a few seconds, but it takes a little bit of time. Done. Okay. So if I refresh this page, then it will show us with USPTO API, which is imported from API management to the API Center portal. Now, the final demo is that I'm going to utilize this registered API. So if I click the Pesto API, then there is an Open API documentation like this. Then this is familiar. You will be familiar with this Swell UI screen, right? So we can test it through this UI screen like this, something like this. Also, there is another one, generative HTTP file using the REST client Visual Studio Code extension. Then we can send like the request like this. So if I click the request button, and it will show us like that. So if you prefer graphical way, you can use this. If you prefer like text-based way, you can use this kind of thing, right? So you can test your APIs, register the APIs, either UI or the text way. Now, another one is that generative API client. What that means is that if I have already the existing application, then I want to integrate my PESTOR APIs to that application. What should I do? Then it is easier to generate the client SDK, right? So if I click the generative API, generate the API client, it uses Kyoto extensions. Then it will show up what kind of the APIs I need to generate. So I choose everything for now. Then I click the create button. Then it says, okay, I need to give it a name, PESTOR client. Then namespace is web app API client. Then the generated SDK is stored into the net source web app API client. And this is the fun part. So Kyoto is generating the client SDK in various languages. So as a .NET developer, I'm just using C# for now. And it is being stored in, it is being generated now, and it will be stored, created within, in here. So there's an API client, is being generated now. It will be generated soon. Okay, it's all done. So it is all just created. Oops. All just created, right? And then if I want to use, so if I want to use this one, is client SDK itself is generated, but it's not connected to our applications yet. So I'm going to copy a few files for this. Then it will create extensions. It will create a UI component. It will update, use the home, the razor file, something like this. So I'm going to use this component, right? So, right, I'm going to run this app, the Blazor app again, then see how it's going. So once it is being built and run the Blazor WebAssembly application, then it will show us with the pages. Now it's showing up. So it's being built with this one. So this list of available paths is coming from the APIs, that a client SDK. Now, so that's how that component is actually says like this. It is calling the PESTOR client, and it is calling the find by status API through that client SDK. So that's how we can do. So this is the end of my demo. So now let's conclude this session. Throughout this session, we have discussed why Azure API Center is introduced and what Azure API Center offers to the developers. And finally, we have experienced Azure API Center with several demos. But that's not all. Now it's your turn. So if you want to play around Azure API Center today, please visit these pages for Azure API Center, Visual Studio Code extension, and Azure API Center Analyzer tools. Please take a screenshot here. And another one about the Azure.NET Day is that there are many learning resources and cloud skill challenges as well. So please visit these links. Take a screenshot here. And if you want to enjoy more .NET features, then you need to install .NET 8 SDK today. So please go into .NET 8 and download it and install it on your machine and play around with it. Right. Thanks for listening. This is Justin. I will see you next time.
Thank you so much, Justin. This was a great session. We want to make sure that we are being mindful of time, and so I'm not going to do a whole spiel about the agenda and everything, but you know the links that you can go to find that, and they are also in the chat. So I'm going to intro a quick 10-minute lightning session from our friends on Playwright.
Testing web apps at Playwright. Hey everybody, my name is Debbie O'Brien. I'm a senior technical PM at Microsoft.
Hi everyone, my name is Vansh. I'm a senior product manager with the Azure Developer Tools team.
So Vansh, I have a couple of teams here at Microsoft and they've been testing their application, but they've been coming up with these problems. They said, authoring tests is difficult. There's a slow inner loop for authoring and debugging. They told me failing tests are not maintained, lack of visibility to debug tests, flaky test failures are difficult to reproduce, and running tests is unreliable and tests are slow, and frequent execution is expensive. So Vansh, obviously, I said to them, you haven't heard about Playwright, and they hadn't. So Playwright is open source, and it enables fast and reliable end-to-end testing for your modern web apps. You test across all modern browsers with a single API, and it works with popular languages like JavaScript, Python, and of course, .NET. So Playwright has so many cool features, and there's a lot of things like full isolation, fast execution, no trade-off limits, resilient, no flaky tests, and powerful tooling like CodeGen, the Playwright Inspector, and the Trace Viewer, which I'm going to show you a little bit about today. Because let's start and break down our problems. They've said to us, getting a test script that works involves a lot of hidden trial, and the biggest issue was educating developers to increase test coverage. And I said to them, well, we've got CodeGen in Playwright. What CodeGen does, it generates your test by clicking through the website, and you can assert the visibility of the text and the value, and it's really easy to get started with testing. All you got to do in .NET is run this command, and what it's going to do is it will open up a browser window, and then it will open up the Playwright Inspector. And as we click through our website, using the website like a user would, it's going to generate the test. Now, this is the demo I showed the teams. So they put in the website they wanted to test, and they started using it like a user would. They started searching for an Xbox controller that they wanted to add to their shopping cart. Now, you're watching me click and do all these interactions, but you're not noticing over in the Playwright Inspector, all this code that is actually just being generated for you. And the toolbar at the top lets you generate assertions. So we can assert that that value is there, and we can modify that. Now we add our product into our cart, and we can go and assert another value into this box here. We can assert the visibility of this number, and we can continue, place that order, and then we can remove that order, and we can finish the user journey of that test. So all I've done in a couple of seconds was basically just click through the site. And here it is, my full test written for me with no knowledge needed of testing even, right? That is the amazing thing. Even my assertions are right there. And I can literally then just copy that code, put it into my editor, and run my test. So really, really easy solution, CodeGen. So then they said, but Debbie, failing tests are not maintained. And they said, like, they struggle to identify the cause of test failures, and the lack of logs and video recordings make it worse. And they're so right. Videos are terrible. And they said, like, we're going to skip the failing test. I'm like, no, don't skip tests. With Playwright, we have the solution of the Trace Viewer. And with the Trace Viewer, you can see a full trace of your tests. You can step through each action, see the networking console. You can pop out the DOM snapshot and inspect it, and easily pick a locator. And you just add this little snippet into your test, and then you can run the Trace Viewer locally, and you can also run it on CI. So this is the Trace Viewer. And as you can see, that test that we literally created earlier with CodeGen, I'm hovering over each action, and it's showing me everything that was done in that browser window. So I can easily see, what was happening. Is that the test I wanted? I can debug it easily. I can even go to the timeline view, and I can select a specific point in time and focus only on the actions of that time. I can see the network request specific to that timeline, and I can see everything else, such as the source code, which is really important to see that there, the console, if there's any errors, and I can see also the locator. I could pick the locator because it's a DOM snapshot. As I click on it, it's going to show me the locator for that specific element on the page. And if I wanted to debug more, I can literally pop this out, the DOM snapshot, into a browser window, and I can inspect the code. So debugging made so much easier. So the team were really excited, But then what happened? They came back with more problems and they said, running tests is unreliable. The team spends 1 to 2 days per week on flakiness. And I was like, oh my gosh. And tests are turned off for PR reviews? No, because they take over 45 minutes. So couple of solutions here. I said, well, first of all, Playwright is the solution, right? Because we've got auto waits for checks to pass before performing actions, and Playwright auto retries your assertions for you. So just like there's less flakiness, and tests are run in parallel, which makes them super fast. So again, they were really happy, but we've got people writing lots and lots of tests, and that's taking a lot more time to run those tests for PR reviews. And I said to them, whoa, I know a guy called Vansh who's working on the Playwright service where you can run tests at scale with browsers in the cloud. Vansh, would you like to tell us more about the Playwright service?
Sure. So Microsoft Playwright Testing is a managed service that extends Playwright open source framework. It is a cloud service designed to scale running Playwright tests. You can use the service to bring down the time required to run your test suite. One important aspect of the service is its use in build pipelines. Teams usually set these up to run on a daily basis or on every PR. While no one is waiting on these nightly builds, if a PR takes time, it really slows down the development. Playwright testing service helps expedite the PRs and increase feature velocity. Not just that, if you are developing in your local environment and you want to make sure your code changes work, just by running the same set of tests on multiple browsers increases the size of a test suite by a lot. The service can help in this situation by running the suite faster. Another advantage of using the service is that you can test on multiple operating systems and browser combinations. This improves your test coverage. Now let's see how the service works. This diagram shows how tests are run without the service. When you run the command npx playwright test from your CI pipeline or local dev machine and specify workers, Playwright OSS kicks off workers in parallel. These workers are lightweight processes. Each worker gets its own browser instance. The browsers that these workers connect to are opened on the same machine because Playwright framework is used locally. These parallel browsers are a limiting factor in how much you can scale in a local setup because they consume resources which are limited. This problem is more pronounced in CI machines where resources are even lesser. If you increase the workers, the test will start to become flaky as more browsers will be opened on the same machine and they will fight for the same resources that are available, which are less to begin with. When you run the same set of tests on the service, everything remains same from Playwright framework, like your environment and your tests. All your data remains on your machine where you are running the tests from. The workers that you spin up, they now connect to browsers hosted in Microsoft Playwright testing service. This gives you the ability to scale because these lightweight processes can now connect more browsers simultaneously. Since the browsers are hosted on the service, you can also choose the operating system where they're running. For example, if you want to test on Chromium running on Linux or Chromium running on Windows, you can do that with the service. Now look at this test run that I executed from my GitHub actions. These tests were run using the service, and it finished 600 tests in just 2 minutes. With performance gains like this, teams can deliver faster and more confidently. Integrating your existing test suite with the service is really easy. You don't need to change any of your tests. Just add a config that extends your existing Playwright config and add a couple of environment variables that are used to authenticate to the service. Now run your test by using the config file you just created and specify the number of workers that you want to use. It's really that easy. On the Playwright testing portal, you can see information about your test run, such as duration, number of workers used, and total billable minutes. We are constantly improving the offering, and we are working on adding reporting capabilities to the service very soon. Let me give you a sneak peek into it. Today, the activity log that you just saw contains very basic information about the test run. Very soon, these logs will contain more details, such as CI information if you're running from CI pipelines and the status of the test run. You will be able to click on each of these items and see the details. You can see the results of all the tests that were run as part of this test run. You can also see the Git information that is coming from your CI pipelines. You can also open any of these tests and see the artifacts and screenshots associated with it. You can also see the trace viewers. This is the same trace viewer that you showed earlier. You can use it in the service portal and troubleshoot tests easily. This feature is not coupled with the cloud-hosted browsers that we saw earlier. You can independently use it in your CI machine or in your local server. Now let's quickly summarize what we saw so far. Microsoft Playwright testing enables you to run tests on cloud-hosted browsers, giving the ability to run more tests in parallel and bring down the time that is required to run your test suite. You can also improve your test coverage by running these tests on multiple operating systems and browser combinations. You do not need to make any changes to your test code. The integration is really easy. We are also adding reporting capabilities to the service that can be used independently of cloud-hosted browsers. The service currently supports JavaScript and TypeScript with Playwright Runner. We will be adding support for other languages too. .NET is a priority and we are actively working towards it. So Debbie, what do you think about it?
I think it looks absolutely amazing. I'm so excited to bring that back to the teams and get them to check it out. And also so excited for the .NET support too. So check out the Playwright open source, the docs here, and check out also the docs for the Microsoft Playwright testing. And of course, join our community on Discord and subscribe to our YouTube channel to see all things testing with Playwright. Thanks, everyone. Thanks, Vansh. Happy testing. Bye.
Bye.
Thank you so much. I know we are 5 minutes over the time that we have said we would be, but I'm very excited for this next session, Dev Productivity Dojo. I'm very curious about what we're going to learn. So I'll bring up our next speaker. Hi, how are you?
Hailey, how are you? I'm great, thanks.
Awesome. I'm very excited to hear all about our dojo that we're going to be making here.
Yeah.
So I'll let you take it away.
Thanks. Okay, great. So hey, everyone. We're going to talk today about mastering the dev experience. So basically our little dojo here for coding and how we should set up everything. And I'll start by introducing myself just a second. So I'm a senior software engineer at Microsoft working in the education team. Mainly I'm working on .NET and Python on the Azure stack. My main IDE or weapon of choice is VS Code, obviously. And I have a bit more than 7 years of experience leading technical teams and Microsoft and other companies as well, and I want to share some of my insights on dev experience, dev productivity, from past roles that I did. Cool. So let's start talking about the pain. So many teams invest heavily in documentation and in CI/CD process. So documentation because they want to preserve knowledge in any means necessary, and CI/CD to let's say the CI part of it is to be eventually consistent, right? To perform all of the validations ahead of time, and CD we all know and love. That's clear. So basically, documentation and CI/CD. Basically, I want to focus on the CI part for being eventually consistent, running all of our validations. Let's say on the pull request build, for example. Where's the issue on that, right? Even if I have a really good setup, which from my experience, most team don't really have like a great setup, and I will explain why. But even if I would have a great setup here, there is one key part missing, and as you probably already assume, this is going to be that developer experience. So I want you to leave this session motivated to invest heavily in the developer experience within your team. Number one, for productivity, and number two, to have fun, right? We all want to have fun while we work. It boosts everything. It creates a positive mindset, a can-do attitude, and we want to invest in that. So this I like to start every session with like a phrase, something that hopefully will stick with you after the session. And usually I paraphrase. So now I'm paraphrasing on the fish metaphor. So apply a patch and it holds for a day, install a system and it will last for a lifetime. So of course, this is software, nothing lasts for a lifetime, but I want to show you how creating proper system that with some investment, like a very minor investment, it doesn't take a lot, can actually create a very strong impact on your system and on your team. Okay, so let me start by telling like a made-up story, but this is actually our day-to-day pretty much. So my boss asks me to build an app, right? So he says, build me an app that does whatever. And I say, yes, sure, why not? Let's do it. So I start coding. My usual like go-to stack, Git, GitHub Actions, and Visual Studio Code. This is like the usual. And then everything looks good. We release a beta, and users love it. Nice. So the boss wants to assign more devs onto the project to speed up the process. So 2 devs, right on. Cool. So we're gonna start writing the documentation, right? Like because I know 2 more devs are joining. I want to facilitate the onboarding process. I want to install some standards or whatever I want to install in my repository in my project. And then I created this documentation. So great, the 2 devs are joining. And my boss wants us to start tracking our tasks, right? So he says, please use Jira or whatever, yeah, like Azure DevOps or GitHub issues, whatever is your jam, but basically start tracking your tasks. So we say, okay, sounds good, let's do it. And then devs come with like a lot of likes and dislikes from previous projects. So they decide they will offer tools that they love from their previous project. So one offers Swagger, the other one offers Notion for documentation. Okay, sounds cool. And then we end up with like a more complex stack already. And this is just the beginning. So we have these 4 tools that we already mentioned, and then these 2 new tools. And now everything becomes a bit of a mess, right? To search the documentation, it's pretty hard. It's not a fun experience, right? Like, and this is like an easy setup. We have only Notion and I don't know, like a Markdown files in the repository. But you can imagine OneNote as well, and some people use wiki pages, and some people using Word documents, and it can be really like it can explode very easily. And then also PRs take a long time because of standards, right? Like I created these standards and I want people to read them, but they can't find them or they're scattered all over our documentation. So it's a mess. Okay, so I create a standards document and I do it like very neatly. I separate coding, testing, docking, and like version control standards that I want to apply to the project. And then I actually created just a lot more docs, right? So devs are pretty frustrated. So I start indexing everything. So basically, in GitHub, the common way to do it is a README file. This is like the landing page for the documentation for the repository. And devs are becoming a bit more content, let's say. And now let's like double-click documentation for a second. Let's look what can be done here in order to increase dev experiences. So the idea is like there are 2 main bullets you need to make sure your team apply. So one is index, like we want all of our resources to live alongside the code and accessible very easily. So you can use the readme.markdown file in order to be the landing page for your project. Of course, I'm talking currently about internal project like closed source, but for open source, this is for the contribute.markdown file. But you can apply it, of course. It's very easy to apply one to the other. So you want everything to be very easily found. So it should be accessible by everyone. So this is the number one key, the number one priority. And then you should invest. Invest is what I mean by invest. Integrate tools, templates, script ahead of time. I want to make it easy to other devs to be able to contribute additional documentation, additional code, additional tools, whatever. So I need to invest ahead of time in this, and I'll explain a few mechanisms you can do for that. So this is like an example of how a repository looks in the teams that I'm working on, and you can see a lot of different things. I want to focus for now on just a few. So index, right? So the readme.markdown file, if you join the project, I just reference you to this single file, and everything is can be drawn from that. So that's very cool. The other thing I want to highlight here is that there are already pre-made templates. So we have like a one-pager template if you need to like briefly update the entire team or the entire group or company or whatever, the size of your circles, about something related to this project. So this is the template that you use. You also have a deck template for presentation and also a design template. And of course, they can use other tools like you see here, like Word or PowerPoint, but the reference exists in this repository. Okay, great. Also, you can see I'm saying it uses Mermaid, so it's a very cool tool that I'll show in a second. But you can also see other stuff here. Maybe you start to recognize stuff. You can see MK Docs. You can just file a command runner. So I also have static documentation pages already set up in the repository, and I have a command runner, and everything is set up. This is like a very easy setup. It doesn't demand more than like a few days to set up the entire thing, and then to contribute anything is like just creating like the additional delta that you need for your task, for your feature, for your bug fix, or whatever. So this is the setup that I want to have in the repository. Now we'll talk about like the tools that I mentioned, just to like I want to highlight them. But of course, there are many tools you can use. So let's start about documentation. So I really encourage you to examine a static documentation pages for your project. I show here two examples. One is MKDocs. MKDocs is a very common one. It's written in Python, but you can use it for whatever. You can even create a professional website with it. It's very easy to set up. But if you use .NET all the way, like this is your only tool, and you prefer to stick with something that is .NET based, there is DocFX, which is also an awesome alternative. So both tools I really highly recommend to use one of these. And the other tool is called Mermaid. Mermaid is basically a Markdown language to create a diagram based on Markdown. So the nice thing is, let's see on the left here, you can see like a sequence diagram, but it supports many other diagram types. And it will render into this amazing, like super simple, super clean way of a diagram. And the nice thing is this lives within your Markdown code, within your documentation, and it's version controlled, right? So it's very easily edited by the next person that is going to work on the project. You can also review it in your pull request. So you can streamline the diagram and the diagrams for your team, and it makes things a lot more simple. So back to our story. This was like a sidestep. Back to our story. So we have better documentation right now, like a nice setup, but devs keeps referencing the README file for common commands, right? So they still need to look at the README file or other documentation files for cheat sheets or whatever. And it's very slow, right? Like we don't want to always context switch into the documentation. So what can we do there? So here we can add a command runner, which is an awesome category of tools that help us solve this issue. So let's take a look at what are command runners for a second. So let's say you have this command for running all of the tests in my project. So .NET test and filtering only for unit tests, and I want the logger to go to the console and be very verbose. So this is a common scenario where there is like a cheat sheet or a section in the README or something in the team documentation with all of the commands that people should use. So with the command runner, we just take this command and we kind of map it into like something very clean. So for example, just test unit, just test all, just test integration, whatever. And this encapsulates the exact configuration that everything should run. Another example is the Docker build. So you have the Docker build, and then you have a lot of configuration. Maybe you have a port mapping. Maybe you have some other stuff that you need to do, a specific naming convention that you use. whatever, and it can be cumbersome as well. So a lot of teams put that command as well in their cheat sheet or README. And here you can just do, like, let's say, just build. Okay, so it's very, very neat. And command runners can actually do much more. I listed here a lot of cool command runners. Of course, you only need one, but pick your poison. Make is probably the most famous one. I put here bash because you can do it in a custom manner very easily. Just is my weapon of choice. I love it. It's also very common. There's also task, mage, and a lot of other very cool ones. And they're like the three ones on the right are very modern way to do it. Like, they are modern command runners, and they have a lot of really cool quality of life features. Okay, so here's an example of a command runner. You can see that it also supports like a lightweight documentation, and it's very, very, very easy. And then you can also, as a developer, you just write just in the command line, and you would get these available recipes, they call it in just, but available commands for you to run. And this is awesome. I can run it from my locally or from the CI/CD process, and it's very, very easy. And back to our story. Okay, so we installed the command runner, so to make everything a bit more like easy. No, we don't need to memorize any commands. We don't need to reference the documentation for that. We have a tool installed within our repository. So things are going very well, and the new dev is joining the team. Says hi, we say go to the single README file. We have a single README file, reference it, onboard yourself, have fun, let us know when you need us. And then PRs are taking too long again, right? So there are PRs like he sends a PR, and then we're frustrated by again needing to explain there's this documentation with the standards, please read it, please follow it. This is how we like things to be done. Okay, so what do? We want to start checking the standards in the PR build, right? So here we introduce C# PR, which is a formatter for C#, but C# PR is neat, and I'll explain why. C# PR is an opinionated code formatter. What does it mean, an opinionated code formatter? Opinionated means it doesn't have all the controls and toggles you imagine a formatter to have, where you can configure it to format the code just as you would like. It actually says, I format stuff the way I like to do it. I mean, I say I am in the tool, and this is how it's done. It gives you very little control. I think there's like a handful of controls for a C# or something in that order of magnitude. And that's it. Everything else is taken care of for you. You don't need to worry about it, and you can focus on actual logic. You don't need people to spend time reviewing PRs and focusing on formatting conventions, which is super annoying to see. As a tech lead in the team, I see people wasting a lot of time iterating over formatting instead of focusing on actual logic issues. So this is an opinionated code formatter. If you know Prettier, I assume most of you know Prettier, so this is basically Prettier for C# because Prettier doesn't support C#. Okay, so this was again a little side note. So I added this formatting command to my just file. So I added the lint command, and I just called .NET C# PR. And then I also, for good measure, I also created this check command, which runs the lint and then runs all of the unit tests and then echoes that everything is good. And we see you can also probably assume why it's good, but we'll explain in a second. And then in the PR build, we just call this, right? So we have this line 12 and 13 to install stuff. And then in line 14, we just call check. So I love how the tool name just, and then I just say, we just do this. It's amazing. I think the naming is right on here. So we just check. And then everything that currently it's just running the C# PR and then tests, but you can imagine this can expand over time. Okay, cool. So now we have a feedback loop, but without another dev involved. But the feedback loop is very slow, right? Because it's PR based. So you code, you send a PR, the PR fails, and then you see it fails, and you create another iteration. So it's very slow. And then you can just say to the devs that you can run it locally, right? Just run it locally. So it's better because you have the command that runs exactly the checks that you would do in the PR build, but it's still not as smooth as we would want. Like it's not real time. And here comes VS Code. I'm not sure how much time I'm into the session, but this is the first time I'm talking about VS Code. But essentially, I wanted to like align all of us because I see VS Code is like the glue that holds everything together. So it makes sense that it comes late in the session, and I want to add a VS Code extension for that. VS Code has an extension for everything. You can even grow your own pets inside VS Code. It's a crazy new world out there. So I found this C# extension for VS Code. I tell the devs, and they are super super excited about that. And then I tell them I documented where like the tool in the docs, and then they are set again. Okay, so I think and I find a solution. So basically, not me, like the VS Code team found a solution for that. And there's a whole different animal here in VS Code that's called like a workspace setting, or basically it's a common dev config. So a common dev config where you can set up the VS Code IDE or the dev experience for this specific workspace or this specific project. So let's look at that. I just created a folder named .vscode, and within that we have this a few different files, and which will configure this workspace for every dev involved. So let's start with with a file called extensions.json. You can see, so this is its content. You can see a list of recommended extensions, but at the bottom you can see that I'm adding C# here. And what this means is that every dev that is going to open the project in VS Code will get this notification saying, you're missing this and this extension. Do you want to install it? For this extension from the recommended list. Okay, so you can install it. And of course, you should install whatever is recommended. And also on top of that, you can also create a workspace setting. So you can also configure everything in VS Code to be at the level of the workspace, but also an extension is a part of that as well. So you can see that I'm setting C# here as the default formatter. I'm doing a format on save, so it doesn't require any manual involvement, and format on save mode file, just because this is the only thing this is the only mode that is supported for C# here. And I know that this setup, these settings will work for everyone when they code. And once it's shared in the settings.json, then I know that everyone will get a real-time experience with the formatting that I want. And if they didn't want to do it because this is not forced by any manner, of course, we still have the safety net of the CI, right? So we still don't need to worry about that in the pull request. No one needs to waste time over like tabs versus spaces, of course. Okay, so focus on logic, not on format. Okay, awesome. So I love this. So I want to start adding a few more extensions. So you can see here a cool list. This is actually my go-to list for .NET. I highly recommend the ones here, but I want to focus here on a very simple, cool one called C# Utilities. Does a lot of stuff. One of the stuff that it does, it adds like a solution explorer when you get like a Visual Studio like explorer to your Visual Studio Code. It's very very cool. So and now everyone is happy. Okay, so I have VS Code set up, and everyone is super happy, and everything is fully automated. So later on, like one of the devs says, let's fix the to-do mess as well. So a lot of repository have a to-do mess. What I mean by to-do mess, people sometimes check in their to-do comments, and of course this is not like how it's meant to be. To-dos, like you can do whatever you want, but to-dos is a great tool for devs to work locally on the project. And once they are checked into the code, it's kind of conflicts with your task management and your other checking tools. And to-do is meant more for like another tool to help devs locally while development. And we like this idea, so we say, okay, go for it. And then look how easy this system is now when we have the initial investment behind us. So we just go to the command runner. We say that in the lint, you can just also run the check to-dos shell script that you write for your own to-do logic. And also you create this new extension. You list this new support another extension that supports to-dos here. This is a very cool one. It's called to-do tree. And then you get also the really nice experience within VS Code where you can track open to-dos. And also you can configure it. So this is like basic configuration that I do for to-do tree. You can do whatever works for you. And that's it. And then you get to do checks both locally and in your CI/CD. And again, no one needs to take care of it. No one needs to comment on the PR. No one needs to learn this. It's just by nature of coding, you will learn this coding standard. And they lived happily ever after until another Dave joins, but this one uses a different OS. Okay, so maybe we'll use Windows and then she uses Linux or whatever the setup may be, and this creates a whole new can of worms. So something doesn't work, something breaks, we're all frustrated about it. So we can introduce dev containers. And I'm not going to talk today about dev containers, but I put it here because I think it's the natural next evolution of improving the dev experience to what I demonstrated here. And I will share a link that where you can read more about it. And I really encourage you to dive into that as well. So just summarizing here. So clear documentation, indexed clearly, and invest early on in the life cycle of the project. CI/CD, enforce everything, and then in the dev experience, invest in a rich dev experience. In either it's the IDE setup, command runners, or other tools that I did not mention here, like dev containers and more. So we're done. I'll have a slides in a second for questions and reference material, but I encourage you to learn more. There are great learning resources here, and there's also like a cool challenge you can try out. And .NET 8 is out. There's you can download it, and also there is a migration tool to help you move from earlier versions. And these are on the left. This is the share sheet. You can scan it. All of the links to everything I mentioned here can be found there. And on the right is my LinkedIn. You can reach out if this excites you. Hit me up. Let's talk. I love to drill down on these subjects, and I have a lot more to cover. So feel free to reach out.
Thank you so much. This excites me. I think this is super awesome. And will you be able to answer questions in the chat after this?
Yeah, sure.
Okay, awesome. So yeah, keep putting your questions in the chat, and we'll get to them as we go along. Thank you so much for joining and helping us close off developer productivity. Have a great day. So we are 4.5 hours in. So we thought for a fun, exciting thing, we were going to do 3 10-minute lightning sessions. And so everyone get your energy up, get excited, because we're going to kick off our app development segment of the day, which is our final portion of the day, with 3 awesome back-to-back lightning demos. We're going to start with migrating to Azure. We're going to talk about Azure functions. We're going to talk about static web apps, data API builders. So it's going to be lots of fun information coming at you fast. So get ready, get set. Here we go.
Hi there, my name is McKenna Barlow. I'm a PM on the .NET Tools team, and today I'm going to talk to you about conversational app and code assessment in Azure Migrate. So Azure Migrate Application and Code Analysis Tool is a tool for application-level static analysis for .NET and Java replatforming scenarios. What it does is it scans at the source code level through your solution and identifies code patterns, API usage, config file contents, etc. that when you move to Azure might be problematic. It's a really easy way to identify red flags and see what work is ahead of you so that you can plan it out effectively. We have multiple ways to run the tool. The first is the command line tool, which is a .NET SDK tool, super easy to install. The second is the VS extension, which I'm going to be showing you my demo in Visual Studio today. In terms of types of dependencies identified, when you run the tool for analysis, you will get a report with all of the dependencies and issues found in your code. So external dependencies tend to be the biggest challenge when replatforming to the cloud, but we also can identify dependencies impacting the ability of the app to scale, for example, in-memory caching, as well as opportunities to take advantage of new features once you are on Azure. So how you manage secrets, Azure Key Vault, Azure App Configuration, stuff like that. There are lots of different types of issues found in the report with various severities. An issue is basically something that's likely to be a problem when replatforming, or it might just be something to review. Mandatory issues will likely block replatforming if not addressed. Potential issues might block. They require developer review, however, and most issues in the report are very likely to be in this potential category. There are also optional issues, which are an opportunity to take advantage of cloud capabilities, and informational, which are simply a notable dependency. No action is necessarily required. So now I'm going to jump into Visual Studio and give you a demo of the tool. So in Visual Studio, we have a sample app that has a lot of things that show up as interesting in the report for this demo. It's a basic eShop application. Most of the code is in this web app here, but we have a few helper libraries that go with it. As I mentioned before, there's the option to use the Visual Studio extension or the command line tool. I'm going to show you how to use the tool in VS. This gives you the best experience because in Visual Studio, we can interactively walk through a few different processes that you'll see as we go through this experience. If you're brand new to the tool, you'll have to get the extension in the VS Marketplace. I already have the tool installed, you can see, but you can also see that I have GitHub Copilot Chat installed. This is worth pointing out because if you have both of these, there is some integration between the two of them that's really nice to have, and I'll demo for you. Copilot Chat is not required, however, but you'll see some cool functionality light up because of it. So let's go ahead and open a new report. I'm going to right-click on my solution and select Replatform to Azure, and then open a new report. First, we have the option to choose which Azure environment to run on. Based on what you choose, we still run all the same rules, just adjust the severities and descriptions of those rules so that you get a report tailored to where you intend to be executing your app. If you don't know or you just want a general report like I do, you can select any. Next, we're going to choose which project we want to analyze. You only have to choose your top-level web apps. You don't need to select dependencies. The tool will automatically assess these, but I'm just going to select everything to be sure and continue on. Next is the components to analyze. The typical scenario is just analyzing the source code, but we also have the option to analyze binary dependencies, which is like NuGet packages, third-party DLL, stuff like that. This will give you a more complete scan if you have this box checked, but also potential for a lot of noise. So it's recommended that you just start with your source code because this will give you the highest priority issues and the ones that you have the most control over. For a more complete picture, you can always do a second scan with both boxes checked. Custom settings is an opportunity to provide a JSON config file that customizes the way that rules work. So here you can adjust which rules are considered important and even define your own custom rules. Let's go ahead and analyze. It should be super quick, and then we'll get our dashboard view. So this dashboard is just a summary of our report. Here we can see the number of projects, the types of issues, and number of individual incidents. Here we can see a pie chart comparing the severities of these incidents. If we have both Azure Migrate Code and Application Assessment Tool and Copilot installed, you can open Copilot Chat from the dashboard. This is the first part of that Copilot Chat integration that I was talking about, and it'll start a new conversation thread with Copilot. What it does is it's sharing the contents of my report and then asking Copilot to summarize which issues are the most important, and it'll help me guide how I want to address them. So I can have this conversation with Copilot where it'll help with next steps after I review the report. And even if I'm brand new to Azure, say I don't know what I'm doing, I can just pick a place to start. So it's telling me it identified a few issues in my app: database, file IO, logging issues, other issues. Let's just pick a place to start. Let's start, for example, with logging. So Copilot Chat is going to help me walk through these issues and then figure out how to best address them in an interactive way. Again, this is optional. If you don't have Copilot Chat, the tool still has full functionality, but if you do have Copilot, you get this really cool interactive experience. And it has all the context from my report, so it's basically a system expert on my migration because I've provided the context here for it. So we're going to wait to see what Copilot has to say. Cool. So it sees that we're using log4net and it gets that out of the report. And it's asking me to share my log4net config file. So when I share that, it will look through and say, hey, here's what we have to change for logging, and then guide me through that step by step. But let's first look back at the report and explore more of these tabs here. First, I want to touch on story points, which are essentially a unitless measure of relative effort that we estimate it'll take to get these apps working in the cloud. They don't necessarily correspond to dev hours or days or anything quantifiable like that. It's just a way to compare things relatively. When grouped by project view, we can actually compare these across our projects. We can see that we have 3 and 3 and 27. So the majority of our story points are on our web app. So we can know that the bulk of our time is going to be spent on this one. So let's jump into this project. Now we can look at each individual projects with a project-specific dashboard. So this is similar to the main dashboard, but scoped to the project. We can view now issues by component. We can view issues grouped by type. And then on the left here, we have aggregate issues, which is just for the whole solution. And this is grouped by type of issue. We can expand each of these for details on individual incidents. So let's look, for example, I see that this logging issue is mandatory, so I'm going to have to address that one. Let's jump on in and see what we have. So on the right, we have a summary of what the issue is about. So the tools detected logging to local or network paths. There's an explanation that I have to use logging that stores logs and locations outside of the host, and then tells me that I can use Azure App Service logging or application insights, and even recommends the log monitor tool. At the bottom here, we're going to get a code snippet from the solution that shows where the dependency is, and then some helpful links at the bottom. Now, if I don't know what to do with this, I can use Copilot chat for these individual issues. So the Ask Copilot button for individual issues will give me targeted guidance on each of these issues if there's something I want to learn more about, or just get Copilot's opinion on how to address. So this starts a new conversation thread specifically for this issue of the logging. This shares my issue description and the code snippet with Copilot, basically everything in this right-hand pane here, so that it can advise us. And look, now we get all this additional information from Copilot. So it's telling me this is a mandatory issue. To resolve it, you should consider using Azure's built-in logging. So it's telling me this is how you might modify your code to be able to do this. And it's giving me some great code snippets and step-by-step of where I would need to replace in my code. So say I don't know what my next steps are. I'm seeing that if I'm migrating to AKS, I can use the log monitor tool. What if I don't know how to include that? Let me ask Copilot, how do I include log monitor in my Docker file? And then it's going to spin up a response specifically about that question. And I can continue to have this back and forth with Copilot. So the real value here that I'm getting isn't just the help and the information. The real value, at least in my opinion, is that you can have a conversation and ask follow-up questions. There's an opportunity to have the back and forth, ask clarifying questions, and it makes Copilot a really great partner for this replatforming process. So we see all this great information here. It's telling me I need to set up a config file and gives me some code snippets. So as a developer, I can feel really confident going through this replatform process that I know how to address all the issues in the report with the help of Copilot, even if I don't have specialized expertise in replatforming applications. So all you developers out there that might be going through replatforming of your apps, please give this tool a try and let us know your feedback. Thank you for your time, and I hope that this demo was helpful.
Hello, I'm Brian Spendolini, and I'm an Azure SQL Database Product Manager. And I'm here to show you how to create a change data stream in minutes with .NET, Azure SQL, and Azure Functions. So before we get into building this, let's talk about the three main stars of this demo we're going to see. First is Azure SQL, which is an enterprise database. And though we're going to be talking about the Azure SQL database, these SQL bindings can go and work against the Azure SQL database, as I said, the managed instance, the Azure SQL VM, or even SQL Server if you have cloud connectivity. All we need is a working connect string. Next, we're going to be using Azure Functions, and these are serverless runtime environments for standalone code. And in there, we'll actually have that SQL binding that's going to be used for triggering and seeing changes in our database. And one of the great things about Azure Functions is not only can we write these functions using C#, but we can also use Java, JavaScript, Python, and PowerShell. So any of the popular languages today, but today, obviously, we're going to concentrate on using C#. So there are 3 SQL bindings for Azure Functions. Now, the first one is an input binding. An input binding can be used to expose data from your database. So you can create a REST service on the data in your database. So we can expose tables, we can expose views, stored procedures, and show them and expose them data so you can consume them in other applications or maybe even with other databases for if you're syncing data or if you want to create an application on top of it that will use this REST service. Next is the output binding, and the output binding acts as basically doing an upsert of data into a table. So you create the output binding on a table, and then you can use post via REST and pass data into that table, and then it'll upsert that data into the table. An upsert basically means if the row exists, it'll update it, but if it does not exist, it will insert it for you. The last one is the one that we're going to be looking at today, and this is the SQL trigger. Now, the SQL trigger, using the change tracking functionality of the SQL database, allows you to capture changes that are performed on a particular table. So if an update, a delete, or an insert happens on that table, we can capture that row and then bring it into the trigger, and then you could do multiple things with it, which we'll talk about in a second. So what are some of the use cases we can have for these bindings or for the trigger binding? We can use them to take data or content within our database and then send them over to maybe Azure OpenAI or Azure Cognitive Services. So let's say we're inserting maybe comments or blog posts or something like that into our database. We can hand it off to content management or cognitive services and say, does this particular piece of text or this paragraph have dangerous items such as profanity, PII, or maybe self-harm? Talking about those particular categories. And then once we get that score back, we can do something with that, either not inserted or corrected or update that. We can also, use these for geocoding data in our database. We can also use this trigger for starting complex processing. Something happens in that database, an insert happens that goes above a threshold or a certain point. We can go launch this event and then go do something with it and start a process, maybe updating a website, as we see with the next use case using Signal R, or maybe updating a Power BI data model in the background, the semantic model, and updating that so our Power BI reports have the freshest data in them. One of the very popular methods, or one of the popular architectures we see today, is event-based architectures. So triggering this data change will actually send this row or these rows over to Azure Event Hubs or maybe a Kafka instance. And then now you can have this database participate in event-based architectures, which we see with microservices and are very popular today. And lastly, this all goes to creating that change data stream, capturing events, and maybe sending them over to Stream Analytics. Maybe we're looking for fraud. Maybe we're looking for certain changes in our data that we want to capture and alert someone with. We can do that with these bindings. So our scenario that we're going to tackle today is, how can I leverage the change tracking features in Azure SQL Database, or as I said before, SQL Server, Managed Instance, or Azure SQL VM, to expose data changes via an outgoing change stream without the need for custom code or any code at all, because I don't want to write any code. I want this to be as easy as possible. I want the system, or I want VS Code, or I want the extension to completely write this for me. I want this to be no code, low code environment. So before we get into the demo, we'll just look quickly at the architecture. So our architecture starts obviously with our database, and we're going to be updating what we call the to-do table. And we're going to be changing some data in that to-do table to trigger the binding. Once that trigger binding sees the change, it's going to get the complete row. And then there is where your imagination can run wild. Once that row hits that trigger, or inside of that function, we can hand it off to, as I said, Azure Event Hub, or we can send it to another database. We can combine a trigger binding and an output binding and grab it and put it to another database. So we're syncing data between multiple instances. Really, you can do a lot with that row, that change row, once it's in that function. So let's start and let's see this demo right now. So our demo environment here is, as I said before, is running in a GitHub code space. We have everything we need to do to run and create this trigger here. So we can see that we have our SQL database running. And again, that was very easily created using SQL CMD. You just go SQL CMD, create database, and bam, we have a database running in Docker and Docker. So the first thing we need to do is we need to create some objects in our database. So we'll create a new query here, and we're going to create a table. We're going to turn change tracking on within the database, and then we're going to enable change tracking on the to-do table. So we just run this. And now we have our table created in our database. And we can actually see this if we open this up. There's our to-do table. All right. So the next thing we're going to do is we're going to actually create the trigger. Now, the trigger can be created very easily. All we need to do in CodeSpace or VS Code is press F1. And F1 is going to bring us to allow us to create a trigger using this wizard. So we can just put create, and we're going to go create a function. Next, after this function is starting, we're going to use the current directory. And then here's, as I said before, all the languages we can use, and we're going to use C#. We're going to choose .NET as our 8 as our runtime. And then what it's going to do, it's going to give us a whole bunch of templates that we can use to create this particular function. And all I need to go down here and just change this to all, and we will see that we have our SQL trigger binding is one of the templates. We just pick that. We can use the default name. We can use just the default namespace. Our connection string, we'll just call it connection string. And this is what we're going to use in our local settings for the function. Obviously, when you deploy this to Azure, you're going to use manage identities and not a password within the connection string. But for our local development environment, this is fine. And then our table, as we saw before, is going to be the to-do table. The to-do table. All right. And what this is going to do, it's going to go and it's going to create all the project files we need. And if I just switch over here to our view, we'll see all the project styles start, all the projects, I should say, start building and start creating here. And when it's done, we're going to have a fully ready to go function that we can use locally and then easily deploy to Azure using the Azure extension right here. So here it is. And here is basically the main code of our function. We see that's the SQL trigger. We're looking at the to-do table. Here's our connection string. And then what we're going to, the thing that we're just going to do today is we're going to just have the output go and be logged. But here is where per row, you can say, send it to an event hub, send it to a Kafka instance, send it to another database. You can actually embed an output binding in here and say, send it to another database to be inserted. So if you wanted to sync data between two databases, you can do this with our trigger binding here. We just really quickly need to add a package to our .NET project. And then all we need to do now is we need to go and we need to add our connect string for this local database to our file. And as you see right here, SQL CMD, config connection strings, and here are all the connection strings. And it's actually already ready for us. We just need the .NET one. And we just grab this here and copy it. And connection string is our variable. And as I said, we're going to local settings file here. Connection string. And we will paste in our file here. And as we see, that's actually lowercase. There we go. Connection string. Okay. So just go back and look here. No, connection string is uppercase. We have our connection string, local settings. Just put that there. just need to put our little tick mark there to make it all right, and add that and save our file. All right, so we are actually ready to go and test this locally. So we're going to jump back here real quick, and we're going to look at our database objects. And here is the SQL we're going to run to actually see the trigger in action. So what we'll do is we'll go back here, and we'll just get this ready to go. And now finally we'll come to our binding. And what we're going to do is in our command line here, we're going to do start our function. And we're going to start it up. And what this is going to do, it's going to build the project. And once the project is built, it's going to connect to our database, and it's going to start looking at this table. And this should just take a second to run here. There we go. All right, it's connected to the database. So now that it's connected, we can go in here and say, and we'll just give it some more room here. I'm going to insert this into our database. And there we go. Our trigger has fired. Here, our operation is 0 is an insert. We see the ID, we see the priority, and we see the description, just as we have from our insert statement. Now I can do an update, and I could just grab this right here and put that there and just do an update. And we see the trigger has fired again. We see it's an operation 1, which is an update with our ID, our new priority we pass in, which was 2 instead of 1, and the description stayed the same. And if we want to delete it, we can go here and do a delete from the table. And again, the trigger will fire its operation number 2. And then we see the ID, which is the primary key, and the priority and description are null because it is a deleted row. So that easy, without writing a single piece of code, we were able to create this trigger on a table in the database using .NET and create a function from it. And now all we have to do is deploy this function to the cloud, and we are done. Very, very easy to do. So let's go back to the slides and just wrap this up here. So a quick summary. As you saw, we quickly created a change data stream with Azure Functions with basically no coding whatsoever. We went into the template, we selected our options, we pointed it to the table, and we were done. Very easy to do. And remember, there's 3 bindings we can use. So there's an input, an output, and a trigger. Today we used a trigger. And again, obviously, we're going to use C# today, but if you wanted to use another language, if you are more comfortable maybe in Java or JavaScript, there are templates for all these languages built right into VS Code via the extension. We did local development, and then we're going to deploy it to cloud development. So think of it this way. With our local development, we have our SQL Server local to our code spaces environment. We can test, we can run everything there. And then when we deploy this to the cloud, we can have it, and in the cloud, we'll have that connect string change to use Azure Manage or Entra ID managed identities. And that way, we don't have to pass passwords around or anything, and we can just allow access between the function and the database that needs it. And if you want more samples or see how to use any other the bindings or the input or the output or any other language that we have here, you can go to aka.ms/SQL bindings, and that'll take you directly to our documentation and our sample repository. So again, thank you very much for watching this presentation on creating a change data stream with Azure Functions, the Azure SQL database, and .NET.
Hey there, everybody. I'm Jerry, and I'm here with Frank. The two of us, we built a pretty neat little app that talks to a database on the back end. But I want Frank, would you describe it to us and kind of show it off?
Yeah, let me show you. So let me share my screen here. So don't judge, it's not finished, but it's a Blazor application, you know, .NET new Blazor. And we start creating that. And because, Jerry, you're a fan of Star Trek, is that right?
Yeah, that's right.
We decided to show that and using a database full of information about Star Trek. And here I built a very simple view page sharing like, okay, different series and the characters, so like Spock and Jean-Luc Picard. I feel like I'm the only one, because I speak French, who could say that correctly.
It sounds right when you say it, yeah.
And Jerry provided me 2 different endpoints, so REST, regular, like more. I think it's very, people know that, and also a GraphQL. So because I couldn't decide which one to use, I decided to use those, and I create 2 different pages. But before we go and look into the code, how I build that Blazor application, I want Jerry to spend more time explaining us how he did that API, because I think it's really interesting. What did you use to create that API?
I use Data API Builder. All right, so it's unbelievable, Frank, too. Let me start by just talking about how accessing a database on the back end is just what everybody has to deal with. So you have a SQL server, you have a client. How are they going to talk to one another? Eventually, you get to this point where you're designing a solution where I need a data API in the middle. And so most developers are like, I guess I have to build it. I guess I have to find the right framework. I have to find the right way to do it, build my repositories, my unit tests, put it in my CI/CD pipeline, and just allow for that code base to grow so much because you have this data API. Well, that's what Data API Builder is trying to get away from, making it so that you have an engine that you can use that gives you all the capabilities you need without needing all the code. In fact, the only thing you really need is a JSON file. And the place to put that JSON file is what we're going to talk about now. So like every developer, you're going to have a repository. So in this case, we have a GitHub repository. And so this is your repo. And when it comes to deploying DAB the way we're doing it today using static web apps, you only need a single file. It's absolutely amazing. So this is you, by the way. You're looking pretty good. And you put this one file into your repository. So let me pull up my repository just to show you what it looks like. The repository starts off completely empty. And I don't add a bunch of code. There's no C#. There's nothing. It's just this one JSON file. Now, I do have an HTML file, just an index file. It doesn't have anything in it, but I need that for static web apps because that's a requirement. But I have this one folder, SWA-DB-connections. That's where the JSON file for Data API Builder is. So let me go into that and show you. Here it is. It's named static web app.database.config.json. If I go into it, it's just a standard JSON file that you would have built for Data API Builder anywhere else. But we're using static web apps, which means we want the web app service to handle everything for us. So it's worth doing it this way. So it starts by just saying what your data source is. Mine's a SQL Server, and I make sure that I'm reading from an environment variable because that's what I'm allowing for static web apps to inject into my container when it's all said and done. And then down here, it's nothing new. It's just a list of the tables that I'm using. So first I have like the actor table, and then down here I'll have the character table as well, and a couple of other things because there's a whole schema here, but we're just interacting just kind of for fun to show off how easy it is to build a data API on top of your database using static web apps. Okay, so what have we done so far? We've built the repository, and then I'm going to go into Azure in my portal, and I'm going to create a static web app service. It's free. I just go in and create it. And the first thing I do as I'm going through the creation process, it asks me where my repository is and automatically creates the GitHub actions that will take the code I put into it, into the repository, and move it into static web apps. In fact, let me just say that again. Nobody puts files into a static web app. They instead put them into a repository, and then the actions move them in for us. That's all handled for you. It's automatic because static web apps injects and adds these actions for you in your repository. Okay, now what do we do? Well, what's awesome is we go into the static web app and we configure it. There's only one thing to configure, Frank. There's only a single thing you need to do. So if you create this is mine, a static web app. You can go in and there's a tab down here or an option down here on the left that is the new database connection feature. And if you go in there, all it really asks you is to create, and I've already done it right here, you can see it. All it asks you to do is to create basically all the information for your connection string. It takes all of that information pointing to any database like Postgres, SQL, MySQL, or Cosmos that's in Azure database. And it takes all the connection information that you need and stores it safely inside static web apps. The reason it does that is so you don't put your connection string all inside your repository where you would never want to put your secrets, right? It keeps it safe inside static web apps. So now I have my JSON file in static web apps. I have my connection string in static web apps. What happens next? Nothing that I need to do. Everything's just handled by static web apps for me. And what happens is it automatically deploys the container it automatically injects my connection string and sets it up and invokes DAB to be my new data API on top of it. So here's my API, completely handled, by the way, because of static web apps. And now it is the thing that's talking to whatever my backend database is. And that cool client that you just created, Frank, that guy talks directly to my API and interacts with, just like you said, either a REST API or a Graph API, whichever one you want. And it's not a choice of one or the other. You get both. It's pretty neat. It's pretty neat. What do you think?
I think I really like it. It's very useful, very easy. And since it goes so fast, we still have plenty of time to go back into the code. So let me share my screen here. So now let's switch to the .NET side of it. So I'm in Visual Studio Code, where I built that Blazor application I was showing before. And you show different API. And I want to show for I'm using for the GraphQL, I'm using a specific query here. Like here, we can see it. I created a folder, and I use. I want to say the name correctly. So Strawberry Shake for Blazor, and it's a very good component. I really like it.
That's right. It's actually worth pointing out that Strawberry Shake is the same group that also makes Hot Chocolate. So Hot Chocolate is the framework that we use inside Data API Builder to expose it from the server, so you can have a graph endpoint. Strawberry Shake is what you would use on the client side to interact with that graph endpoint. Makes it super easy to use.
Indeed, it was. Like, now I understand way better why it works so well. So let me show you this page I create using the Graph API, and it's very low code because Strawberry Shake create for me, based on that schema of the API, create for me objects. So I could just say, hey, Star Trek client, and I ask, give me the character by series, and that's it. Everything was created for me, so I could just use it. So with dependency injection, I had a reference to the schema those classes created. Now I could use it in my code, and here it is, like very basic looping through creating that table. That's for GraphQL. That's pretty neat. And I did show you also I use REST. So same thing, same table here. I'm looping through. It's a little bit more code for REST. Let me just show here a little bit more code. So for REST, because there's no relationship between the entities, the table, I had to make 3 queries. So we can see here I have series, I have character, and I have that relationship table that you create in your database. So I did that, and after that, I could have been more eloquent at it, but it works. So like a bunch of loops and if to rebuild that information and then display it. So it was very easy to consume, and now I could deploy that website somewhere in Azure. So consuming the API, very easy to use and very simple. And I had a lot more time to focus on the app instead of like building an API. Database API are like very straightforward. So a tool like Data API Builder is fantastic for that.
Yeah. And it's just one of those things that's meant to be, well, it's just meant for developers. It has a lot of developer tooling built into it. We talked about Hot Chocolate and Strawberry Shake. It also has Banana Cake Pop. All these names are so hilarious, but it's almost like the swagger that you would use for REST. Banana Cake Pop is that for GraphQL, and it's right there so developers can interact with it. We have open API caching and a lot of other features that really a lot of enterprise endpoints demand before they even get started. So it's really a great tool. It's open source. You can go to the repository if you'd like to and just review the code, download it, get one of the latest releases, or just point to the container and use that container, or use it inside static web apps like we did here today. It's such an easy thing to get started with. You could have a POC done by the end of the day, showing your manager how cool this is and the direction you want to go from this point forward. So it's a really cool thing to say that you've taken almost a third of the code base out of your solution and made it so much easier to use. So Frank, it was cool to put this together. It was neat and fun to work with you about it. And thanks for letting me show off DAB.
It was awesome. We'll put all the link in the description so you could start looking at it. So thank you for watching.
Thank you so much to Jerry and Frank. I thought that was such a great session. We're going to bring them back later today. But after listening to that, I am definitely hungry hearing about all the strawberry shake and pudding and everything like that. But before we bring them back and learn about additional things from them from Data API Builder, I am curious to learn about logic apps. And so I'm going to bring on Kent. Welcome.
Hello.
How are you?
I'm doing great. How are you doing?
I'm doing awesome. Thanks so much for joining us.
Yeah, happy to be here.
Yeah, all right. I'll let you take it away.
Cool. So what we're going to talk about today is .NET extensibility in Azure Logic Apps. My name's Kent Weir. I'm a principal PM manager on the team, and excited to share some of our existing capabilities, but also have a few announcements / teasers to share with you all as well. So let's get right into it. So I'll just spend a couple minutes just talking about Azure Logic Apps, just in case some people may not be familiar with it. But Azure Logic Apps is a low-code, cloud-based workflow tool for automating workflows and integrating your business processes across hybrid environments in a very visual manner. And so typically our programming model looks like this. We have events, things that happen that prompt a workflow to be initiated. And then within that workflow, we've got a series of actions that allow you to perform a set of instructions. And you can really think of this as a visual workflow like that can coordinate many different activities across different systems. And naturally, as you interact with these different systems, there's output data that you can subsequently use downstream in further actions. So let's just take a quick look at a visual that might help describe this. So this is a workflow. And what we have is a series of building blocks. And these building blocks are largely related to connectors and then some internal built-in actions as well. So at the top, we have a trigger. And in this case, this is going to be a service bus trigger that is going to listen for messages that arrive inside of a particular queue. When that message arrives, then it'll go ahead and fire up this workflow and then do subsequent processing. So there's a few different modes in which these workflows can be initiated. This is more of an event-based approach, but we also have a schedule. So every 6 a.m. on a Monday morning, go perform a set of steps. We can go ahead and do that as well. And then there's also manual. If it's an HTTP request, that is another sort of popular way to invoke a particular workflow. We then have what we would call these flow control actions. So these are sort of your typical constructs that you would see inside of your coding environment. So things like looping, if then else, switch statements. In this case, we've got some parallelism going on, and we also have some scopes. So, if you're familiar with your try-catch semantics in your favorite programming language, you can kind of think of it much like that. Beyond that, we also have support for VNets and private endpoint support. So if you need to go ahead and call on premises services, you can go ahead and do so securely over a VNet. And then we also have two modes in which these workflows will run. One is in a stateful mode, which is a durable, reliable mechanism where we checkpoint after each of these actions. And then there's also stateless. So if you want to squeeze out a little bit more performance, better in some low latency scenarios, perhaps request response, where you might have a user waiting on that execution, that might be a good opportunity to go ahead and use stateless. And then last but not least, we do have a full audit log inside of a run history. And really that is just a replay. It basically shows you step by step exactly what took place as part of your workflow orchestration. All right, so that's with that out of the way. Let's get more into the core topic here. So low code is great, and we're proud of our low code nature here. Our driver is really how we can democratize building out these workflows and how dev teams can scale by bringing more people to the proverbial party so that you can go ahead and do more. But naturally, there's some situations where you do need a little bit more control or a little bit more power. And that's really where this whole extensibility story begins, because you can now complement your low code efforts with code in this case, .NET. So, and I'll get into a live demo here shortly, but just a little bit of background here. So in October of last year, we did GA our custom code extensibility for .NET Framework. And you might be asking, okay, well, why .NET Framework? And really the initial driver was we have customers that are using an on-premises middleware tool called BizTalk Server, and that is all built based upon .NET Framework. And certainly for those customers that have built some extensibility in BizTalk, we want to help those customers move to Azure Logic Apps. And so we built this feature that allows them to bring some of those custom code investments along for the ride inside of Azure Logic Apps. Now, what we did to achieve this is we introduced a new Logic Apps workspace project type. And you can see that represented here at the top. That is a workspace. And we have a tour, and you'll see that when we go into the demo. But we create two projects, one for functions and one for Logic Apps. And so this function project is actually an Azure function project that you can go ahead and write code inside of this VS Code experience, and then be able to go ahead and compile this code, and we will bin place it inside of the Azure Logic App itself. When the assembly is generated, this built-in action will allow you to select the code that you've previously authored, and then be able to go ahead and call it right inside of your Logic App workflow. So once again, it's a little bit of best of both worlds. Take advantage of low code, drag and drop, and then tap into your custom code when needed, and then be able to, jump back into the workflow and use any of those outputs from the code call in downstream actions. Now, certainly one piece of feedback we did get from customers, okay, this is really cool, this is great, but if I'm not a BizTalk customer, can I get this in a newer .NET version? And the good news is we have been working hard on .NET 8 support. I was hoping to be able to show it today. We just ran into a small issue, but do look for that shortly. The experience is going to be exactly what I show you today. The difference will be that it's actually .NET 8 under the hood, but that is just something to be aware of. Now, in terms of when would I want to use custom code in Azure Logic Apps? So here's a few reasons that I can think of, and certainly talking with customers, these tend to rise to the top. The first is business logic. You might have some complex business logic that doesn't lend itself very well to that visual editor, where you might have a whole series of if then else, if then else, if then else, switch statements, calculations, etc. It might be just better suited for being able to write in code, be able to then go write tests against that code, have it a little bit more testable, and that's a perfectly valid use for custom code. We do have a data mapper, which does allow you to transform, dot messages, say like a JSON message into an XML message, or vice versa. But sometimes people like to write that inside of custom code. Once again, there might be some testability needs that they're going after, or they just feel more comfortable writing that in managed code versus using XSLT 3. And so sometimes people will use an Azure function for this separately, and now you can include this in your workflow project itself and have that code sitting closer to your logic. We've seen situations, even though our traffic is all encrypted when we think about TLS and things of that nature, but sometimes people want more message level encryption. Maybe there's some third-party libraries that they use, like Bouncy Castle or PGP, and they want to do more message level encryption as well. And that's an opportunity where you could go ahead and use this custom code experience. We do allow you to include compiled DLLs like that you reference, or NuGet packages. And so you can take advantage of some of those libraries that might exist. On a similar vein, encoding and decoding is also an opportunity that people will use this capability for. Now, the next piece is a little bit interesting in the sense that we do offer a custom connector experience. And you can use this in a similar manner. So I'm not calling it a full-fledged custom connector just to avoid any confusion. But you can go ahead, if you had some maybe REST calls that you wanted to go ahead and build that out, or maybe you needed to do some sort of protocol connectivity with some message queuing broker or something along those lines, you could go ahead and write that code and then expose it through an action like I showed you on the previous slide and use it kind of like a connector. So, that is an option and something that you could potentially explore. And then last, but certainly not least, reusability. So that notion of like, hey, we've got common libraries that do certain things. And whenever we're building a Logic Apps project, we can go ahead and include those components and then make sure that they're being reused across our dev teams. So those would be some of the reasons that you could go ahead and do this. So let's get out of the slides. And what I'm going to do is take you through kind of like a hello world experience with respect to VS Code and a demo. So let's just open up a VS Code. Now, I guess for folks that may not be as familiar, we do have an extension. It's called Logic Apps Standard. And this is going to unlock a lot of this capability for you. We do have some other prerequisites, but when you install this for the first time and you run it, you're going to see a prompt in the bottom right-hand corner that's going to ask you for permission to go get all of these dependencies. And we will take care of all of that for you. And it should be a pretty harmless experience. Take a few minutes and you'll have your development environment all set up. So now what I'm going to do is I'm going to head over to the Azure A here. And once you've got that extension installed, you can go ahead and click on this Create New Logic App Workspace. And when you do that, what we're going to do is run you through a little bit of a wizard. And that wizard is going to make things quite simple to get this sorted out, to get this set up. So I'm going to create a folder here. So let's just call this Net Day. And we'll select that particular folder. And now this is that wizard that I was talking about. So I'm going to be asked for a workspace name. And this can be whatever you choose to call it. So I'm just going to call this Net Day Workspace. Then I've got two options here. I've got Logic App with Custom Code Project or just the Logic App without the code. Now, in this case, I'm going to select the Custom Code Project. When we get into this .NET 8 world, what you're then going to subsequently see is two options. You're going to see .NET Framework 4.7.2 or .NET 8. And really, you'll have the opportunity to choose whichever one makes sense for you. Now, the sample that we do provide just as a kind of some boilerplate code is just related to weather. So I'm going to call this function get weather. I'm going to be asked for a namespace, and I'm just going to go ahead and choose Contoso. And then as part of this onboarding experience, we also create a workflow with you, a sample workflow. In this case, I'm going to choose a stateful workflow, and I'm being prompted for a name. So I'm just going to call it my workflow. And we'll open it in the current window. All right, so let's just take a brief tour here. This is the workflow, but let's close this for now. We have that workspace file that I talked about. We have the functions project. And let's go ahead and just open up the sample file that method that we create for you. So what you'll see here is, this is an Azure function. We do have the function name decoration here. We do have a specific a trigger that we actually wrote and that we include as part of this a NuGet package, and it's called Workflow Action Trigger. And this is what allows this code to basically respond to that custom or to that code action that we saw in the workflow itself. So this is something that the Logic Apps team has done specific to unlock this particular scenario. Now, the other thing to be aware of, we do support a variety of, different inputs and outputs. These are just samples, right? So I've got an integer of a zip code coming in. I've got a temperature scale coming in. Is this going to be Celsius or Fahrenheit? But I can also take in complex objects as well. So I'm going to, in this case, return a complex object of weather. It's nothing too complicated, but it is a complex object. And then here I've just got essentially some random code that's written here just to show some variability in terms of what we're trying to do. So this is what we would go ahead and execute. And what we will also do to simplify the ability to call this code is we do include some build tasks. And so you'll see in the csproj file, we've got some specific build tasks that will take our compiled output and then go ahead and deposit them or bin place them into a folder in the Logic App project. So we wanted to keep the Logic App project very much intact to its current structure. And this idea that you've got this function project that you'll compile it, then we'll bin place those files in the right folder in the Logic Apps project itself. Then I think probably what we can do now is let's go ahead and just compile this code, and then I'll be able to launch that workflow for you. So we'll just go ahead and do a .NET restore. And then a .NET build. And then what we should see is this folder being updated here quite shortly. Okay, so that build took place. We'll now see a custom folder that exists. Now there's kind of two pieces here that are quite important. We will create this function.json. This is essentially like metadata that describes the function that we just authored. So it's going to have all of our inputs and outputs. And this will be quite useful when we get into the workflow and we're getting asked to go ahead and provide inputs and what is the expected shape of the output that code's going to return. So this is an important file. And then the other thing is we've got the actual assembly and all of its related dependencies as well. So what we can now do is we can go ahead and open up this workflow in the workflow designer. And we see just this sample workflow that we can go ahead and get started with. Now, when we click on this particular action, we've got this dropdown. And this dropdown is really being populated from that function.json file. So we could certainly have more than one function inside of this project. And provided you've wired it up all correctly, when you compile that code, basically you'll see all of those different functions enumerated in this dropdown. So that becomes quite useful from that perspective. Now, the other thing to note is that it's automatically gone ahead and inspected and that metadata and has drawn these specific inputs that we need to go ahead and provide. Now, these are hard-coded currently, but it doesn't have to be that way. So we could naturally get them from the trigger, but we could also, if we wanted to just have a compose action, we can go ahead and just create kind of like a variable in this case. So we'll just call this zip code. And here we'll just go ahead and hard code a value here. But just to show you how this dynamic content works, we can now go in, click on this lightning bolt, and then go ahead and select our output. And that will naturally be passed as an input. Now, when it comes to going ahead and responding back to the original caller, at this point, it's taking all of the output from that local function, but that's just going to give us too much information. We can go ahead and provide a better experience here, and we can just construct a JSON message here. So we could just say current weather. And now we can go ahead and use the outputs that came from our code. So here we've got different properties that were part of that output. So we could go ahead and just say current weather from that perspective. So now we've gone ahead and we've saved our workflow, and we can go ahead and use our debugger in this case. So let's go ahead, let's set a breakpoint. It doesn't really matter where. That's in our code. We can go ahead and set a breakpoint inside of our workflow itself. And now what we can go ahead and do is just start the debugger. So we're going to go ahead and attach to the Logic app first. And this will take a few seconds to get wired up. And then what we can go ahead and do is attach to the .NET debugger as well. All right, we're good to go. We can see we've got that URL, and we can also see that our workflow action trigger has also been loaded up. So now let's go ahead, connect to our code, and that is wired up. We can launch this by heading over to our workflow, clicking on overview. And here, basically, we've got like a little bit of a management experience going on. So here's the endpoint URL. If we wanted to call this from Postman, we could, but we can also just go ahead and click on this run trigger. And now we're in our debug experience. So we can step through this line by line by hitting F10, and naturally we can hit F5 to complete the execution. And if we head back over here, we can see that it was successful. Now, I talked about that audit trail before, And this is an example of that. We can see exactly the inputs that were passed in, and then we can see the outputs that were also returned as well. So that is the sort of first demo. Now I'm just going to jump ahead a little bit just to talk about our portal experience. So once you've gone ahead and deployed this to Azure, then it's one of those things where, okay, now what would this look like inside of Azure once it's been deployed? So let's just head over. This is a different project that I've previously deployed. And if we go into this artifacts folder, and then we've got assemblies, we're going to see basically the DLL and its prerequisites already here. So it's called get weather as well. And then we've got those existing, let's close this out. We've got those existing prerequisite DLLs that it would have brought along for the ride. If we go ahead and look into our designer, we also are going to see a similar experience to what we saw inside of VS Code. Now, the difference here is that you're not going to be able to author the code. You could go ahead and configure the code. Like if there was multiple functions, you could go ahead and select a different one. You can change the way the inputs and outputs are used, but naturally authoring that code is going to be inside of VS Code at this point. But I do have something coming just related to the being in the portal and being able to do some .NET. All right, now another piece just to talk a little bit about is just logging and sort of how can I take advantage of logging. Now, when I'm in the local VS Code environment, we did have some of those log statements that you may have noticed here, right? So we do instantiate a logging factory, and then we can go ahead and use the logger to log information, warnings, errors, etc. And so that's something that you do have control over. And when you're in terminal, you can actually see this data being captured. So in this case, we did pass in 85396 and Celsius, and that was logged, and we have access to that naturally as well. Okay, let's see. So there's another sort of piece to talk about here. And that is just, the relationship with application insights. And I don't have a full demo here, but just wanted to call this out because it is quite important as well. So obviously inside of your code, you can go ahead and, have your exception handling in place. And when an exception does occur, and provided you've got application insights enabled for your logic app, this information will be passed over to application insights and will land inside of the exceptions table. So you'll be able to get some additional verbose messaging here by looking at the exception that is captured inside of that table. Now here, I was trying to make this fail, so I just threw a new exception. You can see that it would happen on line 32, and that actually is captured here. And this is my exception. Was the custom message that I had provided as part of that. So that's something that does come up from time to time, is how do I sort of see what's going on with my custom code once it's deployed, and this would be certainly one of the ways that you can go ahead and do that. All right, so now just to talk a little bit about something else that we do have in flight as well. So previously we've talked more about managed code, and it has been designed for more advanced customer scenarios, and it is dependent upon VS Code, as I mentioned, for that authoring experience. Now, we still have a large user population that does use the workflow designer inside of the Azure portal. And technically, this would work in VS Code in that designer as well. But predominantly, we see this being used inside of Azure portal. And so this would be the opportunity to go ahead and do some scripting. Like in my opinion, this is one of those things where you need to write a few lines of code to do some parsing or some transformation. This is a good opportunity where you don't have to sort of worry about some of those other dependencies of using VS Code. But if you're writing more than 20 lines of code, you should probably be in VS Code and do it using those particular tools. So we are introducing, and once again, this is will be out pretty soon as well, like definitely this spring, where we will include scripting support for C#, and then also scripting support for PowerShell as well. And so these would show up inside of a connector-like experience. So you would, add this connector, and then you'd have a small window that you could go ahead and write some code. The code that you do write gets stored in a separate file. If it's a PowerShell file or if it's a C# file, and that gets stored inside of your folder, inside of your project. So that's something that you can then put into source control, and sort of manage it from that perspective. We will also support dynamic content support. So, for example, if you had inputs from your trigger and you wanted to use them inside of your C# code or your PowerShell script, you have the opportunity to do that. And same thing downstream, like if you have a response and you want to use the response from your C# script, you also have those abilities as well. And certainly, especially in the case of PowerShell, there's going to be some existing libraries that you may want to go ahead and leverage. And so we will allow you to go ahead and do that. Similar to what I showed you previously in that assemblies experience inside of the Azure portal, the ability to go ahead and upload those so that you can then go ahead and reference them is something that we will also support as well. All right, so I did want to leave you with a few different, links that will help you stay up to date with Azure Logic Apps. The first one is our Azure Integration Services blog, and this is aka.ms/Azure Integration blog. All of our major product announcements are made here. So if you want to keep up to date, this is your best place to go ahead and to do so. Now, naturally, that can be a little bit busy at times. So what we do every month, on the first Monday of the month, we go ahead and put out a newsletter also on the blog. And we do call this the Logic Apps Aviators newsletter. Aviators is the name of our community. And this is where we will summarize all of the product announcements. And also, we will go ahead and highlight our community members as well. So each month, we do have our ACE Aviator, who's someone that we recognize for doing some great work inside of the community. And then we also have a community section where we go ahead and highlight blog posts that we do discover, each month as we're sort of scouring social media. And the best way to be discovered is that hashtag Logic Apps Aviators hashtag is the best way to get noticed. And then the other thing that we do is Logic Apps Live. This is part of the Azure Developers Community Stand-Up Series. And this takes place on the 4th Thursday of every month at 11 a.m. Pacific. It's hosted live on YouTube and Twitch, and it is available on demand after the event. So we just had ours last Thursday. So go ahead and check that out. You can find it at aka.ms/LA Live. And during these sessions, we also dedicate a good chunk, probably 15, 20 minutes for live Q&A. So that's another opportunity for you to get in touch with the product group and provide some feedback. So with that, that's what I had planned today for my session.
Thank you so much, Kent. Yeah, that was super awesome. Always plug in the community stand-ups. These have been so much fun to watch the teams share the progress that they've made, all the updates, and really connect with the community and get that back and forth question, answer, and feedback.
Yeah, awesome.
All right, I will just mention this is the community. And so this is the developer hub that I mentioned for Azure. So this is a segment on the community and the great things that we have. And so there are live streams that happen quite frequently, several times a week, because all the service teams have their monthly live stream. We also have a Twitter or X, LinkedIn, lots of different ways to connect and get Azure resources. We also have lots of video series, and so you can see .NET on Azure has so many different videos where you can take what you've learned today and even expand it, because we have more videos in addition to what we're talking about today. So that's at that link right down below. That's the developer hub for Azure. So next, I'm going to bring up our new speakers who we've seen before today, actually. Let's welcome back Frank and Jerry. Hello, hello. Y'all are both muted.
Hello again.
All right.
There we go. We
that?
got it.
Terrific. Well, thanks, Hailey. It's great to be here. Obviously, we're here with Frank again. We saw Kent just before Frank, and then just before that, a couple of really great looking guys. That was really terrific. They're a little short on Azure's database data APIs builder. So really cool stuff going on there. And that's what we want to talk about a little bit right now, as a matter of fact. So one of the things we love, of course, about the direction that ASP.NET is going is the fact that we can build minimal APIs. We like that as developers and engineers because we're drawn towards simplicity. We like the idea of having something that is both easy to do and simple as far as maintaining our code base. And then, of course, we start thinking, well, we want to add another piece of functionality to our minimal API, and it gets a little bit bigger, right? We don't have a problem with controllers. We just really love things that are small. But then as we start adding best practices and security and logging and all the other things, we're like, wow, my minimal API is still pretty significant when it comes to code. The worst of it, though, Frank, is that what I'm writing is the same thing over and over again, right? It's the CRUD code of like create, read, update, and delete. That same code over and over again inside my data API. And so let me just talk about for a moment, just from an architectural point of view, the way we would think about.
Did you want to show some slide?
Yeah, sure, you bet. Way we would think about the architecture of just a simple API. And so this is about as simple as you could get. I've added an API manager, and I've also added authentication. So if we wanted to make this super simple, your client would go directly to your API without authentication. But let's just go with probably what you would do in an enterprise scenario and why each of these components really matters to you. You know that you have a database that you want to interact with, right? And so we're going to do CRUD operations. We're going to insert records. We're going to update those records. We're going to delete those records. But no doubt we're going to select those records to show in our UI as well. And so the reason we have this data API layer in the first place is to make sure that we aren't beating up our database in a way that isn't appropriate. So the first way is just to abstract things away from the database so that we can project the data in a way that perhaps we have a data marketplace and we're selling our data as a clearinghouse. That's really important. And so an API allows us to leave our database alone, but still expose that data, projecting the columns the way that we want to, projecting only specific tables the way we want to, as well as adding predicates to our queries to make sure that they only receive certain data rows as well. So we can do that by adding a data API without having to make any change to our database. That's nice. However, when you really boil it all back down to it, and you're a .NET developer, Frank, that C# that you're writing is the same thing with every project. So I go in and I'm writing my controller, or I'm writing my minimal API, and I just copy it from my previous project because it's the same code over and over again, change the table name, update the field names, and go from there. And I suppose if you're paid by the hour, that's really appealing, right? Because you just get to do so much extra work. But the downside is the more code that you write, the more opportunity you have for either it to be out of date over time because something has changed, or the opportunity for you to introduce a bug. So to make sure that you don't have a regression or some type of bug in your code, naturally, we would just introduce unit tests against it to make sure that my API runs the way that I expect it to run. All of this is just code growth over and over again. The handful of lines of code that you had to build your client now has doubled, tripled, maybe sometimes, depending on how you want to write your API and how many objects you have. The repositories that you've built, the frameworks you've had to introduce, and all of it is the same as the project before and the project before that. And you find yourself doing some copy and paste inheritance of some of the bugs that you had from previous projects into this project as well. Wouldn't it be nice if we could just take this middle piece out, this API circle, and just remove it completely from our overall architecture and topology of our solution, and still have the same capability, still be able to do things against our database, project the data, as well as advanced features like caching and security, claims management, policies, and all the pieces like that, without having to write it again. So that's the whole idea of why we talk about Data API Builder, because Data API Builder allows you basically to sidestep the problem, to look at it and say, listen, when I build the Data API, I build it awesome. And I build it with this feature and this feature and this feature and this feature, and so do we. This is a .NET engine that is implemented the way you would actually implement it, with all the exotic features and capabilities that you would expect, all container-based and cross-platform and language independent, where you don't have to introduce a brand new framework or anything else along the way. So that's really, really nice. And that's what I want to kind of talk about here. I want to just point out we have API Manager here. And the reason you have API Manager is because as soon as your API becomes significant, you need a manager to be able to make it so you can handle things like versioning or maybe even payload manipulation on the inbound and outbound, as well as advanced security that you might need depending on whatever your source of authentication is. All right, so that's at the highest level, and hopefully your solution looks something like this, right? You have your own components that you've added in other places, but at the highest level, those are the components. Now, Data API Builder gives us both a REST endpoint as well as a GraphQL endpoint, and we'll talk about the advantage of that today. And we'll talk about how REST is so easy and so common and so universal. We all know how to use it, built into the HTTP client. And calling it is such a straightforward thing, and we'll deal with that here in just a second. But we also support GraphQL. You don't have to, it's not a choice between one or the other. And we'll talk about why that is strategically valuable for a lot of UIs, a lot of clients. And even though you might still be using REST for a lot of the capabilities that you think about when you have a data API, at the same time, a more advanced data API might find value in a GraphQL. And we'll talk about that here in just a second. Data API Builder is really built for Azure databases. So we have SQL Server, of course, Azure SQL DB. We have Postgres, we have Cosmos DB, as well as MySQL, all hosted inside Azure. But if you want to be on-prem and you don't want to deal with Azure, or you want to host this in another competing cloud, that's totally fine. Data API Builder is completely open source, and you can use it however it is that you need to use it. In fact, it's not just one or the other. If you have multiple of these databases, you can have Data API Builder point to many of these simultaneously. So you don't have to choose between one or the other, cloud, not the cloud, whatever it is that suits you guys, and whatever it is that your solution is already using. You don't have to go and negotiate for a different set of technologies. You can just use it right where you are. You can have a plan perhaps to upgrade and know that Data API Builder will handle that upgrade for you as well. So that's really nice to know that the backend database is so flexible as well. All right, so let me show you something really cool. I can't get away from the fact that I love Star Trek as much as I do. So our database remains the Star Trek database, and it's really easy. And it's really great because it shows us all the different types of relationships and table types, and as well as data types to interact with as well. But we're going to do something very straightforward today and just try and list the series. So I'm thinking of all of the original series, the Next Generation, and things along those lines, right? So all of you who thought it was going to be The Force Awakens, that's the wrong franchise. We're talking about Star Trek. And so this is the table, nice and simple. It is the series table. And I want to show you the basics of creating the configuration file to set up a Data API Builder instance. So remember, it's container-based. This is not code generation. Not at all. It's not a framework or a NuGet package that you interact with in your code base. No, this is simply a container that you drop into your overall topology so that you can have that as your data API on top of your database. Then to configure that, you provide it a JSON file, the end. That's all that you provide it. And let me show you what that looks like. So I have let's see, right here, I have a simple example that I just want to show you how you would start with in fact, I have this right here. All right, so it's a command file called Star Trek, and it just shows you the two commands that you would use when you're starting to build it from scratch. So I want to just show you as little as possible so that you can really see that just getting off the ground and having a data API is ready right off the go. And so if you want to run this in Docker, if you want DAB CLI to host this so you don't even have to have a container manager like Docker, fine, no problem. You can use the DAB CLI to do that. And then where you deploy it is going to be up to you. Static web apps is something we showed earlier, but now you can also do it in ACA, Azure Container Apps, or ACI, Azure Container Instances, or AKS, Azure Kubernetes Services. And so look at this. So the first command is dab init. This initializes the configuration file for you, tells you that it's going to be a SQL server, and it also says what the connection string is. So in this case, I'm using an environment variable called my connection string, and then I'm saying that this is going to be a development environment so that I can have extra developer capabilities like Swagger, and we'll see in just a second, we'll have Banana Cake Pop. And so I'll add a single table. Remember, that's the series table. And so I'll add the series table. Here I'll say the source is dbo.series. That's just the schema plus the object name as well. It could be a table, could be a view, could be a store procedure, and it could be a container in the case of using Cosmos DB. But this is SQL Server, and we have to set up what the default permission. So in this case, of course, we make it as simple as possible with anonymous star. So star means all of CRUD is available, right? The read, create, update, and delete are all available. I could individually add access to each of those depending on how I want it, but it's as simple as possible. Now when I run it, it runs the command, and I want to show you the resulting piece here. So inside my one folder here, I have the configuration file that was created. It's really, well, let me scroll to the bottom just to show that it's 60 lines. Each one of those lines, then I only ran 2 command lines in the CLI, but it built all of this JSON, and it's a little bit tricky sometimes to get JSON right when it gets to become many, many lines. So it's nice to use the CLI to interact with it. I can both create it and update it along the way as well. And so let me just show what this is. I say this is the entity or the table view or store procedure I want to show. It's going to be called series, but I'm pointed to the object. That's from the same syntax. It defaults to table, so I didn't have to say that. And then in GraphQL, which is not what we're going to show here, but in just a second we will, it's called series or series, a plural. The plural of series is series. And then it enables it in REST as well. And here are the permissions. Nice and simple. Hopefully this looks easy, because it is. I provide this to the container, and from that point forward, the engine takes it and builds everything for me, all the endpoints, the dynamic controllers, and everything else along those lines. Honestly, the way that you would have done it, with the same telemetry and introspection around the graph, all the resolvers, everything is built for you, and it's really, really great. Now, if I were to run this, the CLI command is simple, dab start. It reads the command, it reads the config file that's built in, automatically deploys it, gives you an endpoint and a port. My dynamic port was 5001. So if I click on this, it'll launch. I launched it in another window here, but I'll show you. It launches a browser, and that browser takes me to the root where it says that it's healthy, basically that everything is configured correctly. And then I say API/series, and it gives me the list of all of the series, just like you would expect, already serialized, brought back as JSON, with the ability then, by the way, to add things like you saw in OData, that I could add things like, let's see, select equals name. So that would be an example. And so let me change that back to equals. And it is series, select with a $, select name. And what it does is, $, select equals, lowercase
how you know
lowercase s and select. Thanks. And it brings back just the name. So, right, this allows you to do some basic projection of your data without having to change your endpoint and without having to change your database. So, Frank, I want to just give you this kind of starter endpoint and see what kind of application you can build for us.
Just before I show the little app I had, we had one question, and I wonder if you want to answer it right now. So I was asking, how do you manage the database schema change in DAP?
Well, so there's a hidden question inside that, I think. So when the schema changes, obviously you're going to change your configuration file to match it. But what you might really be asking is, how do you change the versioning of your application so that you handle the schema change without breaking your API endpoint? And that's one of the reasons we talked about APIM, or API Manager, being present. So that allows you to basically surface up the same API at 2 different endpoints, but allow you to change the payload as it goes in and out based on whatever version that you have. So versioning an API, that is a difficulty everybody who has an API has. If you change the schema in the database, obviously the API must follow along. If you point to a series table, but you change it to be shows, you're going to have to update it to do that. However, you could still alias that to make sure that the entities all have the same name and the consumer of your API doesn't know that any changes made behind the scenes. However, if you want to change your API and version it, then you version it through API Manager so that you can have V1 and V2 and V whatever, or maybe based on date or some payload or header that you decide to do. All of that's handled by a manager for you. That's not what DAB does. Just like a minimal API or an API controller doesn't do that for you either, right? If you want to have version management, you use the tool for that rather than try and build a tool to do it for you. So I'm glad you interrupted me there, Frank, because that makes plenty of sense to answer. It's a common one.
Cool. So let's now switch quickly, just for 2 minutes on my screen. I created previous session. I built like a Blazor WebAssembly, and I wanted to do something different. So I did a console app, right? So .NET
Nice.
New console, very basic. And here you can see the code. I did not do dependency injection or anything, but like I'm creating a client here. I'm using the same address, localhost, because I'm running, like you said, in a container. My database is a container. DAB is in a container for me. So like it's all on my machine right now because demo. And after that, I just do client, get me from a JSON async, and I specify here a type, a class, series list. We'll get where that come from in a second, because then the serialization will be happening automatically for me. So that's great. And here I specify where I want to go. So I won't try to type your query because you had enough issues typing it. But if I had some filters, I could just do the same as you did previously. I could move this part, the API, like in my base URL if I want. Like that doesn't make any difference right now. Obviously, in a real application, the connection will be in some configuration or something like that. And that's it. After that, we'll get the result and loop through to show the names. Now, where this series list is coming from, well, I'll just create, again, same page because it's a demo, but I created a class called series with public and name, because that's what if I go back to the schema, that's what I had, right? I know the ID was a number because there's no double quotes, and name was a string because there was a double quote. So I did something very simple. And if we look again, sorry, I switched too fast. It was in an array called value. And that's why I created here a series list. I would say, well, like that's a list. I could have say array, but list is just easier in .NET. So you have so many tools that I love. List, I mean. So I use this, say value, and it works. So now if I maximize my console and I do a .NET run, and I'm scared to do any typos, even just .NET run. Come on.
Lowercase s on select. Yeah.
And voila, I have all the Star Trek shows that are in the database.
Nice.
So
and you know what? Perfect. And it's good to show this as a console. For one, it takes away all the complexity of extra pieces around the edges. This is the sort of thing you might deploy if you're writing an Azure function and you need to reach out to an API to use some of that data. There's a lot of good ways to have such a basic implementation. It shows up a lot of places. So Frank, let's take it to the next level though. So this is just a single table. Certainly we can interact with multiple tables, multiple endpoints with DAB. Let's do that, but let's do it in the fanciest way we can. So let me jump back over into mine and make a small change. So the biggest change that I want to make is just, well, for one, let me just remind us what we have here. So if I go back into our diagram, so we just accessed the series table, but what I want to do now is show all the characters that are in each of those series. So if you think about the original Star Trek show, we have Captain Kirk and Spock and Bones and things along those lines. However, some of those characters, including like Spock, is also in another series as well. So multiple series. In order for us to do that in a regular database, we don't have a regular one-to-many relationship. We don't have a many-to-one relationship. We have a many-to-many relationship. And in order to accomplish that, we need a cross-reference table in between two tables. And that's what we have here with series underscore character, right? You can see it has as its compound key a series ID and the character ID. That allows for a character to show up in as many series as you want. Now, being able to do this in REST is actually super tricky. Not tricky, it's more painful than tricky, because it means we take series and we expose it as the series endpoint, and we also take series character and we expose that as the series character endpoint, and then finally the character table, we expose that as the character endpoint. Doing that in REST means you'll call each of those at least one time. So you could start by getting all of your series like you demonstrated to us, Frank, and then you call and find all of the characters in that series, or maybe you just get the entire table back and do some joining in memory, and then go and get either individual characters that match those, or you use, or you get the entire thing back if you know that the character table isn't gigantic. However, one of these tables could have 1 million rows in it, 2 million, 10 million rows. It's a database meant to hold data, so it could be really big. So that's not really the best way to do it either. So we know we have $select that allows us to project down to whatever columns we actually want to return. We also have $filter that allows us to add a where clause, basically, so that we can make it so that we return only the rows we want. But even that seems a little brutal, because there's an easier way, and it's through GraphQL. And let me just kind of show how we would do GraphQL here. So let me start by stopping Dab, which is currently running. I'll back up to my my second demo, and I have another command here that I want to show, and this is the command line that I would run. So, but like we did before, I run the initialization and I add the series and character tables, but that's it. I don't add that cross-reference table because Dab doesn't require it. Instead, what I add now is an update command to series that says I want to add a relationship called character. So this allows me to say series character, and it brings back all of the characters that belong only to that series. And then I say the cardinality of this is going to be many to many, right? So I indicate that to be many, and I go through and say which is the table. So this is my cross-reference table. We call it the linking object, and what the source and target fields are, so that we can identify how to relate those together. What's beautiful, and one of the reasons we don't have to provide too much information here, is because SQL already has foreign key constraints established inside the database. So Dab understands that. It's written by us. We're the SQL team. We know how to read SQL really well. And so we can make sure that this relationship is correct. Now, what's nice is, what if you don't have those constraints? What if you have two tables related together, but you've never set up their foreign key relationships inside SQL? That's no problem either. I can still set up the relationship in Dab here, just like this, and we will artificially, or kind of like behind the scenes, create it for you. Not by setting up a constraint inside your database, just by interacting with your data as if it were actually related. So a real neat capability allows you to give a real capable API on top of your data without having to change your database. All right, so let me just run this and just show what it looks like when we're done. And so in the second one here, let me just back out and show you that everything is still the same. I still have series here, but now I have a new property inside series called relationships. Of course, I can have more than one relationship if there were. This is the character relationship, and it's many to many, and goes through and basically just puts the JSON equivalent of what we put in the command line into the configuration file. So now when I say dab start, inside the new folder that has the updated config file, now it starts Dab for me, and everything is still the same as before, because this is additive. I've added on to what we had before. And so pulled over here. So let me just bring that down. So you can see it's healthy. And even though I know, well, let me just do it. So you can see API/series is still there. I can still get series, but I don't want to do that because this is the REST endpoint. Instead, I want to go to GraphQL and interact with the GraphQL endpoint. So because I'm in developer mode, it allows me to have Banana Cake Pop. So Banana Cake Pop, if you know what the Swagger UI is, and you think about what does the Swagger UI do for REST, it allows the developer to interact with it without having to use curl statements or anything else. That's what Banana Cake Pop is for GraphQL. It allows me to interact with it real easily. So look at one of the things I can do. I can write a query. This is the way a query looks like when I'm writing a GraphQL query. I can say query my series item name. So this is the same thing that I did before, right? So I'm running only the name. It's the same sort of projection where I pick what my properties are or what my fields or columns are, depending on the backend database. And it brings it back exactly the same. So that part's beautiful and what I would hope to get. Now, because of the relationship now, I can say character. And character then has items. And those items are basically the fields or properties. And I can ask for the name of a character, right? And so I'll clean that up to look nice and pretty. I'll run it, and you can see each one pulls back Star Trek and the individual characters as well in a single payload. So instead of the multiple repeating calls that you would have had to have done in REST, now in Graph, you can build your own query against those and have the relationships pre-built and identified so that whoever is the consumer of your data API can get back what they need, and they aren't constantly beating up all of your endpoints because they need to get so much data and because REST can only give you so much, right? This isn't a full OData implementation on the REST side of Data API Builder. So instead, we have GraphQL. Remember, it's not a choice between the two. You can use them both depending on what your use case is. So there you go. I want to give this to you, Frank. Now you've got a graph endpoint that allows you to make just a single call to get lots of data related to one another.
Wonderful. So let's switch to my computer. I was planning to type a little bit. I'll try to speed it up a little bit. So I want to put some difference. So again, same thing here. I'm going to build like a console application because with Strawberry Shake, my favorite NuGet package of the day, there's 3 NuGet packages that you could use. So in the previous session, I was using Strawberry Cake Blazor because I was in Blazor. There's the .NET Maui. But now, because I'm on a console application, I will be adding to my solution the Strawberry Shake server. So I do that. And then after that, there's 3 little commands that you need to use to be able to have the generated client, the GraphQL client, when you're using it, when you want to do GraphQL query. It's a mouthful. So first, you need to initialize saying .NET new tool manifest. That will create a config folder in your solution. And we'll show that in a few seconds. I just want to show all the command very clearly here. And after that, you install the tool, Strawberry Shake tool. Here, I decided to go local, so I don't pollute my computer, just that specific local folder. And after that, because right now I'm running against like a local database, like local API, I would say, sorry. I'm using localhost, but whatever is your database, you're setting your URL and say, hey, GraphQL init, and that will download the schema of your API. So now switching to the code, we recognize here a console application is mostly the same code that I did previously in Blazor. So I create a client here, just like this, getting the service from my library that was generated. I get the character by series, and then I loop through all of those. If I go back here, because I want to show a little bit more, let's go. If I expand the configuration, that's what the init tooling created. So it's installed the .NET GraphQL. I put my query here. I decided to put it in like a folder. I don't need to, but it's the same query that you were showing earlier, Jerry, in Banana Pup. I'm always his name. The configuration. So here I have the name of my client. I could have put a namespace if I wanted, and I have the schema that was downloaded with it. So with that, when I do my .NET build, it generates for me a client. And we say, where is the client? That's a big difference between Strawberry Shake version 12 and 13. And initially, I was struggling when building this demo because it was not reacting as before. That's why I want to spend time to explain it, is they change it to make it cleaner and everything. So if you're looking for your client, you won't see anymore the files there. But because it's built, if you go in the object in your .NET, I'm .NET 8, you have berries, and there it is. My client is here, so it's still generated for me. It's just now I don't specify output directory, and I won't be able to, well, like I could dig into it and like have fun with it, but like I won't see some output folder with the files. So if I run that again, should expect the same result in a less fancy way than Blazor, but I have all the series with the character.
Nice. All with a single call. So the API just does a single operation and builds the join statement back into SQL for you behind the scenes. That's really great.
So now, Jerry, I should get back to you so we could wrap up and not take too much time.
If you're a developer and you're looking at this, hopefully the light bulb has gone on and you're thinking to yourself, my code base can be considerably smaller now because I don't have to build so much of this repetitive code. I don't have to even have the unit tests. Think about your CI/CD pipeline and how much simpler your CI/CD pipeline is. And even more importantly, just think about how you can scale this now. And so everything is available to you. This is a free open source project that works with Postgres on-prem, works with SQL Server on-prem, in the cloud, MySQL, Cosmos DB. It's really up to you, the backend database. And this is not only platform independent, but of course it's also language independent because you're only interacting with an endpoint and only getting JSON back. This is a secure, feature-rich set of endpoints that you get for using this as well. And I just want to point out real quickly that this is an open source project, which means you're completely welcome to join us and contribute to it with us. And so that would be terrific. Here are some of the features that you get. We're about to go open. We're about to have, we're currently in preview. We'll be generally available next month sometime. And so that's pretty exciting to see that on the horizon for us as well. It's been almost 3 years getting here. So much engineering behind the scenes that we've saved you from having to do as well. And so here's where you can get started at http://dab. And so there's a lot of resources that you can use and kind of go back into. We'll just leave the core ones for the event today, but also the ones specifically for DAB right here that you can go and use. So Frank, thanks for kind of walking through this, starting so simple and then starting to use more advanced endpoints so that we can have, honestly, an easier code base for our client as well.
Yeah, it was very nice having you. So we'll stay in the chat if you have questions. We just want to let the floor to the next speakers. Hope you have fun with the strawberry shake and DAB. And people were wondering, Jerry, can you say the full name of Spock? I know I can't.
The full what?
The full name.
Spock's full name. Can you say Spock's full name?
That is the whole name. The Spock. He doesn't have a last name.
I don't know. Thank you all so much. Yeah, if you want to see more of Jerry, come back to the YouTube tomorrow where he'll have the community live stream for Data API Builder.
That's right. Thank you.
Yeah, thank you all so much. And yeah, tomorrow after Jerry's Data API Builder session, we will have a session on app service. And so that kind of cues us up into the next session, which will be on app service. But I do want to call out all of the links just one more time. All of the session links that you've heard about today, so Jerry and Frank's session and all the ones before that, they're here at the session links link there. Also, please join the Cloud Skills Challenge. It's a great way to take what you've learned and turn it into action and start practicing all the things that you're learning. So I'm going to stop talking and just invite up our next guests, which is Byron and Jeff. Welcome to the stage. Hello.
Hello. Hey, Hailey. Hello, everybody. Thanks again for having us. Very excited to do .NET Day today. And we're going to be talking gRPC. So from the .NET Day from last year, I think we demoed gRPC on App Service Linux. So today we're here back again with more gRPC, and this time showing it on Windows. And Jeff, I don't know if you have the slides ready to go, but this is basically just giving us an opportunity to talk about some of the infrastructure work that we do on the service side and how that reflects to features and support that we get to present for you, the customers that are ultimately running on this. So this whole thing comes, last year we did some work. This is also one of the cool things is how we use .NET in the service itself. So last year we talked about how we migrated all of the front-end infrastructure. You can think about it as the load balancer that is sitting in front of your application when you're hosting it on app service, so that you can run on multiple instances and not have to configure some other infrastructure yourself. We migrated all of that from using, old IIS HTTP.sys pipeline to using Kestrel and YARP-based routing on .NET 6. And that enabled us to then do the gRPC feature on App Service Linux. Now we've done another big platform shift, and that is we've moved all of the Windows-based hosting, what we call the worker VMs, over from Windows Server 2016 to Windows Server 2022. And that's big infrastructure work that happens behind the scenes that hopefully nobody noticed that it happened. But what it means is that we can then go and build additional features, like in this case, the ability to have end-to-end encryption and gRPC for app service windows. Jeff, you want to go to the next slide?
Yeah, sure.
Okay, so this is basically a question for you, Jeff. Like, what is gRPC? Why should I care about it?
Yeah, so if you're not familiar with gRPC, it's a remote procedure call created by Google, and it's used for high-performance messaging over an HTTP2 connection. And it does this by opening up a gRPC channel that enables different types of streaming scenarios. So you can stream from the client side, or you can stream messages from the server side, or both at the same time with bidirectional streaming. And because it uses protocol buffers to define the calls, you can also create these language agnostic implementations. So if you want to have a .NET server talk to a Python client or vice versa, as long as you have those protocol definitions on both sides, then you can send those messages.
And usually we contrast and compare gRPC versus REST, right? Those are kind of like the two ends of the spectrum. And why would I choose gRPC over, REST?
Yeah, so REST is more of a text-based approach that communicates over HTTP. It uses the classic request response model, and it opens and closes connections consistently. gRPC uses binaries to communicate over HTTP2. And because of this, you can enable these streaming scenarios. So if you have a lot of data and you need more closer to like real-time information, then gRPC is going to be a better option. So if you need that higher performance communication, maybe if streaming is a requirement for you, and also if you have control over both the client and server. So again, if you have those protocol definitions, then that could be your option. REST can be, a better option if you prefer that text-based communication, or if payloads just are less frequent, or if you don't have ownership of the API and you have to communicate through that way. Cool.
So to put it in a nutshell, if the output of the API needs to be human readable, go with REST. If you don't control if you only control one side of the equation, like you only control the client or you only control the server, go with REST. But if you have, those high performance, high throughput scenarios, gRPC is a better option. And if you want to have control both of the server and the client, then gRPC is also a better option. And I think one of the interesting scenarios that comes up a lot these days is, we need to AI all the things. And the canonical example of here's a chatbot, that is not a great scenario for REST, but it's a great scenario for gRPC bidirectional streaming, right?
Yeah, because you're going to have those messages coming in pretty hot, so you'll need that high performance.
Yeah, I think one of the things that comes to my mind is the amount it takes for the whatever it is you end up calling in the backend for the AI magic. That has an unpredictable delay on how long it will take to get you content back. And also it's unpredictable how big the content is going to be. So when you're thinking from the server side, do I need to chunk this? Do I need to send it in multiple payloads? What is the timeout? All of those things kind of like go away from you as a developer having to build that backend. If you can put it into this streaming bidirectional scenario, right? Because at that point, the client and the server are having their conversation, and results come in as soon as they're there. As opposed to when you're doing REST, you would need to do something like a 201 continuation. You would need to write a bunch of code to handle that async scenario, what happens when it fails, all of that stuff. And you still have the latency of the fact that you're polling, right? So if you miss that response on your previous poll, you're still going to have to wait until your next poll comes around to get data. So that's like a great example of where gRPC it's an awesome fit. Okay. What's next?
Yeah. So, how does gRPC actually work on app service? If you're familiar with the Linux version of this, it's going to look pretty much the same. You have to set 3 config settings. One is the version, setting that to 2.0. This is going to actually enable your app to accept these HTTP2 calls. And then you have to set the proxy, which is the second config setting that actually takes the traffic, the HTTP2 traffic, and then forwards it to your application. And then for Windows, you need to also set end-to-end encryption. This is a requirement for gRPC on Windows, as well as app service. And then, of course,
Can we talk a little bit more about the end-to-end encryption? Like today, when I don't have this feature turned on, all of the SSL HTTPS termination happens at the front ends. And then the traffic that's going from the front end to the worker, because it's all within the infrastructure that we provide, is not encrypted. And then the worker itself gets the unencrypted data and therefore processes it. But with gRPC requires it to be encrypted end-to-end, which means that now the SSL processing will need to happen on your worker. So that's a non-obvious impact that you will have when you turn this feature on, right?
Yeah, and so the proxy and the encryption kind of work together to really make it a full end-to-end call.
And you can also use the end-to-end encryption feature even if you're not using gRPC, right? Like those are independent.
Yeah.
Okay, and then we on Linux, I know that we support all four scenarios. Is it the same true for Windows?
Yeah, it's the same thing for Windows. Each call, which actually brings us to the next slide, which is the demo. We'll go over the unary call, the client stream, server stream, and the bidirectional stream as well.
Right, and I'm not a gRPC expert. You are the gRPC expert in the house, so you're going to have to explain to me what's the difference between a unary and a client stream, server stream, all of that stuff.
Yeah. So let me share the screen for a second.
So in this scenario, you're going to be showing us 2 different pieces of code, right? One is the server side, and if you remember when we were talking about REST versus gRPC, there also needs to be the client side. So I think as soon as Jeff can get the Visual Studio to share, we're going to start seeing those two things. And I guess also the other question I have is, do I care if I'm deploying it as a Windows source code application or a Windows container? Is it supported for both scenarios?
So right now, Windows container is not supported. So we'll have to be a Windows code app.
Okay.
Okay,
I'm
so
guessing the plan is as we get to GA, we get to the point where that is supported as well.
Exactly. Yeah. Okay.
So I'm looks like you have grpc-win.app.azurewebsites.net, and this is just using the browser as the client, and it has that message that tells me, hey, you don't know how to talk to gRPC, so therefore go get a client that does, right?
Yeah, exactly. So this is what we're looking at is the Windows application, the gRPC server that's hosted on app service. And, as you mentioned, the note says that we need to use a gRPC client to communicate with it. So we're going to pull up our client that we already have created. And with our local client, one thing to note before I run it is that it's pointed to that gRPC endpoint, creating a channel. So let's do a quick run, and we'll make this a little bit bigger for y'all. Okay. So this is just a simple application, a simple console app that just proves that it's making those the calls that we mentioned before. So first call is the unary call, simple request and response method. It's going to happen pretty quickly. It's a single message. The hello part of that string is actually a response from the server that's hosted on app servers.
Okay.
Okay.
And then we're doing this as a console app because it's like real gRPC. If you want to do it from a browser, from like you need to do gRPC web, which is a different protocol.
Oh yeah. You can also host a gRPC. You can host a client application, and then it will still make those gRPC calls to the server on app service. Okay. So the next one is server streaming, which is a little bit more interesting. And what's happening here is it's sending one request from the client to the server, and then it's actually streaming back the messages. So we're in the background, it's sending a string of those numbers, and then it's adding in the pound sign on the call back to us.
Okay, so if I were doing this with REST, I would need to do one call to initiate the process, and then do a 201 continuation, and then call on that until the server finishes processing and sending me back all of the responses. Whereas here, you just send one request, the request stays open, and then we stream from the server as the server processes, right? The thing that is not evident here from the demo is that the server could be taking, different amounts of time in between each one of those responses, but then they just stream back. There's no additional request to pull.
Yeah, exactly. So because we established that gRPC connection, which is pointed to the host application, and because we set the proper config on the hosted app, which we'll cover in a second, but the server can then accept the client calls over that HB2 connection, and then it forwards that call to the app, and then it comes back over that single connection with the response. Okay, well, let's go to the next call, which is client streaming. And you'll notice that client streaming acts a little bit different because in the background, it's streaming a string of names to the server, and then it's just coming back as one response. And that's why it took a second for us to see anything. That's all well and good, but I think the most impressive one is the bidirectional streaming. And here we are sending requests and responses simultaneously. The client is sending the string of names, and then at the same time, the responses are the hello part of the string. So it's able to print them out at the same time.
So again, like this is the perfect example for the chat application, right? Where you have communication going back and forth. There's processes going on the back end. You don't know how long it's going to take, and you don't have to write all of this logic to account for the polling, the retries, the connection, establishing connection, reestablishing the connection, etc. So that's kind of like where I think the scenarios shine. We do have a question coming in from Ravi. Let me see if I can pop it up so that we can see it over here. And this is the question about what about gRPC versus WebSockets? So I think this comes down to, WebSockets I don't think are going away. But gRPC is a way to do all of this stuff over HTTP2. I think that is more the question, right? Is HTTP2 versus HTTP1 and WebSockets. And gRPC is just the framework that lets you do that. hopefully that answers the question.
Yeah, exactly. It kind of depends on what your requirements are.
Awesome. So let's take a look a little bit at the server code and see kind of like what's going on.
Sure. So if we go over to the server code, first I'd like to mention the proto file. This is where you make all of the definitions. So if you go through the process of making a gRPC service for your first time, you're probably going to go to the .NET docs, and this is what I'm using. It's just a templated gRPC server directly from Visual Studio, and then I've just added a few more definitions that include the stream examples. So the server stream, the client stream, and the bidirectional stream. And this proto file needs to be the same in your server code, and then you need to add it to your client as well. Yeah, and then just a quick look at the service that includes the logic for those definitions. You can see here, this is where we're sending back the messages. Unary is the hello, the # for the server stream. For the client stream, it's that single message after it takes in the other string with all of the names. And then for bidirectional streaming, go all the way to the bottom here, and then it's that first part, hello, that you're seeing in the demo.
So this really becomes just an async await pattern, and you don't need to handle any of the complexity of the. I think I keep coming back to this. Is the difference between having to write all of that code to handle the continuation pattern on traditional HTTP requests versus just doing async await on a C# project, and the framework kind of like takes care of it for you.
Yeah. And other than that, there's no special thing to do in the program or file or app settings. You can just take it as it is here and deploy it straight to app service. And then, as we mentioned before, just have those 3 configuration settings in your web app, which I can show.
Oh yeah, so yeah, that's a good point. What you showed us right now is a server, which is what gets deployed to your web app. And then the client application is what's either running locally, or if you have a separate front end, that's where you would have the other gRPC client that is talking to this API.
Yeah. And in your web app, before you deploy to it, you just need to set, again, the version. So it can actually take HTTP2 calls, the proxy, again, so it'll forward that traffic, and then the end-to-end encryption. So just those 3 config settings, and then your web app will be ready to accept gRPC calls over HTTP2.
Obviously, deploying your code.
Yeah.
We have another question from Ravi as well, which is, will gRPC work over HTTP3 as well? And technically, it should. We don't yet support HTTP3 on web apps. It's something that's in the backlog and we want to do, but it's not there today. Okay, so we looked at, what is gRPC, how to do gRPC on top of app service. We looked at the client, kind of like the different scenarios, what's the value prop. And right now we're at the point where this is in preview, right? So the next step is we're going to take this to GA. Do you have, kind of like what the plan is there?
Yeah, let me go back to sharing the slide. Oh, there it is. Okay, yeah, so there's a couple of limitations that we have currently with gRPC. It only works for in-process scenarios at the moment. So you'll have to keep it on ASP.NET. So your app is going to run, within the same process of your web server.
Mm-hmm.
And we also have site activation also only works with HTTPS. So what we recommend is that you need to keep always on enabled in the config to prevent any scaling issues when only gRPC calls are running since site activation isn't yet supported with gRPC calls yet. So that's one thing that's coming. Out of process scenarios are going to be supported as well. So your app can run with different web servers, and then we're also bringing Java and Windows Java support and Windows container support. So you can expect that probably later this calendar year.
Awesome. So just to be clear, the Linux side of the house, that is GA, that is across all the different languages that we support, and you have the gRPC activation already there. On the Windows side, you do need to have something that is going to activate the app. That is basically what we call the cold start. That's the first request that comes to your app to have it, come up, start up, and be ready to serve requests. That is, we need that activation to be over HTTP today, and the plan is to take that limitation away so that it can activate over gRPC, so that you can have like 0 HTTP requests to activate the app. And then it only works with ASP.NET today on Windows, but the idea is to also support Java, which is one of the other major languages that we support on App Service Windows. And you mentioned the containers. Then the in-proc versus out-of-proc. What is the benefits of having the out-of-proc part?
Yeah, isolation. That's probably the main benefit. Or if you need to use a different web server like Nginx or Apache. Okay. Yeah, and then in-proc is you get the performance benefit of running it on the web server.
Right. But then if for whatever reason your process hangs, it hangs the whole web server. So for the scenarios where you might have those hybrid conversations where there's some part of it is HTTP, some part of it is gRPC, that's where you want to potentially separate stuff into out-of-proc as well. Awesome. After this, what's next, Jeff?
The last slide is missing. I think this might be the wrong deck.
Okay.
But that's okay. Yeah, so we have all of this, the demo code that we've prepared is on GitHub right now. So you can go and you can clone it and try it yourselves. And then we also have the instructions on there to do all of the config settings for app service.
And just because it's right before build, Jeff and I will be there at build. If you're coming or if you're watching online, we'll have another demo where this is happening as well, and you'll get to see all of the app service announcements that are coming up then. Another shameless plug, we have the app service. If you can't get enough of app service, we have the app service community stand-up that's happening tomorrow, and we're going to be talking about the GA of the automatic scaling as well as integration with the Azure load testing scenario. So it's all going to be about scale out and perf tomorrow. You can join us. You can find the link on the Azure Developers. So if you're on YouTube watching this, that's basically the same thing. And then, finally, you can also reach out to us on Twitter. Hailey, I don't know if I was supposed to do this, but I seem to be able to have the option to throw the banners from the community stand-up. That's our Twitter. This is controlled by the product team, so it's actually us answering and posting there. Other than that, I think we're ready for questions if we have anybody else that wants to ask us something. If not, we can hand it over to the next guys.
Awesome. Y'all are actually our final presentation. We saved the best for last.
Oh, sweet. Well,
yes.
Thanks everybody for hanging out. Thanks for having us, Hailey. It's always a pleasure to show up for .NET Day. And I think, what do we have next? We have Python Day coming up.
Yeah, we'll add another Python Day. We have lots of languages to do, so lots of different learning.
Awesome.
Well, thank you all so much for joining. This has been super helpful to know.
Thanks, everybody.
As a final call out, final call out before we end the day here, all of the great links are listed over here. Check out the Azure Developer Hub to find a bunch of samples, ways to get connected with the community, ways to find all the new resources that we're releasing. We are constantly coming out with new updates, new products, new features. And so that's a great way to get information on what's new for Azure developers. Today's agenda is listed down below, but that's also with all the session links. Anything that anyone referenced, including the GitHub repo that they mentioned in the previous session, all of that will be listed there in the session links link. Finally, the Cloud Skills Challenge is there as well. I've already seen a bunch of people have completed it, and we have, I think, 83 as of an hour ago, people who are working on their Cloud Skills Challenge. Keep that up. It'll be open for about a month now. Just a lot of opportunities to learn and try out .NET for Azure. Finally, last plug for the YouTube channel. You can find more information on it on the Azure Developer Hub up there. But yeah, community live streams are happening multiple times a week. You have the opportunity to connect with your experts who are actually working on the products themselves, ask them questions, figure out what roadmaps are happening so you can give feedback. They love hearing from you, and we love engaging with our community. We're super excited for all of y'all staying here with us today. We really appreciate the community. We appreciate your engagement, your feedback, and I am so appreciative. Please, if you could, let us know how you like the events. The survey's down below, and so your feedback is so important to us. With that, I just want to say a last final thank you to all of our speakers, all of our moderators, everyone who has helped make this happen. We are so grateful for you to be able to bring this to our community. And with that, I hope everyone has a wonderful day. Thank you for watching.